Academy of Engineering. On behalf of Chief Patrons of the event, Professor Dr. Manoj Ranjan Nayak, Founder President, SOA University, and Mr. J.D. Patil, President, Indian National Academy of Engineering, we extend a very warm welcome to our invited dignitaries, esteemed fellows, young associates, members of INAE, research scholars, and students to the Technology Conclave 2026 of Indian National Academy of Engineering. For those guests not familiar with Indian National Academy of Engineering, INAE was founded on April 20th, 1987 as a society under the Societies Registration Act and is a professional body located at Technology Bhavan, New Delhi. INAE comprises India's most distinguished engineers, engineer scientists, and technologists covering the entire spectrum of engineering disciplines and functions as an apex body and promotes the practice of engineering and technology and the related sciences for their application to solving problems of national importance. The former presidents of INAE include the stalwarts of engineering eminence such as late Dr. APJ Abdul Kalam, former President of India, Dr. Anil Kakotkar, former Chairman DAE, and late Dr. K. Kasturi Rangan, former Chairman Department of Space. In the year 2026, INAE has 1,033 Indian fellows and 112 foreign fellows on its roll, identified in 10 engineering sections who are elected in recognition of their personal achievements in engineering, which are of exceptional merit and distinctive eminence in new and developing field of technology. INAE has a three-tier interaction with engineering community through the fellowship members and young associates and also the student members. INAE undertakes several meaningful technical programs and events which have increased its outreach in the engineering and technological domain. The Technology Conclave is one such event organized since last year, which is aimed at involvement and participation of individual members so as to bring them under the umbrella of the Academy. For those joining online, I would like to give a brief introduction about SOA University. It is one of the most preferred and largest multidisciplinary research-driven and extension-oriented higher educational system in India, established in 1995 as a charitable society. The journey started from the modest Engineering and Technical College, ITER, with the approval of AICTE in 1996. SOA grew in stature and diversified into another discipline of study. Ministry of Human Resource Development, on recommendation of UGC, confirmed the deemed to be university status of Siksha Anusandhan Bhubaneswar on 17th July 2007 under Section 3 of UGC Act 1956. It currently comprises 13 constituent institutions and 18 advanced research centers over nearly 149 acres of fully Wi-Fi campus area. This event is organized by INAE and hosted by SOA University in association with AIC-SOA Foundation, IIT Bhubaneswar, IIMT Bhubaneswar, NISER, ICT, IEEE Bhubaneswar section, NRDC. We are grateful to have the sponsors of the event, SAIL, Danili, IMFA, OPGC, Excel, IFCO, NALCO, Silox, Aditya Birla, and DRDO. With this brief introduction, it is my privilege and honor to invite our distinguished dignitaries to the dais. May I respectfully invite Professor Damodar Acharya, FNAE Chairman, Advisory Board, SOA University, and patron of the event. May I also request Mr. J.D. Patil, President, Indian National Academy of Engineering, Professor P.K. Nanda, Vice Chancellor, SOA University, Professor Indraneel Manna, former President, INAE and Vice Chancellor, BIT Mesra, Shri Manoranjan Ram, Senior Vice President, Danili, and Professor S. Samantre, Dean IIT Bhubaneswar and Secretary INAE Bhubaneswar Chapter, to join us on the stage, please. Our chief guest of today, Dr. Ashok Kumar Panda, Chairman and Managing Director, Steel Authority of India Limited, is joining us shortly. As a symbol of appreciation and reverence, may we request the student volunteers to kindly welcome our esteemed guest on the stage by presenting a bouquet. To commence this august event, we shall begin the invocation ceremony and lighting of lamp, symbolizing knowledge, wisdom, and pursuit of excellence. May I request our esteemed dignitaries to kindly come forward for the lamp lighting ceremony.
Shubham kurutvam kalyanam arogyam dhanasampadah. Shubham kurutvam kalyanam arogyam dhanasampadah. Shatru buddhi vinashaya deepajyotir namostute. Deepajyotir namostute. Shubham kurutvam kalyanam arogyam dhanasampadah.
Thank you, distinguished guests. May I request everyone present to kindly rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you. Please be seated. Before we commence the program, we take a pause and remember a towering personality in the field of engineering and technology, Professor P.K. Dash, who unfortunately passed away on 19th November 2025. I would request Professor S.R. Samantre, Dean IIT Bhubaneswar and Secretary INAE Bhubaneswar Chapter, to kindly come on the stage and speak few words in his memory and honor.
Very good morning to all of you. It is said that the goal of life is not to live forever. The goal is to do something and create a footprint impacting life. This real example is Professor Pradipta Kishore Das, a great scholar, visionary and extraordinary human being. Professor Das was not only the individual academician or researcher, he was the institution by himself. The man with significant amount of energy, urge, courage, blended with humility, really created the environment for new knowledge dissemination, connecting nodes for transformation. Hunger for learning, one of the attributes he was always carrying forward. He has opened up a large space and ignited many young minds to face tomorrow's challenges and who have succeeded in serving society at large. The footprint of services to INAE was also with a great aspect. Professor Das was actively engaged with INAE since he became the fellow of INAE in 1998 for his outstanding contributions in power systems engineering. His leadership role in INAE, including chairing sectional committees and representing governing councils, reflects a larger footprint of his professional services to INAE. Possibly, Professor Das, he came to arts to inspire and ignite people who can really do extraordinary jobs, having significant impact and enable them to excel and grow. Sir, your touch will always be in your heart and ignite us continuously. Today, this August Forum of INAE is paying a heartfelt tribute to one of the outstanding scholar and academic leader of this country. I request all to go for a 1-minute prayer for this purpose. Thank you. Today we have Madam Sanjukta Das. She is here on our request we are here to give a tribute to Professor Das. So I'd request both the President of INAE and the former President to give a mark of respect on this occasion. So possibly Madam cannot come, so I'll request to
The Academy gratefully acknowledge his invaluable contributions to engineering sciences and education. May his noble soul rest in eternal peace. To formally open today's proceedings, it is my privilege to invite Professor P.K. Nanda, Vice Chancellor, SOA University, to kindly commence the proceeding with the welcome address. Thank you, sir.
Good morning, everybody. Jai Jagannath. Esteemed Chief Guest, Dr. Ashok Kumar Panda, CMD Cell, who is on the way, will join soon on the dais. President of this function and President of INAE, Dr. J.D. Patil. Chairman of International Advisory Board of SOA and Chairman of the Bhubaneswar INAE chapter, Professor Damodar Acharya. Former President of INAE, Professor Indranil Mana. Senior Vice President, Daniel, India, Sri Manoranjan Ram. Secretary of INAE Bhubaneswar chapter and Dean and PG and Research of IIT Bhubaneswar, Professor S.R. Samantrai. All INAE Vice Presidents, distinguished Vice Presidents of INAE, INAE Fellows, and all the members of the INAE, young associates of INAE, officials of INAE, Colonel Rai and others, scientists, engineers, researchers, authors, delegates, our university pro-vice chancellors, deans and directors of our university, faculty members, students, entrepreneurs, ladies and gentlemen, print and electronic media. At the outset, on behalf of the university, I extend a warm welcome to all of you to this two-day conclave hosted at SOA University. I am deeply honored to INAE for partnering with us and to host this great event in our campus. As far as the technology is concerned, I think entire evolvement of the human civilization, right from ancient age till today, technology, science and technology play a pivotal role, one of the few pivotal roles in the entire growth. Technology is one such visible pivot in that domain. There has been paradigm shift in our kind of the evolvement of the society, and to have a secure and also a respectable societal growth, technology is ubiquitous and pervasive in all sectors of life, and INAE plays a pivotal role in that. As far as the university is concerned, we also have started with the Faculty of Engineering Technology, and rather latter actually added a lot of interdisciplinary other disciplines as well. Technology is now uniquely positioned for in all sectors, all disciplines of our life, of our kind of the growth. And the global priority and the national priority also focuses on technology evolvement and technology growth. And therefore, the technology also is one of the aligned with the national priority of our country. Therefore, there are several national priority, evolvement of technology is one of them. And we have seen over the years, over the decades, how it has played a major role in transforming the global evolution landscape of our entire humankind, so also in our country. As for example, that artificial intelligence and quantum, which is upcoming in the way, it will redefine our own life, and this is also a boon of technology. And therefore, we have to embrace the technological advancements and changes for growth of our society. In that regard, this conclave actually is focusing on few of the national priorities. One is nuclear energy, We know the energy crisis because of the geopolitical situations of the world and the necessity to be Atmanirbhar Bharat in this domain. So therefore, this technology, this two-day conclave focuses on energy, nuclear energy, distributed energy resources, transportation and logistics, healthcare, which is another kind of the big national priority, and then next generation communication and others. Besides, also it attracts entrepreneurs who are engaged in kind of the creative solutions for different problems of the society. And this conclave encourages young minds to see, to delve into, to understand what are the importance of these kind of priorities. And we have all kind of these stalwarts in the field, invited top-notch personalities in their respective domain to share their expertise with the young minds and spark some kind of in their minds so that they will contribute to the society and also to the nation. As far as this two-day conclave is concerned, I am deeply honored that we have actually attracted people from engineering community, scientists, entrepreneurs, researchers. I think all the eminent personalities of INAE who would share their findings and the country's priorities in these lines. And therefore, I wish that these 2 days conclave deliberations will definitely spark in the young minds so that they will be definitely go ahead with the issues and the perplexities of this technology in the national arena. Therefore, I once again welcome you all and encourage to be engaged, actively engaged in the discussions, in the lectures, in the panel discussions, in the posters, and also with the top-notch scientists so that we will have a strong collaboration and vibrant impact and vibrant on these different issues where we will definitely contribute to the nation. This 2-day event will culminate in recommendations for future generations to actually pursue their career in different technological arena. I wish this will have a lasting positive impact on all of us. We will learn many things, and I am very grateful to INAE and also to our chairman INAE Bhubaneswar chapter Professor Damodar Acharya for hosting this in our university. Thank you. Once again, welcome to this campus. Jai Hind, Jai Jagannath.
Thank you, sir, for your gracious welcome address. It is now my privilege and honor to invite Professor Damodar Acharya, FNAE, Chairman, Advisory Board, SOA University, to kindly address the gathering.
Very good morning to all of you. In this INAE Technology Conclave 2026, we have here with us the President of INAE, Mr. J.D. Patel. We have previous President, Professor Indranil Manna. We have the Senior Vice President of Daniel India, Sri Manoranjan Ram. We have Professor Pradipta Kumar Nanda, Vice Chancellor of SOA University. We have Professor Subhrangshuranjan Samantaray of IIT Bhubaneswar. Also, we have in the audience our esteemed INAE fellows, INAE members, the entrepreneurs and innovators actually who have come here to show their innovations and technologies actually what they have developed. And we have distinguished faculties of SOA University, the host of this conference, Conclave. We have distinguished guests from different parts of life, and many are there who are really attending this thing on online because it is actually hybrid mode. So to all of them, on behalf of actually INAE Bhubaneswar chapter, I extend them a very hearty welcome to this conclave. Now this conclave is scheduled for actually next 2 days. And also, of course, I forgot to mention our chief guest, honorable chief guest, Dr. Ashok Kumar Panda. He couldn't really, he is actually on the way. His flight was delayed. He has just landed there and he is on the way. And he will be joining us very soon. Also, we had Dr. Ranjit Ratha, chairman and managing director of Oil India Limited, as one of our plenary talk speaker. He also got delayed, and I'm really sorry to actually say that we'll be missing him. So in this conclave, we have several plenary talks, and plenary talks actually will be given by on nuclear energy and distributed small and medium-sized reactors. Very pertinent topic by Mr. Bhuban Chandra Pathak, former CMD of Nuclear Power Corporation of India Limited. He will be online. Plenary talk will be given by Professor G.D. Yadav on actually he is a Padma Shri awardee, and he is his topic is going to be on coal gasification, fertilizer, coal-based chemicals. He is a professor emeritus and former vice chancellor of ICT Mumbai. And incidentally, ICT is actually IOC is one of our partners in organizing all these things. We have plenary talk by Professor U.B. Desai. He is the Chancellor of Anurag University and founding director of IIT Hyderabad. Now, here in this conclave, our focus is definitely on energy security, how to reduce energy requirement, how to diversify the energy input. This thing actually will be all deliberated, and all stalwarts will be really presenting their things here. Apart from this, we have got actually series of panel discussion on very, very important topics. One is actually on the transportation and logistics, and we have also a plenary talk by Professor U.B. Desai, who is the Chancellor of Anurag University and founding director of IIT Hyderabad, the most very renowned actually professor and researcher on the next generation communications. Panel discussions are there on transportation and logistics. It will be moderated by Professor Manoj Tiwari, who is the director of IIM Mumbai. We have today several parallel sessions on here, and that will be related to it will have actually presentation by the INAE members actually who are present here, and also there will be next actually we will have pre-dinner talk three very eminent people actually will be speaking here in the pre-dinner talk. One is actually Professor Abhay Karandikar. He was former DST secretary and also the director of IIT Kanpur. Now he is a member of Niti Aayog. Pre-dinner distinguished speaker is going to be Professor A.B. Pandit, who is the Vice Chancellor of ICT Mumbai. We have another distinguished speaker, Dr. Binay Kumar Das, who is the Director General of DRDO. It will be also having a cultural program followed by actually dinner. Now, in the next day, we are going to have the plenary talk by Professor Santi Pavan on semiconductor technology, a veteran in this field. Actually, he is from IIT Madras, and he is Alexander Institute Chair Professor of IIT Madras. And most interesting part is there is going to be a panel discussion on healthcare technologies, and it will be organized and moderated by Professor Suman Chakravarti, who is the director of IIT Kharagpur. And of course, there will be parallel sessions on which there will be papers and poster presentation, and in the other side of this thing. Now, also actually there will be felicitation of newly selected individual members of INAE. Plenary talk is also there by Dr. Ravinarayan Patro, a real veteran in rare earth, and he was the former CMD of IREL Limited. And as you know, rare earth is actually the most important thing now, particularly in this is find actually so much of use in communication in our semiconductor technologies and even batteries. So this is actually going to be another very, very important thing. And finally, there will be actually one more actually panel discussion. It will be moderated by Mr. Sasit Sekhar Mahanti, he was former director of Cell and SR Steel. So it will be on the reduction and diversification of energy inputs in energy intensive industries, because as I have told you, our focus is actually on the energy in this particular conclave. So this is going to be another very interesting thing. Now, of course, it will be followed by the validity session, in which the chief guest will be Professor Santanu Chaudhary, Professor and Dean of School of Advanced Computing at Ashoka University. Then, of course, Professor S.R. Samantarai, he will be there in this thing. And from the INAE side, Lieutenant Colonel Shobhit Rai, with Deputy Executive Director from Indian National Academy of Engineering, it will be there. So this is actually briefly the program which we will have, and I'm sure the deliberations are going to be of very high order, and it will be really very, very interesting, and I'm sure the students, entrepreneurs, members, and even our INAE fellows and other distinguished guests, actually they will gain a lot out of it, and maybe it will set some sort of agenda for what to do in these areas for which actually we have selected. With these actually few words, I welcome you all, and we can really go ahead and have a very, very nice program here. Thank you very much.
Thank you very much, sir, for setting the tone for the conclave. Ladies and gentlemen, it is now our distinct privilege and honor to invite Professor Indranil Manna, former President INAE and Vice Chancellor BIT Mesra, to kindly address the gathering. May I request everyone to welcome Professor Manna with a warm round of applause, please.
Mr. Patil, President INAE, Dr. Ekipanda, the chief guest who will soon join us, Professor Acharya, Professor Panda, Professor Samtre, Mr. Ram, a galaxy of dignitaries seated in the audience, many of whom are actually our peers and mentors to many of us, including myself, the members who are going to get inducted in the fold of INAE very soon, ladies and gentlemen, science and technology is often regarded as the key driver for the economic growth and prosperity of any nation, and rightly so, because there's no denying the fact that in today's world, in the present era, growth always depends on the foundation of science and translated by the might of the industry as technology. Not because my first degree was Bachelor of Engineering, not because I'm very closely associated with Indian National Academy of Engineering, I always felt that in this very commonly uttered phrase of science and technology, there's a missing link. And this missing link is engineering. If science is all about the fundamentals and asking the question why, then engineering is the bridge which connects the fundamentals of science to the ultimate product and deliverables in the form of technology. So engineering is that know-how that actually translates the knowledge into viable solutions. And please remember, engineering is nothing but the answer to the societal aspiration for growth and development. In Indian National Academy of Engineering, we have a year-long calendar of activities, starting with the Foundation Day, the National Frontiers of Engineering, Engineers Conclave, and Youth Conclave, finally the annual convention. And yet the leadership, some years ago, decided to have a new chapter called Technology Conclave. Why was that necessary? Primarily for two reasons. If you look at the cross-section of INAE, Mimangsha at the very beginning presented before you the journey of INAE for the last nearly 40 years. We represent truly the most outstanding and distinguished individuals in the country belonging to the engineering domain as our fellows. The number is just about 1,000. For a country of 1 billion, nearly 1.5 billion, the largest and the youngest population in the world, which very legitimately aspires to be the developed nation very soon, the driver has to be the engineering profession. With having just about 1,000 individuals as elected fellows, no matter how serious we are, we can't make a huge impact and a difference to the society and the country. So INAE leadership decided to create a new cadre called membership. And this membership essentially will be drawn from across the disciplines of engineering. And they will actually be an order of magnitude greater in number than the fellows. So our ambition is to have 10,000 members of INAE in years to come and be the main foot soldiers of the academy to be able to strive hard and contribute to the growth of the nation. Now, we have to understand that the country today is poised for a big leap towards the future, and if that has to be successful and sustainable, then we have to find answers and sustainable answers in the field of energy, climate, transportation, defense, and in all other sectors. If you go by the internationally accepted indices, then India has a long way to go in terms of the Human Development Index, energy consumption per capita, innovation index, and very many others. And these differences in the society is going to be possible only when engineering truly plays the bridge between science and technology. There was one other reason why we wanted to create a new platform, and that's also to embrace the technologists, particularly from the industry. If you look at the overall distribution of the fellowship, nearly 48% of the fellowship comes from academia, about 22 to 24% from industry, and the remaining about 28-30% coming from R&D organizations. In the charter, we actually proclaimed INAE will be represented equally by individuals coming from academia, industry, and R&D, so approximately 1/3. So the representation from industry is less than what is desired. So there again, we decided that apart from having members, we also would like to place an emphasis on having not just leaders, but the true technocrats who will drive the developmental charter of the country for the future. So Technology Conclave, we are into our second edition. Last year, thanks to IIT Bombay, we had one such occasion, but mostly confined to the meeting room. But this time, we are very happy and proud that we are able to attract leaders from the industry, entrepreneurs, very many young individuals who have created startup companies, and they'll showcase their progress made, innovations created. We would also like to make a very special mention here that INAE caters to engineering in the most fundamental way. In the recent past, thanks to a very large funding coming from Infosys Foundation as through their CSR route, INAE has launched an initiative which is absolutely unique and like never before. INAE would like to mentor nearly 4,000 teachers coming from engineering institutions across the country who are governed by AICTE and make them equally competent and confident in terms of their teaching capability. The program is now into its second year, and I'm not sure whether faculty members from SOA University has already participated and benefited. Otherwise, I'll request Professor Panda to make sure that some of your young teachers join the CEEE program. CEEE stands for Center for Engineering Education and Excellence. And the idea is to reach out to institutions who are not as well endowed as the top technological universities in the country like IITs, and expose them the high standards of teaching and engineering so that they create the future generations of engineers who will drive the progress of the country. Before I end, I would certainly like to place on record our deepest appreciation to Professor Acharya, Professor Panda, for being very gracious host for the second Technology Conclave of INAE. Would like to also appreciate the role played by our own part of the leadership, led by none other than President Mr. Patil, Professor Shantanu Chaudhary, Vice President, and Cornel Rai and the rest of the people to have come up to this stage. We have a long way to go, and I personally believe that what defines engineering, if that has to be realized, then we need a wholehearted, synergistic, and all-around effort so that the country not only proclaims, but actually achieves the desired tag of developed nation. I realize that Dr. Panda has just joined. Welcome, Dr. Panda. We certainly would like to make a big difference to the major technological fields. Steel certainly is one of them. And I have reasons to make a special mention because by training I'm a metallurgist. And I know very well that why the country actually is keenly awaiting a major development, a significant change in the steel sector. We are a developing nation. We will continue to require more steel than what we produce today. Ever since I was a student, we have been hearing that by 2025, India will produce 300 million tons. We are probably halfway through or even less. But important fact to be noted is that we produce about if it's 150 million tons, so out of 2,000 million tons, you can imagine that we are certainly not much smaller than the mites of China. And India should produce, if not, why only 300, even 500 million tons of steel. But the important fact is that India's consumption per capita of steel is far too low than the even world average. And at the same time, we emit CO2 to the tune of the third largest emitter of CO2 in the world. So imagine if 150 million ton becomes 500 million ton, then the whole world will point fingers to us that you are emitting much larger amount of CO2 than what is permissible. So we have to find a solution. So the challenge here is that on one hand, a developing nation wants to be a developed nation. So we have to build very many more buildings, bridges, stadium, and infrastructure. So we need a lot more of steel. And if we continue to be totally dependent on carbothermic reduction, then we are going to emit much more CO2 than what we are doing today. So as engineers, it rests on us to find a viable solution. And we have been hearing about hydrogen reduction, but we are far away from implementing them in the large steel plants, whether under SAIL or Tatas and so on. So here is the challenge that awaits a very major intervention from the engineering community. And I appeal to the younger generation in particular, fellows or members apart, who actually should come forward and make a very large and sustainable contribution. So hoping that we are going to achieve that someday in the future, not too long ago, I wish all of you a very fruitful interaction during this conclave. Thank you very much. Jai Hind.
Thank you, Professor Manna, for your illuminating address. Ladies and gentlemen, it is my privilege to inform you that we are now joined by our esteemed chief guest, Dr. Ashok Kumar Panda, Chairman and Managing Director, Steel Authority of India Limited. On behalf of INAE and SOA University, we extend a very warm and heartfelt welcome to you, sir. We are deeply honored by your gracious presence at INAE Technology Conclave 2026. May I now request our dignitaries to kindly welcome the chief guest with a bouquet as a token of our respect and warm regards. Thank you, sir, for sparing your valuable time to be with us. It is now our pleasure to invite Shri Manoranjan Ram, Senior Vice President, Danili, to kindly address the gathering. Thank you.
Good morning, everyone. Respected dignitaries on the dais, ladies and gentlemen, and my dear students. Some of the students I'm finding here. I'm finding a little bit less energetic. I don't know why. So I'll give you some interesting topics, and I need maximum 9 minutes of your undivided attention. First, let me thank Dr. Acharya and Mr. Mahanti for inviting me to this INAE conclave. This is the second time I am attending a INAE conclave. I attended in 2021 in Jaipur, and today I am here in front of you. It is always a pleasure for me to deliberate on the topics related to the engineering and technology. And here I have my mentor, Mr. Mahanti. I have two mentors in my professional life. One is Dr. Sanak Misra, and another one is Mr. Mahanti. So, if you have seen the focus areas of INAE Conclave 2026, one area which caught my attention, and that is to engage academia, researchers, industries for engineering excellence in India. Engineering excellence in India. So on this context, I would like to highlight two topics. Because I am coming from an engineering and technology company, that is Danieli. Danieli Group is based in Italy. It's a more than 100-year-old company. And in the world, we are one among the three. There are three technology suppliers in the world who supply technology and the equipment to metal sector. Wherever you see a steel plant, we three are there. One is Danieli, second one is SMS Group, third one is Prime Metals. So we have the technology for the metallurgical industry, mainly in steel and also in non-ferrous as well. Fortunately, I worked in two. I worked 9 years in SMS, and now in last 4 years, I'm in Danieli. I started my career from Rourkela Steel Plant. 15 years I worked in Rourkela Steel Plant, then I moved to ArcelorMittal. I lived and worked globally. And the interesting part is that how the technology is closely related with academia and researchers and industry together. I'll give you a few examples. In order to create engineering excellence, in my view, is that we need to clearly focus on two areas. One is intellectual property, and two, how India can become the product nation of the world. Now the intellectual property, it starts from the indicator of intellectual property starts from the patent applications, because this is an academic institute, and many of the academicians are also here. Last year was a historic year for India. India received around 1.8 lakhs patent applications and local patent applications, and globally also from India around 4,500 patent applications were filed, which is PCT applications we call, that is called Patent Corporation Treaty applications. Now if we compare with China, where we start, we are 1.4 billion people, China is also 1.4 billion people. So we have filed 1.8 lakhs applications, China has filed 18 lakhs applications, patent applications. We have filed 4,500 applications for international patents, and China has filed 73,700 applications last financial year. So why is such a big gap? We are a young country, as Professor Manna has said, that we are a young country. Median age is around 28 years. India is producing annually 850,000 engineers every year. So why the patent applications we are falling so behind? The simple answer, anyone can say that we need to design our products. And product, what I mean, is not FMCG product. What I'm talking about is mostly the industrial machinery and plant machinery products. So we have to design our product, we have to develop intellectual property, manufacture locally, and sell to the world. And next obvious question you will ask that why is it not happening actually? Why is it not happening at a rapid pace? I thought a lot about this question. One thing comes to my mind is that maybe the complacency, maybe the chalta hai attitude acting as a barrier to the sense of urgency for product innovation. For example, as again I'll refer to Professor Manna, he raised a topic about steel. Today, we are producing around 165 million tons of steel. We have the capacity to produce around 220 million tons already installed in India. And we have been producing steel since last 100 years. And all of you will be surprised to know that we do not have a quote-unquote Indian technology who can give us iron making and steel making technology. The moment anyone wants to put up a steel plant, be it Steel Authority, be it Tata Steel, be it JSW, be it JSPL, ArcelorMittal, anyone, they always rely on the technology from outside. So don't you think that's something we need to ponder about? 100 years we have been producing the steel, but not a single Indian technology is available for iron making and steel making, which we can offer to the world. So now the question is, how can we develop technology? Every time in the corridors of government, when we go for some discussions, Secretary Steel or somebody, they always talk about, can you do technology transfer? And then, a question comes to our mind, why should we do technology transfer? We developed the technology. It is an Italian technology, it's a German technology, it's a Japanese technology. Why should I transfer it to India? So the question is, that means no one will transfer the technology to us. We have to develop technology in-house. Now, if you see that how we can develop technology, let's see how the developed countries, they have developed technology. Because without developing the technology, we cannot become a developed world by 2047. That's for sure, because otherwise, there is something wrong. So if you see that how it has happened, I'll give you 3 points. How it can happen. The first step is that public investment, massive public investment is required in research and innovation. The countries like Japan, UK, US, Italy, Germany, they have directed public funds to private sector and they have built world-class private companies. South Korean companies like LG and Samsung, they are the household name today. Now you come to Japan. Japan consumer display an extraordinary loyalty to their own products, extraordinary loyalty. And this cultural confidence helped Japan to produce multiple brands like Sony, Panasonic, Toyota are all household names. Come to China. China made exports as the engine of their growth. They have set up special economic zone funded by government and manufacture for global market. Many of you might be using iPhone. The technology in the iPhone, you will be surprised to know, many of the technologies in the iPhone was funded by public funds from US. But what is happening in India actually? In India, we are spending, means if you put all the R&D expenditure put together, it is less than 1% of the net sales of many major companies. Last year, India has spent total $15 billion in R&D. And last year, in the similar period, China has spent $1.1 trillion for R&D. So this is the difference. Now if I talk about my own company, Danieli, in which I am working, So one company, headquartered in Italy, also we are here in India, we are having 1,000 engineers in India. We have a manufacturing facility in Siri City in Andhra Pradesh. Danially, irrespective of the revenue, annual revenue, we always earmark a fixed amount for our R&D. In the last 10 years, we have been consistently spending $200 million every year. And it is because of that we could able to create new technology. We have created a technology in which the CO2 reduction can take place to the level of 300 kg per ton of steel. And that has been demonstrated by Tata Steel in Ludhiana. The plant has been commissioned March 2026, and it is a endless casting and rolling plant. And in which, of course, it is a scrap-based plant, but look at the technology. That technology has eliminated completely the reheating furnace. So you put the scrap and get the rebar within 2 hours. It's the smallest plant, but it is producing around 1 million ton plant. And total number of employees, 100. 100 employees per million ton. So this is the type of the technology which are already in place. But the point is that this technology is coming after a lot of expenditure on R&D. Now, second step, as I said, that public investment. Second step, that government must become the first and anchor customers for the products which are manufactured in India. Across the world, you will find those who have developed technology, public procurement has played a decisive role in creating successful products. And in that context, I would like to thank Steel Authority of India Limited. They have kept a criteria of minimum 50% sourcing from India in all of their capex projects. Another important point I would like to mention, and that is the third step, how we should go for product development. India needs to move beyond assembly-led manufacturing. Many times we say we manufacture in India, but if you see under a magnifying glass, if you enter into the workshop, if you want to enter into the factory, you will find, are we really manufacturing something from basic engineering? Answer is no. Many times we do assembly because we lack the basic design and basic engineering development in India. And there actually, we need, through INAE, I would like to put these thoughts in this conclave. We need to do something how the basic engineering or basic design can be developed in India, and hence the rest of the things can follow through. Yesterday, our finance minister, she was taking pride that India will become the center for global center for competence, GCC. We have now multiple GCCs in the country. Many Fortune 500 companies, they have opened GCC. But look at the GCC inside. 2/3 of the people who are employed inside GCC, they are responsible for execution. Who is doing the algorithm development? None. Algorithm has to come from outside. Who is doing the product architecture? Product architecture is coming from outside. So this has to change. There, the industry and academia should come forward, and this is something which is the need of the hour if we really want to become a developed nation. Of course, where there is a will, there is a way. In the Chandrayaan-3 mission, the 95% of the space equipment, which in the rockets, which is used in Chandrayaan-3, you will be happy to note that it is manufactured in India, 95%. Now, how it has happened? It has happened because of massive public investment, thrust of the government, and government pushed it. So the point is that in the engineering sector, particularly in the metallurgical sector, because the metallurgical sector will take the country forward, there we need to have massive public investment, as I mentioned in my speech. I do not know how many of you have watched this series, Made in India, a Titan story. I would say it is a glowing example of Made in India story, and Titan Company is the 5th largest global brand, and it is an integrated watchmaker. Every component of Titan watch is manufactured here in India. So the message what I would like to convey is that let us try to create more Titan story for India, and let us fall in love with your domain knowledge. Because I see a lot of students are here. I always urge to the students that do not digress from your domain areas, even if you see some white collar flamboyant jobs, but your domain area will take you to a height which the flamboyance may not take it forward. And simultaneously, you have a responsibility for the growth of our country. So with these thoughts, I would like to conclude my speech. Thank you. Thanks a lot.
Thank you so much, sir. We now have the privilege and honor of inviting Mr. J.D. Patil, President, Indian National Academy of Engineering, Member of Board of InSpace, Trustee L&T Employee Trust, to kindly give the presidential address. Thank you, sir.
Thank you, Mehman sir. I must say that as President INAE, my job has been really made very simple by Mehman sir as well as Professor Manna. Lot about INAE has been spoken, and I would restrict, in the interest of time, to only add what has not been spoken, specific about this phenomenal society, or call an organization called INAE. One part of the background of INAE, which is far little known, is we know that technology is par excellence, and truly in that sense INAE created a gold standard in terms of who and who's who of technology in India specific to the engineering domain. And the engineering domain is far more important for a simple reason. We have multiple establishments and the government putting enormous amount of funds behind academia and also the science institutions. Once science is known, there's only one way science can be converted for practical use, through engineering. So it is those set of people, and almost everybody sitting in this hall as engineers, we are the only ones who create from an abstract thought into something which is practical, directly useful, and this is original value creation, wherein maybe one ingredient, 1 rupee goes in, and the output can be 100, can be 1,000. Now this is essentially the ability of people, and the thinkers among them, those who did exceptionally well in terms of taking India forward, are the ones who we, in a way as INAE, celebrate as our fellows. INAE was, as Mehman sir said right at the beginning, set up in 1987, and I must tell you how important the country felt a need for an organization like INAE was to just say that the Prime Minister of India at that point in time felt it obligatory for him to come and formally inaugurate INAE. So INAE's first year of existence, when it was founded in 1987, and this is the 40th year. We just celebrate our 40th birthday on our foundation day. We are a couple of months down now during the 40th year. And this is a journey where if you notice any sincere and serious effort in terms of technology, whatever has happened in the country right from that day, you will find at least half of those specialist committee members would be fellows of INAE. And that's essentially suffices to say what INAE actually contributes in terms of, one, identifying, shortlisting, electing the kind of absolute phenomenal minds in this domain who are thereafter celebrated as fellows. Now we always felt, and Professor Manna and me were talking about it, that we need certain amount of mass, which we talked about at length, and we said there are less than 10 to 12, 1 out of 10 to 12, which we are able to select. But there are 11 whom we are not able to sort of embrace as our fellows, but are exceptional technocrats and leaders. And this is exactly the relevance for our new initiative, which 3 years back we started as fellows. As of date, while we have about 1,100 fellows, we just have about 300 members. And the membership becomes extremely important because we believe that every fellow, beyond every fellow, there should be at least 10 to 12 those who did not make it to the fellowship, and that's exactly where the membership and bringing that kind of a mass together creates value for us. Now, when we again talk of this important kind of an organization, the current leadership at the center felt it obligatory that an institution of this kind, when they give a recommendation to the government, they would obviously want to, in a way, say what the government wants to listen. And that's, in a way, good way that if you are funded, you would do. Because you would not be absolute critic of the government. You would toe a line what the leadership wants to you to say. Now, this is where the current government decided a couple of years back that INAE is funded by Government of India. While founded in 87, we used to be funded for our operations by Government of India right from 1993-94. Now, the current government actually took a call and 4 years back decided that INAE needs to be completely independent. So with an independent mind, what job we actually expect them to be doing, they do it far more sincerely and far more seriously. So if there's something right about it, it's our job to say government has done well, but there's something which government is not doing well. We are free, with our own wisdom being brought together, to say this can be done better. We don't criticize, but we say there are things that can be done better. And this is precisely where INAE became completely independent. And for most of you, except some of our fellows, obviously would know that last year was a benchmark year, first year of our existence as an independent, non-government funded, not 1 rupee of government funding we now take. Government decided in 2022 to taper down, and in 24, it was the last year. For 24 operations of INAE, government probably would have contributed, I would say, 1 in 6 rupees. Now, this is an ability that INAE built and created a benchmark in the Indian, I would say, similar kind of societies that exist. And there are more than 500 of such societies that exist to sort of do deep thinking in different domains. And we happen to be the first in the country that actually build that sustenance. More obviously, our fellows know, our members as well know, because this is the direct communication that the institution does to our fellows. We are somewhere about 2/3 on the way, little beyond 2/3 on our way to build a long-term sustenance in a form of a corpus fund. Once that corpus fund builds to a certain size, INAE can be running to eternity on just the annuity without touching 1 rupee out of the corpus fund. And that's exactly where, in last 2 years, we've been able to reach what we decided as a target, about 2/3 of it. Second major part is what Professor Manna did talk about on the technology conclave. The relevance of technology conclave is what we said. We do a lot about promoting engineering and technology, but the basics of technology, although that's an ingredient in everything that we do, we need a very focused kind of a discussion, getting into deeper and deeper few domains of those technologies which are relevant. And this is essentially where a technology conclave was conceptualized. And we said, while our fellows will obviously speak because they're the best of the minds in the country, but there's more and more involvement of the members that needs to be there in the technology conclave. Last year, within a couple of months of thinking through this idea, we did the first technology conclave. Remained about 150 people. Much smaller boardroom was good enough for the technology conclave to be done. We spent a lot of time during that, literally early morning to late evening, just one day, and we debated on sustainability of civil infrastructure. Extremely relevant because India today, if one sees what the government is spending, virtually 1 out of every 4 rupees that the government today earns is getting into infrastructure building. And if the infrastructure creation happens more sustainably, it starts making sense for India. Now, this one-day technology conclave and a forum on sustainability in civil infrastructure, which INAE, one very senior fellow of INAE, Professor Prem Krishna, has been chairing a small forum. And this forum, along with the inputs out of the technology conclave, what they put together was celebrated at the global level because, like INAE, there are 32 such academies across the world. All these 32 meet once a year, and every year it happens in a different country. So the last year's KITS, as it is called, the Council of Academies of Engineering, Science and Technology, the KITS meet actually talked very highly. A presentation was made on what INAE has been doing, and that's a repositioning of INAE in that sense in a global forum, being an independent entity without any favor or fervor, without any expectation out of that the government will give us some money if we are pleasing them. And this is exactly how the INAE is today taking it to higher and higher levels. Deep thinking forums is a matter of INAE's DNA, and somehow, a couple of years back, we were not able to do it as well because of the fund constraints. We decided during last year, now that we are standing on our own feet, we need to get back into it. I must inform you that last couple of months, we initiated 3 forums. One, of course, the Sustainability Forum continues. We decided sustainability in the energy in terms of the power generation distribution. We need to do far deeper work, and that's the forum which we initiated this year. The second forum we initiated this year actually pertains to what government's clear focus in terms of the green energy in the form of nuclear energy being taken to 100 gigawatts. So Dr. Kakotkar's chairman, under his being chair, he's chairing a forum specifically for nuclear energy, how to scale right from where we are to sustainable use of thorium, which essentially can power India for nearly few hundred years down the line. And that's a forum which we today are spending a lot of time. The third very, very major forum, which, and I am saying it at length, is any one of you, because this is, as INAE, I can say that from, as a president, the most active chapter. Your state and the region in which you operate is the mineral-rich region. And that's where the relevance of the next forum, we started a forum on critical materials. And this is critical material. We are not only talking of rare earths. We are now talking whatever is critical to India's growth in terms of where we want to be. This is where we need to focus, and we need to sort of think through, write it down, recommend, be part of some of those discussion forums. And that's where we have an in-house deep thinking forum specifically to the critical materials. Now, that's essentially what INAE today is doing. Besides, Professor Manna talked of the CEEE, the Center of Engineering Excellence in Education. Idea essentially is, it was always, I'm an industrialist, lived my 47 years in Larsen & Toubro, building a small company into a global powerhouse. When we do this, we start realizing that the quality of engineer what we used to recruit 40 years back or 50 years back, we don't get that quality today. So there's something that needs to be fundamentally changed. And this is exactly what Professor Manna talked about, that 4,000 teachers who are teaching engineering, if they are brought to a same level as some of the best of the professors in IITs, select few who actually then mentor each of those teachers for 1 full year. And through that mentoring, if we can change the teacher obviously has another hundreds of students whom he is actually dealing with and handholding them and teaching them, can make an enormous amount of difference. And that's exactly the theme on which the CEEE came up. So today, there's enormous amount of, I would say, societal, domain-specific to the field of engineering that at INAE we do. Of course, I could have spoken, if time permitting, on many other things, but suffices for me to say that's a new founded, new organization, fully funded by itself. Every major celebrated kind of an event that we used to do, including the awards, different types of awards INA used to grant till 2020 and then 20 onwards. One reason COVID, thereafter fund constraints, we had to stop them. We now are back in a way, every possible award scheme has been reinitiated. We celebrate entrepreneurs, we celebrate people who are doing innovation, and while one can say what is not happening in India, we are someone who would like to say there's a small success, a great work in innovation, let's celebrate, because if you celebrate our successes will breed more. And there are thousands of examples, and my own working career I can quote, where we are better than the rest of the world. Now, if this is what we can actually bring up, provide a platform, celebrate people, more celebrations can be expected to happen in time. On that note, I would like to say thank you. Good to see a hall which is quite sizably packed, and I would say, truly heartfelt gratitude to Professor Acharya to have actually been able to put up a program deeply thought through. Suman, my colleague as Vice President at INAE, actually did enormous amount of coordination with Professor Acharya and the team here at the chapter. And we said that if we have to move out of Mumbai and rather Delhi and Mumbai, what better place to go? The most active chapter being Bhubaneswar, the first stop we must make at Bhubaneswar. Now, that's essentially where I would wish that every one of you stay around, listen to some of those talks, because this is essentially where new ideas and new kind of innovation we'll hear about over the next 2 days. Thank you so much. Jai Hind.
Thank you so much, sir, for your valuable presidential address. We are privileged to have with us our Chief Guest, Dr. Ashok Kumar Panda, Chairman and Managing Director, Steel Authority of India Limited. Just to have a brief introduction, Dr. Ashok Kumar Panda, CMD SAIL, is a technocrat cum finance expert widely recognized for his deep technical knowledge and domain expertise. He has over 3 decades of experience cutting across disciplines and hierarchy in different plants and units of SAIL. Prior to taking over CMD SAIL, he had been working as a Director Finance and Director Commercial, lasting a deep impact over SAIL's various performance matrices. Dr. Panda has envisioned strengthening the position of SAIL amongst the top steel producing companies during his tenure as CMD. His presence with us today greatly elevates the significance of this inaugural session. Sir, we are deeply privileged to have you here. We request you to kindly share your address and enlighten us with your perspectives. Thank you so much.
Thank you. Very good morning, everybody. Jai Jagannath. Distinguished fellows of INAE, distinguished guests, people present here, participants from startup companies, dear students, very good morning once again. INAE, which is established in 1987, is going in the path of 40th year of its establishment. All the very best to INAE. And this program is being organized in SOA campus. In the hospital campus, as I came to know, SOA has hospital as well as engineering college within this. And today is Saturday. There's nothing to worry much about it. We can really interact, listen to each other, and discuss many topics of importance, topics that we want to know, topics that country wants to know, topics which excites us. One such topic is today's topic, of course, as I'm going through the program of Technology Conclave being organized by INAE. It has diverse topics which are very interesting. For example, if I just go through, read those: energy security, transportation and logistics, healthcare technology, reduction and diversification in energy-intensive industries. So these are some of the topics which are really the areas of concern for the entire Indian economy today. At the same time, when I say it is an area of concern, areas of concern, that means it has challenges, and where there are challenges, there are opportunities. That is how this country, our country, India, is really growing. We have many problems of disparity of economy, problems of education, but over the years, we have really matured. But of course, there are problems still. We are having a lot of aspirations. That's the reason why this country has today become the 4th largest economy in the world. And we are rearing towards achieving the 3rd status. That's our aim, and hopefully we'll be able to do it in next couple of years. But as we know, achieving 90 marks out of 100 is easy. Maybe it doesn't require much of an effort. But between 90 to 100, getting every 1 mark is very difficult, because it is poised with so many challenges. And along with the challenges, along with every challenge, there are opportunities. We must be able to find out those opportunities and try to cash on them. Then only we can achieve every other step, from 90 to 91 to 92, like that, then go towards 99. So the time has come that we must look inward as well as look outward, as to understand what others are doing. As our speakers have already spoken many things on research, development, technology, and other things. From Daniel, Mr. Ram was talking about research. That is another area of challenge for all of us. At the same time, we have opportunities. When we look at the other economy by the side of us, which is China, that is posing us a lot of challenge, a lot of threat. But because of those challenges and threat, we are trying to mature ourselves, and we have a benchmark. Today, the benchmark, apart from the global benchmark, we'll look at our neighborhood benchmark, which is China benchmark, and try to do something to go towards them, or maybe at some point of time, do better than them. So that's the pretext based on which we will discuss something in this particular conclave. When we look at the GDP growth of India, it is around 8%, 7.7% to be precise, which is growing at a very good rate. And this rate is there in very few countries throughout the world today. The world which was afflicted by corona some time back, 2 stages, India also got afflicted. And after that, continuous war situation, be it Russia, Ukraine, or in the Gulf. Because of that, all of us know that the global economy has taken a toll. European economy, EU economy is in tatters. Russian economy is not doing good because of the war situation. US is also not that good. There are very few economies, and when you look at your neighborhood, that is China, they also have a problem regarding GDP growth, because they have already grown to such a large extent that they are finding it very difficult to sustain. Sustainability is a question for them because they have scaled themselves to a different level. Now, very few countries are really growing at this particular time, and one of that is India, posing a growth rate of 7.7% or close to 8% is really amazing. That's the reason why the other day I had a friend in SCL Tech, of course, I think he has come to SOA and given a lecture as well. They are changing their alignment from other countries towards India. They are trying to strengthen their operations in India today because they're finding the growth of digitalization, AI is going to take place at a very rapid rate in India. I'll give certain examples as well why it is really true. So companies, the digital companies, software companies, they are also changing their style of business. They are changing from something called digitalization to AI. If you ask any layman or any person, he would say that AI is nothing but digitalization. But if you ask a digital company, he will say, no friend, there is a difference between digitalization and AI. AI is something different, digitalization is something different. So AI is a greater interface beyond digitalization towards human beings. So that is where the focus is. We'll talk about that. And that is one field in which India is really going to grow. I would say it is really going to grow, and the consumption pattern is also going to grow very largely going forward. That is the in thing for the economy. In India, we are focusing on Viksit Bharat and Atmanirbhar Bharat, which is Make in India. That is very important. The focus of this government for last couple of years is on these two aspects. Viksit Bharat means you have to grow. Your fourth economy, how you can become third economy, then how you can become second economy, like that. Make in India, which is Atmanirbhar. Unless you become Atmanirbhar, you cannot grow beyond a point. For example, if you talk about China, say around 30-40 years back, level of economy between us and them wasn't the gap wasn't very high. But over the years, the gap has increased. And they are almost like a black box. It was very difficult to penetrate into what exactly they are doing. But now, since they are growing and they are present everywhere, talk of any South African countries or South American country where resources are there, or talk of Russian country, or talk of Mongolia, or talk of Australia. Wherever there are resources, Chinese players are already there. Talk of Canada, they are there. In spite of the fact that they have been gifted by God with so many resources. Even then, they are present everywhere. There is a reason for it. The reason is that if you want to grow, then you have to grow within the country and you have to grow outside the country. In the sense that what is important is your currency. Your currency plays a vital role. Our currency should not depreciate, because if it depreciates against the primary currency, which in this case today is USD and Euro, if it depreciates, then your GDP value in terms of dollars comes down. There is a risk that you may fall down from fourth to fifth. So what it means? It means that we need to grow internally inside the country, do a lot of exports, which is what China is doing, and spoil others' economy. That is on a lighter note. That's what China is doing. And you strengthen your international operations, be present everywhere around the globe. That's what China is doing. So in that process, what is going to happen? When you export, then you get the foreign currencies. You get dollars, you get euros, and other currencies as well. So availability of those currencies in the country improves, and that is why the FE parity improves. So rupee versus dollar, rupee versus euro will improve, and that will help us. Number two, when you have international operations outside, then what is going to happen is, there you will be making income, you will be making profit, and those profit will be repatriated to India in foreign currency. So in both the cases, you are getting foreign currency. So when you are getting foreign currency, that means your rupee strengthens as compared to the foreign currency. this is beyond the technology, but because we're talking about business, I just want to any economy will improve only when the currency is very good. Today, in the middle of this Gulf War and Russia-Ukraine war, behind the scenes something is happening many of us are not able to see. What is that? The primary currency is US dollar and the second primary currency could be euro. You talk of any other currency, these are not primary currencies. That means when you are doing transactions with other countries, you are either doing it US dollars or in euros, and those are then getting converted into the other currencies. Like if you are making transactions with Japan, then you are not directly sending yen. You are sending US dollars, then US dollar gets converted maybe in Hong Kong or Dubai, etc., in an intermediary branch into yen, then yen goes over there. During this Gulf War situation, very tacitly, China is making direct yuan, their currency is yuan, direct yuan versus Gulf का अपना जो currency है, they are making direct deal between these two. So, if this kind of deals happen, then what will happen is that slowly and slowly these deals will get formalized. And once these deals get formalized, then direct deal with yuan can be done and yuan will become a primary currency. The days are not far off in which we'll see that another primary currency is going to come. And on that context, even our government is also trying to make direct Indian INR transaction with friendly nations like, say, Russia. Of course, it has not happened so far, but those attempts are being made right now. But those attempts will get strengthened and get established only when we grow, only when we export. And these exports will come only when our GDP grows further and our industry grows further. And to improve our growth in the industry, we have many requirements. One of the requirements is technology and R&D, as Mr. Ram has correctly pointed out. I'll come to steel sector. So in the steel sector, till today there is no indigenized technology available. We take iron making or steel making or rolling mill technology either from Danieli or from SMS or from Primetal, like that. But yet we have not developed our technology. Obvious question could come, why? The reason to why is not the technology transfer, as he has correctly mentioned. I mean, this company, some of those companies are interested to even do the technology transfer. But is that the real indigenization? Reason is no. The answer is no. Because we have to develop our own technology. How we can develop that technology? Only when we create research hubs. Who will create research hubs? Industry along with the academia should create research hubs. Only then it is possible. We have no doubt about the capability of our people. We have great consultants in steel sector. Again, I am coming to steel sector. In steel sector, Micon and Dasturco, to name a few major ones. They have been seeing the basic drawing and design, basic design drawing and detailed design drawing day in and day out. They know about these things. Even through re-engineering in the steel plants, we have these ideas. But are we together? I would say no. Whether the academia, the consultants, and the steel plants, are they together? No. Why? Because of difference of opinion. Because of who is going to take the lead. Because of the fact that who is going to share how much. It is not that there is no dearth of money. There is no dearth of money right now because these companies, there are so many industries in the steel sector, they can contribute money. But the question is, which is that single platform which will take the lead? So these are some of the questions on which the answers are not there right now. But while taking the lead, the academia industry, they can partner together to do certain things. I'll give you certain examples where the academia and the industry is really doing good and doing fantastic jobs. But of course not in the steel technology, but in other areas they're really doing very good. Which is that area where they are doing very good? It is that area where, for which India is known to be a pioneer. It is the area of digitalization, AI and software. Let me talk about our steel industry. in our steel industry, there are a lot of scope for automation, for process improvement, for safety, for transaction improvement, and many other, for information symmetry. And all these things requires a lot of digitalization. And on the top of that, lot of AI applications. So today the focus in our steel plants, in Steel Authority of India Limited, which I represent, we have 5 big integrated steel plants at Bhilai, Rourkela, Bokaro, Durgapur, and Burnpur. Apart from that, 3 other special steel units available. In these big steel plants and these special units, we are trying to implement AI and digital applications for many things like process improvement, for predictive maintenance so that breakdown becomes zero, absolutely zero. And also to show the unhealthy safety situation, unsafe situation, so that safety incidents do not take place. And these AI companies are doing a wonderful job today. The other day, in the ministry organized program, we had one AI conclave in which participants from steel plants had attended, from NMDC means mines, they had also attended, and the startup companies participated in that. They were giving presentations, and they have so many solutions to our problem statements. It is really mind-boggling, and they are very much enthusiastic, excited, and they want to do great jobs. So when we invite them to our steel plants, what we do? We have formed various groups in the steel plants itself and a central group as well for the digitalization. They prepare the problem statements. We tell them to prepare these problem statements with respect to process, with respect to the machineries, equipments, as well as the safety, in safety line of fire management. We must see how people do not come in line of fire so that even if there is an incident, but people do not die. So in all these aspects where human intervention is not required today, whose intervention is required? Either robotics or AI. So when we are giving these problem statements open to various startup companies, we are getting fantastic ideas and solutions from them. And slowly we've started implementing those, and with every passing month, there are visible improvements in the processes, mostly in the safety areas, and also in the mines. So that is one area in which I believe our startup companies are doing a good job. And when we look back, from where the startup companies are coming, are they just coming just like that, or there's a background behind this? If you go by their profile, you will find that most of them are either technocrats or professional like chartered accountants, MBA finance, something like that. So they are all intellectuals. Their style is different. The style of business is different. They are today's generation. So their style is entirely different. They are able to take more challenges, and within challenges they find opportunities. Reason why I'm telling this is that actually we have got so many students present here, and you should get that energy out of this. And these startup companies, they have got their academic background from esteemed colleges, engineering colleges, top institutes, IITs, NITs, state engineering colleges, big private colleges. So after getting their engineering qualification or professional qualification, they have ventured into startup companies, and they are adopting the technology which is required in the industry. So today, in today's world, actually, when we see, we are encouraging startup companies. For example, I would say in Steel Authority of India Limited, we have got a policy for inviting startup companies. There is no need to look at their financial capability or the past history. If it is startup companies, and if their credentials are good, and if they are able to give good solutions, then we are inviting them to we are investing, and we are inviting them to give the solutions. And that is how the entire economy is going forward. India has the highest number of startup companies in the world. That is a very good sign for our economy. And within startup companies, when they mature and grow to a particular level, and get listed in the markets, then they become unicorns. So I hope probably number of unicorns also is quite high in India, and we hope that unicorns should be more and more going forward, to be in large numbers. So they are the ones, those who will grow, and those who will grow the total economy taking forward. So these are some of the stories, but having said this, there are many challenges. One challenge is that our rupee is depreciating. That is one challenge. And when we look at steel company as a part of the economy, we will see that it constitutes around 4% of the total Indian economy, total GDP of the country. But even if it is 4%, but this is the backbone of the industry. If steel company grows, then the Indian economy grows. I will cite one example. In 2021, and the time when we had COVID, everything was in standstill. The economy came to a standstill that time. No activities, not much of a production. Production cut off around 50%, 60%. Certain sectors, they had to stop production. In small sectors, they had to stop production because they did not have a wherewithal to pay their laborers even. But at the end of COVID, when we started, then you can find that time the steel companies, they contributed a lot in terms of capex, in terms of starting back quickly, and in terms of producing oxygen for the requirement of the patients throughout the country. Because oxygen is one which is also required in the blast furnaces to produce hot metal. We throttled our hot metal production and we throttled our crude steel production, but we supplied oxygen to the nook and corner of the country to save our human beings. So the steel companies in the past has contributed a lot, present also they are contributing a lot, and in future I will tell you how they are going to contribute. Per capita steel consumption in India a couple of years back was 60, then increased to 80, then today we are at 100, but world average I believe is 160 or 150, something like that. So long way to go, and because our economy is growing, we will go away from brick and mortar kind of a thing, we'll go for steel structures everywhere. When we go to international market, other countries, we find that the building structure, everything is majorly made of steel, prefab structure. Slowly and slowly, we are adopting those. One, by using that, you are reducing the education period. Number two, by using that, you have the longevity. Number three, by using that, there is a flexibility in the sense that it can withstand the earthquake, etc., all those things. Initially, it may be very costly, but if you look at the total life cost, then it is pretty cheap. So steel is bound to be growing in this country. Couple of years back, our total steel production was around 80 million tons. Today, we are at 160 million tons of production and consumption in the country, while our capacity has grown up to 180, 190 million tons. In next 4-5 years, expansion in steel is there, and it is going to touch 300 million tons. Everybody is expanding. Steel Authority of India Limited, where we have a capacity of 21 million tons, we are going towards 35 million tons, already chalked out. In our 4 major steel plants, we are expanding capacities. In next 4-5 years, so 35 minus 21, 14 million tons will be added. Tata Steel is increasing, JSW is going very aggressive, everybody is increasing, AMNS also is increasing their capacity. One good thing about Odisha is that Odisha today has become a steel hub in the entire country. That's a matter of pride for all of us that this is one state which is growing, the economy has really looked up, and it is throwing challenge to other states, neighboring states. It has got the good policies because of which the businessmen, they are going to pour money over here. We have resources of iron ore, at the same time because flexible policies to some extent or to a greater extent because of which the industrialists, they are coming forward to put up their plants. Earlier we had one steel plant which is Rourkela Steel Plant under Steel Authority of India Limited, but today you are finding, forget about the western belt, the coastal belt has become the steel hub. Right from your Kalinga, Nagar, Jajpur down to Paradip. So in this state itself, in the next maybe 4 to 5 years, there will be addition of capacity of around 6 to 7 million tons. One in Rourkela, one in JSPL, Tata Steel. And after that, JSW is planning to put up there 5 million tons, and after that another 5 million tons, something like that. So still in this state itself is going to grow at a very rapid pace. And that is how the total steel production in the country will grow from today's level of 160 million tons to 300 million tons in 4 to 5 years. There is no doubt about it. There's a logic behind it. The logic is that actually steel consumption today is growing at a rate of 6 to 7%, almost equivalent to GDP growth rate. If we extrapolate that, then the requirement in next 4 to 5 years will be more than 300 million tons, and I believe the capacities are going to come towards that. But the question is, to achieve this, is it just to pour in money and put up a plant? The answer is no. There are many challenges for that. What are those challenges? The challenges are the ones that we are going to discuss in this today's meeting. One is energy security. The other one is transportation and logistics. Third one is automation. And of course, the reduction of energy. Steel is a very energy intensive sector. In today's session, we have experts from steel, experts from oil and gas. Oil and gas sector, they produce energy. Steel is the one which also produces but consumes energy greatly in its steel production and hot metal iron production. So the question is whether this energy we can use just like this or we need it in some other form. As we are going towards green energy or CO2 reduction, which is the need of the hour, that is posing a lot of challenges for the industries, for every industry, not only for steel, for every industry. But because steel is made from iron ore, so it is known to be a pollutant industry. It produces around 11 to 12% of total CO2 emission in the country. Its contribution in the economy is 4%, but in the pollution it is 11 to 12%. Point to ponder, point to think about it. And this point is also being deliberated in the steel sector throughout the globe, not only in India. And we are also deliberating about how to reduce this percentage. If you look at European countries, they have started something called CBAM, Carbon Border Adjustment Mechanism. That means beyond a particular level of pollution, if somebody is producing more, then his steel, when he supplies to European countries, it will be penalized. So that is called Carbon Border Adjustment Mechanism, and that is already started a couple of months back. The basic reason for that is to encourage producing less pollution, use more technology which are less pollution savvy, so that you are under control when you produce steel. Parallel to that, in India, we are also going to start, ministry is going to start another policy, and that is going to take place in another 2-3 years' time. So this is the time when we are preparing ourselves how to reduce CO2 emission. So to reduce CO2 emission, there are various ways of doing it. One, improve your technology in the blast furnace, which pollutes the most. Reduce the use of coke over there. Coke is produced from coal and then it is charged in blast furnace to reduce iron ore into hot iron, which is called hot metal, and also it acts as an energy over there. So it is a reductant in the blast furnace, as well as it is also an energy having a high calorific value of around 4,200 gigacal. So you need to reduce coke in that by use of better technology. The second thing is, along with that, the first one everybody is doing, we are also doing on a daily basis. The other thing is that you start using those energies which are green in nature. Something we call hydrogen injection. So hydrogen, you might be listening about hydrogen. In future, hydrogen from electrolysis process from water, that will be the in thing. So hydrogen will be injected in the blast furnaces which will replace to to a greater extent coke, so that the pollution will come down. The third one is we have gases generated inside the plant. While producing coke from coal, in the coke ovens, we get coke oven gas. So that coke oven gas can also be injected in the blast furnace to reduce the coke in the blast furnace, and the gas can be internally used in the blast furnaces so that it doesn't pollute outside. So these are some of the technology on which the steel companies are really working, and those are the in things for reducing CO2 emission. So when we talk about energy, there is a paradox. We talk about coal gasification to get energy, which is a topic today, as I have seen. Yet we say that how we reduce CO2. I mean, both are kind of little bit contrary to each other. But within the same coal gasification, do we have a technology in which we do not pollute the atmosphere, yet capture that energy? So that is the thing which we need to talk about, and the technology is going to evolve to capture that particular aspect, which are the requirements of future for all of us. That is on the energy front. On the energy front, the other matter which is very important for all of us is the renewable energy, which is coming in a very big way. As I told, AIs are coming in a very, very big way. Their growth rate is going to be much higher than the GDP rate of 7%, 7 to 8%. Their growth rate could be, the startup companies' economy growth rate could be at more than 10% going forward. So similarly, in the energy sector, everybody is now focusing on renewable energy. If you talk about 10 years back, in the academia, in the industry, we were only talking about renewable energy. And in such speeches, when we were discussing, we were only giving some vivid comment about renewable energy, but we are not able to give any practical experience, examples. But today, if you ask anybody, to me also, I can give a lecture for 2 hours on renewable energy. That's because it is required. That's because it is available. That's because the industries have really come up who can today give you solar energy, wind energy, water, hydro energy, and at the same time, the need of the hour is just not that. The need of the hour is RTC, something called round-the-clock energy. Same renewable energy, but not 8 hours in a day. It should be 24 hours. So there is a combination of hydel, wind, and solar. In that combination, some people give RTC, but that is not sustainable. What is sustainable is something with a huge investment, that is the battery backup. So the battery backup will give you RTC, round the clock, but today because it is not properly commercialized, so that is why the cost is very high. But slowly and slowly, as we are going towards RTC, the production of batteries will be more, and then the fixed cost will come down for battery, and that is how the cost is going to come down. So these are all the evolving things. When you talk about cell today, in cell we consume somewhere around 1000 megawatt or more than that. Most of that are coming through our own gases and the boiler coal thermal. But as the focus on renewable energy is there, we are today thinking about switching over part of the thermal energy towards RTC. And that is going to come. And that is where the RE companies will have huge investments in those fields. So that is another energy which is in the offing and which is going to improve our economic strength in the country. These are on the energy front. When you talk about transportation and logistics, we have so many challenges. We increase our steel production from 160 million tons to 300 million tons. How to evacuate it? Unless you have an outlet to do that, you cannot do that. So for evacuation, what is required is logistics. Today in the country, the logistics is not geared up to kickstart 8% GDP growth rate in terms of capex in next 5 to 6 years. Everybody is putting up capacity. Talk about steel, talk about oil and gas, talk about manufacturing sector or anything. So today our economy is really growing and capexes are growing. Capital investments are growing. So new capacities are really coming up. But when it comes up, along with that we should have the logistics available with us. So logistics, when I say, it is with respect to rail, with respect to road, and it is also with respect to waterways. These are the three things which needs a lot of improvement And when we talk about improvement, the investments will come from the government as well as from the industries. In road, a lot of investments are going to come, new vehicles have to come, and road network has to improve. In the road, in the rail, there is an opportunity for more number of doubling of rail tracks, and then importantly the high speed rails and something called freight corridor. So these corridors are slowly coming in the country. So the freight corridors will really give a lot of relief to all of us. And the waterways means actually we need to invest, the industries need to invest in the ports and improve the waterways so that through inland waterways also you can transport material, and you can also transport material for exports. And the fourth thing which is important is the slurry pipeline. This raw material which also requires transportation. If you take away a little burden from the logistics part of it through slurry pipeline, then those logistics can be utilized for outbound transportation. So slurry pipelines are going to come up in a big way so that the raw materials can come easily to the plant units without having road intervention or rail intervention or polluting through road and rail interventions. So these are the challenges where all of us have to work, and that will improve the total scenario. Today's topic is about healthcare technology. I mean, there are also a lot of technologies going to come. So I believe this workshop for 2 days, in which many people will participate, plenary discussions will take place, and there are so many students around, and I think startup companies are there. They'll be able to deliberate more and give their ideas, throw their ideas to the people, and we'll be able to gain a lot out of this. At the end, I wish all the very best to everybody for this 2 days workshop on such diverse topics concerning economy. Thank you very much.
Thank you very much, sir. Your words today will undoubtedly serve as a guiding light for the deliberations of this convention and will inspire all of us. Ladies and gentlemen, it is now my privilege to request our esteemed dignitaries on the dais for the formally release of INAE Technology Conclave 2026 souvenir. May I now request the dignitaries to kindly take out the souvenir from the folders placed before and release it together. Thank you. May I request Professor Damodar Acharya and Professor P.K. Nanda to kindly felicitate the distinguished guest on the stage. So Professor Damodar Acharya will be felicitating from INAE side, and Professor P.K. Nanda will be felicitating from SOA University. So I would request all the dignitaries to please come forward for the felicitation. Nanda sir, please felicitate Patil sir. I would request to have a round of applause. Thank you. I would request Nanda sir to kindly felicitate Manna sir, please. Thank you. I would request Professor Damodar Acharya sir to please felicitate Shri Manoranjan Ram. Thank you. I would request Professor P.K. Nanda to kindly felicitate Professor S.R. Samantre, sir. Thank you so much. To conclude the inaugural session, I would now like to invite Professor S.R. Samantre, FNAE Dean IIT Bhubaneswar and Secretary INAE Bhubaneswar Chapter.
Good afternoon to all of you. So we are at the concluding session of this inaugural function. So as we know, this 2 days INAE Conclave is going to have a lot of deliberations on emerging topics. I'm not going to repeat all these because all have been discussed. So on behalf of INAE, I extend my gratitude to Dr. Ashok Kumar Panda, the CMD of SEL. With all the odds, he reached today with us, having delayed in the Delhi airport. So thank you very much taking such pain and becoming the part of this function. I thank Professor J.D. Patil, the President of INAE, for choosing this place as Bhubaneswar as the venue for this conclave. We'll definitely take it forward in future. Thank you very much. I thank Professor Indralin Manna, the past President of INAE, coming over here and inspiring the INAE community to conduct such kind of very light class programs. I thank Sri Manoranjan Ram, Vice President of Danieli, to be part of this program and supporting this conclave to a larger extent. The leadership from Professor Damodar Acharya. So I thank Professor Damodar Acharya for really igniting and inspiring this INAE space over at Bhubaneswar and making this chapter one of the very vibrant chapter of this country. We have almost conducted many programs as of now, and the INAE has a bigger presence in Odisha during last couple of years. So on behalf of INAE, I thank Professor P.K. Nanda, the Vice Chancellor of this university, for extending all his support to conduct this conference. Above all, I extend thanks to the President and Founder of this organization, Professor Manoranjan Naik, who has really extended all these supports to conduct such programs. This may be the third program at a row since 2011 when Professor P.K. Das started the INAE convention in 2011. So we have this university has a big footprint in that respect. So needless to say, Professor Naik has created a highly motivated environment for education and social outreach in this state. Thank you very much for supporting this INAE conclave. I extend thanks Professor Manas Ranjan Malik, the director of SOA AIC Foundation. Possibly he is the man who has really gone through the thread and bits of this program and made it to these heights. I thank all these committee members, especially Professor Renu Sharma, who has coordinated multiple activities during the execution of this conclave. On behalf of the INAE Bhubaneswar chapter, we thank Professor Santoni Chaudhary, who has been in place for conducting or executing this program, and the INAE secretary with Colonel Roy and the team, who have really done a very fantastic job to conduct this conference at these levels. I thank all these participants, young minds, and the entrepreneurs, startup, and all the delegates who are being part of this conclave and really made this conclave to go to a different height. All the team members of this conference, because we started preparing this conclave just 2 months, and within these 2 months, this has achieved these heights. I think we thank all the people who are actively involved, directly or indirectly, to this conference, all the faculty members, support services of this university, and the media to take it further. So I strongly believe this 2 days conclave will deliberate and exhibit many new ideas and injecting thoughts for creating ecosystems for sustainability and creating platform for Make in India to meet the mandate of Viksit Bharat. Thank you all. Jai Hind.
Thank you. Ladies and gentlemen, with the inaugural session now concluded, we shall commence the technical proceedings of INAE Technology Conclave 2026. I would request all the dignitaries to please step down. We will start the technical proceedings with the first plenary lecture of the day, which is a virtual plenary lecture. It is my privilege to invite Shri Bhuvan Chandra Pathak, Chairman and Managing Director, NPCIL, to deliver his plenary talk on the theme Nuclear Energy with Distributed Small and Medium-Sized Reactors. We'd request everyone to please be seated. We are starting with the virtual plenary lecture for the conclave. I would request everyone to please be seated for the first plenary lecture of the day.
Ladies and gentlemen, thank you for your patiently hearing the inaugural session. We are now running slightly behind schedule. I request that we all quickly settle down and give due respect to our esteemed speakers who are awaiting their opportunity to address you all. Thank you very much. So we should be online very soon. Allow us that time.
It is my privilege to invite Shri Bhuvan Chandra Pathak, Chairman and Managing Director, NPCIL, to deliver the first plenary talk on the theme Nuclear Energy with Distributed Small and Medium-Sized Reactors. May I request Sri Pathak to kindly deliver his address? May I request Sri Pathak to kindly deliver the address? Sir, you are not audible. Yes, yes.
Am I audible?
Yes, sir. You are audible now. May I request Sri Pathak to kindly deliver the address? Sir, you are not
am I audible?
Yes, sir. You are audible now.
Am I audible?
Yes, sir. You are audible. Yes.
Am I audible?
Yes, sir. You are audible now. May I request Sri Pathak to kindly deliver the address?
Am I audible?
Yes, sir.
Yes, sir, you are audible, sir.
Yeah. Okay. Good morning. Today's chief guest, Dr. P.K. Panda, Mr. J.D. Patil, other dignitaries who have just presented the inaugural session, and all the industry partners, invited guests, speakers, delegates, and dear friends. It's my privilege to be here, and on the onset, I thank Dr. Acharya for giving me this opportunity to talk on energy security in current scenario at SOA Bhubaneswar. I don't know how much time I have, but I'll try to complete with the time being allotted to me. I'm sharing the presentation. Yeah, so as you know, we have twin contradictory targets for the country. One is making India a Viksit Bharat or developed nation by 2047, and at the same time achieving net zero carbon emission by 2070. The first one gives us the challenge or the target to treble our GDP to around, and of course, energy supply requirement. So that is possible only when the per capita income or per capita total energy consumption goes manifold. And for this, we need huge amount of energy. And then second one is, of course, achieving net zero carbon emission means there should be a least emission into the environment.
Excuse me, sir, your presentation is not visible, sir.
It's not visible?
Yes, sir.
Okay. Is it visible now?
Not yet, sir. शेयर कर लेंगे उनकी साइड से।
Is it visible now? Is it visible?
Not yet, sir. You are requested to kindly share it through your screen, sir. The manager probably you are sharing it.
So is it now visible? Not yet?
Not yet.
Just a moment. Put to Awid. Yeah.
Now this is visible, sir.
Yes, visible. It is visible now. So my presentation will be in 10 main headings, and I'll be talking about this how nuclear energy journey started and what are our various plans and what is our plan for further implementation, achievements and other things. So we'll discuss one by one. So coming to our journey in nuclear power. As most of you must be aware about this 3-stage energy program, we have 3 stages. First stage is where we'll be using the natural uranium, which is available in India. And basic idea is to be self-independent in terms of fuel. So thorium is available in India in plenty. So we have devised 3 stages wherein the plutonium which will be generated in the first stage, that is pressurized heavy water reactor, will be used in second stage, and wherein plutonium along with the thorium will be used as a fuel. And this fuel will not only generate electricity but also give a lot of fuel for third generation, that is uranium-33. And then we can be self-independent in terms of nuclear fuel for many centuries. So that is why this 3-stage has been devised. Otherwise, elsewhere, it is the pressurized heavy water reactor, which the pressurized water reactor, the PWR, which are generally deployed everywhere because they have huge amount of uranium available there. So how this nuclear power industry basically developed in the country? It was because of the Dr. Bhabha initiative. The first institution was set up in 1945 at Tata Institute of Fundamental Research at Mumbai, and then post-independence, Atomic Energy Act was enacted, and Atomic Energy Commission was established. Department of Atomic Energy was established in 1954, and then 1950s, 60s, 70s, a lot of vision was developed and institution building was taken up. So, as we all know, our governing body is Atomic Energy Commission, reports directly to Prime Minister, and Secretary Department of Atomic Energy is the chairman of Atomic Energy Commission as well, and the entire Department of Atomic Energy is having around 330 organizations within it. If I divide into some sectors, so we see its R&D sector, where institutions like Bhabha Atomic Research Center or IGCAR are there, and Department of Atomic Energy produces heavy water. It manufactures fuel, it manufactures the radioisotope also, and we have 5 public sector units under the Department of Atomic Energy. Nuclear Power Corporation of India Limited is the leading pioneering company as far as nuclear energy is concerned. And we have service organization. Of course, there are educational institutions, and there are various aided institutions like TIFR or Tata Memorial Research Center, that is TMC, wherein which is the pioneer institute for cancer research and treatment, and various institutions like Atomic Mineral Division was set up in 1948, 49. Rare Earth 1950, Uranium Corporation of India Limited 51. Likewise, these institutions were developed. Nuclear fuel complex was developed in 1968, and a lot of industry for supporting nuclear power was handholding was done. IGCAR, that is in Kalpakkam, developed in 1971. Indian Plasma Research Institute 1982, Atomic Energy Regulatory Board, RRCAT, NPCIL, it was set up in 1987. Of course, it was there in other forms also. And this Board of Radiation and Isotope Technology, that was set up in 1989. So this way, along with this, in any nuclear power corporation projects, we need nearly 50 major and 200 medium scale vendors. So these companies were also encouraged to take up manufacturing jobs. L&T, Hindustan Construction Company, Walchand Industry, Kirloskar, BHEL, ECIL, and many more are there, which was developed with handholding by NPCIL and DAE. So the first reactor which was set up, of course, in India was Tarapur 1 and 2, that is based upon the BWR, boiling water technology, which was set up with the cooperation of GE, USA. 1969 was that was set up only to have the experience of operating a reactor, and subsequently our aim was to basically go for finally utilization of thorium. So we went for the pressurized water reactor. So first reactor which was set up in pressurized water reactor was in that is Rajasthan. So these were the 1970s was the area where we tried to demonstrate the technology, and 1980 we indigenized all those technologies. So we developed our own PSWR, and then we standardized it, and now today we have a 700 megawatt reactor, which is in all respect 100% we can say indigenous reactor. Everything right from design, construction, commissioning, operation, maintenance, manufacturing, everything is sourced from India. So it's a real example of Atmanirbhar Bharat. So, and recently, around 3 such reactors are in operation now. So, we have 24 reactors which are in operation today. And of course, we have one more reactor which is under prolonged shutdown, that is RAPS-1. So we are not counting in our fleet. Otherwise, we have a fleet of 25 power reactor I'm talking about. And total installed capacity is 8,780 megawatt. And stage 2, that is breeder reactor, prototype fast breeder reactor also has been made critical in the month of March this year, that is 500 megawatt. And 9 reactors of different capacities, 700 megawatt, mainly 700 megawatt, and 4 reactors of 1000 megawatt are in different stages of construction. Out of this, first reactor will be another 2 to 3 months time will be basically commissioned, and every year at least one reactor will come online, and this way we are going to add 7,500 megawatt. And apart from this, there are 8 reactors of 700 megawatt. In that indigenous reactor are at different stage of pre-project activities, wherein site is almost now ready for taking up the construction jobs. So our target is to take the total nuclear power from 8,780 megawatt to 22,000 megawatt by 2031-32. This is where NPCIL is working now. And you can see these are the photographs of various units which are in operation today. 24 units, 8,780 megawatt. And this is the photograph of fast breeder reactor 500 megawatt, which is just made critical. And these are the 9 reactors of 700 megawatt, like Rajasthan 8 is one, Gorakhpur, Kaiga, Kudamkulam. So the Kudamkulam reactor, that is 3 unit 3 and 4, they are being set up with the cooperation of Russian Federation. Of course, they have the major equipment supplied, and design drawing is from their side. But otherwise, the construction, commissioning, operation, maintenance is being done by NPCIL only. 2 reactors of this capacity are already in operation at Kudamkulam site. And these are the 8 reactors at different pre-project stages. So we take pride in being in this sector for past 57 years. And Tarapur 1 and 2 is the shining example of continuous operation. We have been able to operate these reactors very successfully, and these are the oldest reactor not only in India but in the world. And recently we have modernized this one and have been brought online, and both of them are operating at 160 megawatt each. And we one of our reactor, that is Kaiga unit number 1, made world record in 2018. Continuously operated for 962 days. Of course, these pressurized water reactor can, because they are on power reactors, wherein regularly every day 2 to 3 channels are refueled, so they can continuously operate for any number of days. But because of the regulatory requirement, we have to shut down the reactor after 2 years. So in case of Kaiga 1, because these reactors were operating very well, Atomic Energy Regulatory Board allowed us to operate it for 962 days. That made the world record. Then immediately after that, Darlington 1, that is Canada, they broke the record. Of course, then we didn't want to go further on that. And the beauty of nuclear power is reactor is they are operate on continuous basis. So these are the number of reactors which have been operating continuously for more than 100 days in 54 at 54 occasions. This is the performance of our operating fleet. You can see in 21-22, 47,000 million units we have generated, and last continuously 2 years we have been operating more than 55,000 million units. Our plant load factors is very encouraging. It is above 80%. And if we compare with international reactors, so we are much better. Our capacity factors are very good. And we have till now, since inception of this corporation, we have avoided around 842 million tons of CO2 emission, and annually around 47 million tons of CO2 we are avoiding by producing green power. And as we all know, there has been 3 major accidents in nuclear accident. That is, first one was in 1979 in 3 Mile Island, that is in USA. Second one was in 1986, that is Chernobyl, USSR at that time. And third one is 2011 Fukushima, that is in Japan. So these major accidents has taken place in the developed countries. So we are into this business since 1969, and there has not been any incident, and we have not released radioactivity beyond the stipulated limit set by regulator. And we have the experience of 664 reactor years of operation of power reactors. We can see through this diagram, the background radiation itself is 2,400 microsievert, and Atomic Energy Regulatory Board has given a limit that you should not be releasing more than 1,000 microsievert from your plant. You can see our plants are not even, this is not even 1 microsievert. So this fraction of micro, except for these 2 plants, that is Rawatbata and Kalpakkam, because they are the oldest reactors. Otherwise, you see, this is the status, how strong design and operation is there behind achieving these targets. And after the Fukushima, the accident, we have stress tested our reactors, and we found that reactors are in extremely good shape. And in spite of all those things, we have incorporated many recommendations made by the committee, and all those recommendations have been implemented. And in 2012, there has been one review by IAE, and this is the impression they have given, that is open communication, enthusiasm, motivation, and sense of ownership were observed at all levels during the OSARD mission. These attributes have cultivated an environment of strong safety culture at RAPS 3 and 4. So this is the international accreditation which we have got. And apart from design, construction, commissioning, operation and maintenance, we have a great strength in renovation and modernization of our nuclear power plant, because in pressurized heavy water reactors, we need to change the core of the reactor every 15 to 20 years. And initially, we wanted the support from international bodies, and we didn't get that kind of support. And whatever cost they were offering was very, very high. So we developed our own technology, and today we are in a position to change all those components. Why it is so challenging is because once the reactor gets critical, it starts operating. So anything, any changes in the reactor is very difficult because of the high radiation field. So we have that now technology, and we can see within a limited budget and shortest time possible, we are able to replace all those internal components. And we have carried out such operations in 8 reactors, and the 9th reactor is in progress. So now international players are seeking our support on this. And this is the reason now the oldest reactor of the world is in operation after this specialized health assessment and studies of structures, systems of and analysis was done. Even the reactor building, which was constructed long back, we have gone for the testing, and it is extremely good results, and we can operate these reactors for another 10 to 12 years. So in nuclear sector, public opinion is also very important. So NPCIL is doing a lot of activities onto this in terms of exhibitions, lectures, seminars, and developing permanent facilities, capabilities. You can see the environment, how much care we take about the environment around the sites. And the flourishing fisheries, agriculture, these are the examples. So whenever you have the time, you can visit and see the flora and fauna around these sites. And then we take care of local people in terms of healthcare, education, skill development, infrastructure, sustainability development, sanitation through our CSR activities. Now coming to today's topic, that is how the nuclear power can contribute. See, we see the total energy requirement today, installed capacity of electricity is around 532 gigawatt. Out of this, majority is now renewables. That is, if we take nuclear, hydro, and renewable, it is more than 50% now. So that was the commitment by 2030. The renewables will be more than the 50%, and this is what India could achieve now. Of course, we can see the nuclear is in terms of installed capacity 1.6% only, but in terms of generation, you see it is 3%. So that is why the capacity factors of nuclear are very, very high as compared to other sources. Worldwide, there are 415 power reactors which are in operation, and around 380 gigawatt is the net capacity. And reactor operation experience is around 20,000. So now, as CMD SAIL was telling about this need for this green energy, especially in view of this CBAM. So nuclear power is going to play a major role. So in terms of the growth, which is to be there by 2047, and the need of clean energy and energy system challenges. So nuclear power is a key player in this energy transition because other sources, of course, like renewables, will have the problem of intermittency, and a lot of work has to go for this battery storage, and of course it has to be cost effective also. And as far as nuclear power is concerned, we are the cheapest in terms of per megawatt installation cost if we compare with international players. The recent reactor which we have set up was 16 crore per megawatt. So, but we have the technology now available, we have the infrastructure available. Now it has to be rapidly, basically deployed at site. So that is why last year the Shanti Act has been passed, and a lot of players are going to be there. Why nuclear power is going to play that role is because of this reliable base load characteristic and low carbon emissions. As I told, if we compare life cycle carbon emission from this nuclear power plant, it is comparable with the wind. Even solar is generating much higher carbon emissions in terms of life cycle emissions. So it's almost at par with wind. And so this is going to be a driver for decarbonization, and definitely it has to be economically competitiveness. So more and more players have to be there now. Otherwise, if we go for a large scale manufacturing in India, so the cost of the nuclear power project will come down drastically. So what are the possible strategies? So one is we have to stick with our 3-stage nuclear power program. That is deploy large number of 700 megawatt reactors, and that too in as a nuclear park. We have to have a site where we can have at least 8 to 10 reactors in one go, so that the good amount of nuclear power is made available, and that will bring down the overall cost of the project, and other infrastructure related cost will also be less. But at the same time, we need to have diversity in terms of PWR technology. Worldwide, it is the pressurized water reactors. The region is the pressurized water reactor technology have much higher capacities, like 1000 megawatt, 1200 megawatt, 1400 megawatt, even 1760 megawatt. That is which is being basically used in France. The EPR is 1760 megawatt. So NPCIL along with BRC is also working on this technology. We are going to develop the Bharat Small Modular Reactor, which is based on the PWR technology. Why we didn't go for PWR was because it needs enriched uranium, which initially we didn't have, and we had to be dependent on foreign players, which of course after 1974, which was not there to India. So that is why now the time has come. Now we can source every nuclear material from across the globe. So it's the time to go for PWR also. That is why we are working on this. And of course, as far as this energy intensive industry like steel, which was just mentioned, we need to have small reactors for captive generation. That is why NPCIL has gone for a request for proposal for Bharat Small Reactor, which is based upon the PSWR technology. And because we have a small size reactor, that is 220 megawatt, so these reactors can be set up nearby those industries, and power can be directly fed to this industry. And of course, there is a need, of course, BARC and other institutions are working on this to develop a technology which will be used for not only for generation of electricity, but also producing hydrogen. Because today, the overall energy basket, if we see, around 18% is the contribution from the electricity, but remaining 82% is in terms of molecules, like transportation, like industries, steel industry, fertilizer, cement, wherein the energy is used as a molecule. So if we have to basically reduce the overall carbon emission, so we have to address the energy, reducing the carbon emission from the energy requirement also, that is 80%. So one is to convert this 80% in terms of electricity, 18% has to go up, like electrical vehicle today, wherein electricity will be used instead of molecule, and the fuel for the energy. So hydrogen is going to play a major role. So we are working on the designs of a reactor which will generate hydrogen directly. Like a fast breeder reactor could be one, and molten salt reactor could be another one, wherein the high temperatures are achieved to produce cheap hydrogen, and whenever there is low demand on the electricity, so that electricity can be used for the hydrogen, which in turn can be used for transportation and other industry. And of course, nuclear power is very niche, and the public perception is not so good about this. So we have to have a highly trained people in NPCIL or in Department of Atomic Energy. We have a well-established system of training people, the selection, induction of the engineers directly from the colleges through a GATE and other. And then we have full-fledged 1 year, 1.5 year or 2 year training program for various category of people. And there is licensing by Atomic Energy Regulatory Board. So we have to have a huge infrastructure for training, which NPCL is working. We are going to have a big training setup in a place called Narora near Delhi, wherein yearly around 1,000 engineers can be trained. And this will be, of course, for our in-house requirement. At the same time, we can offer this facility for other institutions also. And but there has to be industry, academia collaboration also on training. It's not only the NPCL or BRC or IGCAR. Various institutions also can take up this training program, wherein a Department of Energy can directly contribute. And of course, leadership development is also equally important. It's not only generation of nuclear power, it's a generation of nuclear power at a competitive rate. Ultimately, we have to sell the electricity into the grid. So there is leadership, not only for the project execution, for the effective plant operation, but also ensuring the overall safety of the nuclear power plant. Instituting the safety culture within the company. So that is very important. And operational excellence is another very important factor. There is an organization called World Association of Nuclear Operators, that is WANO, which has 4 regional centers, Atlanta, Paris, Moscow, and Tokyo. And there is central office that is in London. So who basically oversee the safety aspect of those operating reactors, 415 reactors which are operating worldwide. So so they focus mainly on the operational excellence. So they review, they have the peer review mechanism and see that each nuclear power stations are performing at its best level. And since, as I discussed, we have to sell electricity at a competitive rate, and nuclear is having big competition from wind and solar. They are very, very cheap, and whereas the electricity generated by nuclear is definitely expensive one. So we have to reduce the overall installed capacity, the installation cost of the nuclear power plant. So it is possible by standardization of the engineering models, which we have the model now to whether it is 220 megawatt or 700 megawatt. NPCL has a standard design, so it has to be followed as such. And supply chain strategy. It is everything is available in India. We have the capacity in the industry, but we have to increase the size now. So for this, the moment large number of players are there, so orders will be there. So cost of the equipment will come down, and Indian manufacturing industry can be basically used as a hub for manufacturing across the globe for the meeting requirement of NPPs across the globe. And of course, project management has to be there so that the gestation period generally, which is very high in case of a nuclear power project, it has to be reduced. And of course, we could build many reactors in less than 5 years. These are the benchmark which we have set up. So we have to ensure that it is maintained. And operational efficiency. We have to operate all these reactors at very high capacity factor. Generally, our reactors operate at 80 to 90%. Some of the reactors operate at 100, more than 100% capacity factor also, like Kalinga. These are the reactor designed for 220 megawatt. Contents they operate for 100, more than 100% capacity. And nuclear power projects not only are high gestation period, but capital intensive also. So we have to have the capital made available, both from internal resources as well as from FDA, and the government of India is working on this, and FDA also may be open for this setup of nuclear power plants. As I told, the supply chain is very important because our mainstay is going to be 700 megawatts. So everything is available in India. So we don't import anything. And we import only fuel that too, we have the capacity, we have the manufacturing setup in India, but because the uranium itself is not available, that is why we are importing from outside. But other than this, and heavy water is available plenty, and we are exporting heavy water from our heavy water plants also. But like manufacturing, small equipment, electrical instrument equipment is also very important, wherein industry has to put lot of effort. The moment large number of orders are there, there would be huge expansions, and in view of the Shanti Act, all major companies like Larsen Toubro, like KBL, KSB, they have started expanding their factories to meet the future requirement which are going to be there in coming years. And the focus area has to be community engagement. That is very important because land acquisition is one of the very important factor, not only in nuclear power plant, but also in other sectors also. So public has to be taken into confidence for this. And project timeline and cost control is very important to be competitive. And operational and fuel cycle management, for this probably we may have to acquire uranium mines elsewhere, and we can take uranium ore from outside and manufacture in India because we have the capability in the country. So manufacturing of fuel can be done now in view of Shanti Act. Even private parties can also manufacture fuel. So only the availability of uranium has to be ensured. So somehow we have to address the capital cost should not go up. That is the only major challenge we have to address. So what are the plans and strategies? So the major areas would be the large deployment of 700 megawatt reactors, because this is proven technology now and 100% indigenous. And as an additionalities, we can have large capacity light water reactors with foreign collaborations without making any changes except for the site specific related issues. So that India, today it's the installed capacity of electricity is 500 megawatts. Say after 2047, we may have around 1500, 1600 gigawatt. So to meet this kind of challenge, we need a large capacity reactor. So that is why foreign collaboration is also very important, wherein various companies in India, both in public sector as well as private sector, can venture into this. As I told in the beginning, NPCIL has come out with a model Bharat Small Reactors. These are 220 megawatt small reactors, which already are in operation in NPCIL. Around 15 such reactors are operating. So these reactors can be used for industries for captive use, and wherein the concept was people can come up with land and capex, opex, and NPCIL will design, construct, commission, operate, and maintain these plants. So this is how we can support decarbonizing the industries, and development and setting up Bharat Small Modular Reactors. This is being developed by NPCIL and BRC together. So this we are going to have, as per the nuclear energy mission, by 2031-32, we'll have 5 such reactors and 3 such capacities we are working. That is 200 megawatt, 300 megawatt, and 50 megawatt. So these type of reactors are under development and will be set up in a place called Tarapur near Mumbai. And we need to work on emerging technology like molten salt reactors or breeder reactors. And of course, we need to have the competent human resource for coming years and decades. So this is what is the roadmap. Today the installed capacity is around 8 gigawatt and 13 gigawatt is under different stages of implementation. And in all, NPCIL will basically set up around 53 gigawatt by 2047. I'll come to the breakup of this. And the target for 2047 is 100 gigawatt. But this is the minimum target because to meet the 2070 requirement of net carbon emission, we need to have much more than this. So this 53 gigawatt will come from one is the 23 gigawatt by indigenous PSWR and 21 gigawatt from light water reactors. Like 4 reactors we are going to have in Kudankulam, and Jetapur we are going to have 6 reactors, 1730 megawatt, and Kovada will have 6 reactors. So this way total 53 gigawatt will be from NPCIL. And in addition to this, around 4 gigawatt will be from the Bhavani, which is based on the fast breeder reactor. And remaining 46 gigawatt will come from various private companies, joint ventures with various public sector unit by NPCIL. Like we have the a joint venture with NTPC. At Mahi Baswada, where 4 reactors of 700 megawatt are being set up. And but it's not going to be that easy. So there are many challenges. So the one is the support from the state government is very much required. It's for land acquisition, rehabilitation of displaced communities. Water allocation is very important because we need to have around 90 cusecs water available for setting up twin units of 700 megawatt, and various clearances for acquisition of land. Land acquisition is done by the state government in case of public sector undertaking. So the support from state government is very much important here, and local administration in terms of pre-project planning activity. Because once we acquire the land, a lot of site-specific studies, desktop studies are to be carried out. So because it is nuclear power plant, so generally there is public apprehension. So state government, local administration has to basically support in all those activities, not only pre-project, but post-commissioning, operation maintenance, and the full support is required. Now the way nuclear power has been brought into focus now by Government of India, so I'm sure we are going to get this support. And because cost is very important, so green energy concessions are to be provided for the nuclear power now. It has to be brought in line with whatever is available to solar and wind, and many more things can be thought of in terms of this carbon taxonomy. And one way of reduction of the tariff could be the GST, because electricity is not under GST. So that is why the burden of GST for setting up nuclear power plant is very high. Of course, the initial cost of nuclear power plant is much higher, but the operational cost is much lower as compared to other sources, especially the fossil fuel. So somehow the cost of the setting of power plant can be reduced by giving some concession in terms of GST. And infrastructure development, anyway, for transporting the large equipment, there should be the good road, railway network around that area, and public awareness. This is very important. Finally, because what happens is during setting up of any nuclear power plant, there would be a lot of protest, and because of this, a lot of delays takes place. But once the power plants start generating electricity, then there is all around calm, because the overall the economic standard, the state of standard of the people basically goes up. So people are happy. But during the initial setup period, these are the challenges which has to be addressed. And now, since as of now it was only NPCIL and to some extent Bhavani, we were self-sufficient. Now there would be many such companies. So NPCIL is coming forward in terms of mentoring all those, giving the support to all those companies like site selection, siting consent, land acquisition, and technology related capability, capacity development, quality management, construction and commissioning, operation and maintenance, training capabilities. So we will be supporting, NPCIL is going to have one vertical which will be providing the consultancy support to all those companies, and we will encourage all those companies to go for this technology which we have developed in terms of 700 megawatt. It's because it's very cheap and it is indigenous. Otherwise, people are free to go for any imported reactor also. And then once we have the technology, as Mr. Ram was telling, why we should go for the imported ones. So once we have the technology, we have earned it very hard way. After 1974, there's total technology denial regime was there. So it is the government of India, it is the Department of Atomic Energy who has developed this technology with a lot of money put into this. It should be used now. So NPCIL is ready to provide all those kind of support. We have been providing, we have been basically inviting people from various companies. We are training them, we are mentoring them, we are sending our people to various sites for assessing the suitability of the site. So that will continuously be there now. So with this, thank you very much, and welcome any questions if at all there. Thank you.
Grateful to you, sir, for your very inspiring talk. From INAE, please accept our thank you and our gratitude. Thank you to you, sir.
Thank you. Thank you very much.
Ladies and gentlemen, we now proceed to the next plenary lecture of the conclave. It is my privilege and honor to invite Professor G.D. Yadav, FNAE, Bhatnagar Fellow CSIR, Emeritus Professor of Eminence, and former Vice Chancellor, Institute of Chemical Technology, Mumbai, to deliver the plenary talk on the theme Coal Gasification, Fertilizers and Coal-Based Chemicals. We are indeed privileged to have him share his invaluable insights on harnessing coal resources through advanced technologies to support India's energy security, chemical industry, and sustainable development. May I request Professor G.D. Yadav to kindly take the podium and deliver his plenary talk. Ladies and gentlemen, please join me in extending a very warm welcome with a hearty round of applause.
अच्छा तो कोई ना ठीक है तो आप एक नहीं नहीं अभी एक ही स्पीकर का तो मुझे लगा देख लूंगी और एक छोड़ दे
Just be careful with the wire, sir. Yeah, yeah. Thank you. See whether it is project hoga, projection. Give that. Change kar do also. Yeah. So you can sir kar reaction ho gaya. Yeah. Sir, do you need this? No, no. Then I can use this. Okay. Good morning. Oh, good afternoon. Sorry. So I'm going to talk on this subject because of the many things which are happening. Nobody had heard Hormuz before. Maybe in February, hardly anybody knew. And that has created a global energy crisis. And what is talked about is how India, country like India, most populous in the world, can overcome this problem. And we have huge supply of coal. So can we use coal? So I deliberately chose this title, From Coal Combustion to Circular Carbon Economy. So look at this. We know that there is the price of crude oil has been fluctuating from 62 to 120 plus. We don't know. 2 days back it was 73. It has again risen to 80 plus. So every day it is changing. So what do we do on this energy crisis? So India should be, because you heard about SMR, the small nuclear modular reactors, but can we do something with coal and still be able to achieve the so-called net zero emissions by 2070? That is the idea. So let us look at some of these things. First is, the carbon emissions, so-called carbon dioxide, that was during the first crisis in January 2020, before the pandemic, it was 410 ppm. Practically, we were sitting at home for the entire year, and on a particular date of 10th of April 2020, crude oil price was negative. It's not required, I can do that.
Sir, actually that is not working. It is fluctuating. Is it working?
Maybe it might.
I don't know. Yeah.
Okay.
It will.
Okay.
Is it working? Not working. Tape.
All right, thank you. Technology has its own problems. So, on 10th of April 2020, the crude oil price was literally negative, minus $10. You have to pay for taking that crude oil. And still, although we were not doing anything for the entire year, we added 2 ppm during the year. So January 2021, it was 412. And they said the economy is restored when in May 2022, it became 418 ppm. So the growth of economy is related to carbon emissions, and that is exactly what we need to fight. This, now you see that July 6 this year, it was almost 430 ppm. So a lot of carbon dioxide is being emitted. And really speaking, for comfortable life, 380 ppm is the mark. 308 ppm, should not be more than that. Okay. So what is this net zero? Net zero means your carbon dioxide emissions should not be more than 10 gigatons in a year. So in 2022, we emitted something like 35, this is fossil carbon 35 gigatons, billion tons, and it has to be brought down to less than 10 gigatons. That is the mark for the so-called 1.5 degrees Celsius temperature rise. So in other words, it is not net zero, but net negative. So we have to take carbon dioxide out of our atmosphere. Now the problem with our economy is it is carbon-based economy, whether it is natural gas, oil, coal, etc. So that is what, so and the whole problem now is that we are going towards the so-called renewable carbon, biorefineries. So use of carbon gas fuels is the real cause for this greenhouse gas emissions. Now another interesting thing, this is since I talked about geopolitics, in February, that is 12 February 2026, Donald Trump revoked the so-called EPA endangerment finding. That was the reason for this Paris Agreement of 2015. During Obama's time, they said that, this is the EPA finding, that carbon dioxide is going to be the most dangerous gas and something should be done. That is the actual position. However, Donald Trump revoked that. So Donald Trump is not responsible for any carbon emissions. US is not responsible. That is the meaning. So we have to worry. Others have to worry for this. So this endangerment finding is gone to winds. So now let us talk about net zero and what we can do. In net zero, hydrogen technologies are going to help. So whether use coal or anything else, I'll talk a little about that. Then carbon dioxide will be the new oil, and we have to decarbonize the economy. Then biomass, waste biomass or purposely grown biomass has to be a source of chemicals, materials. Solid waste management. I come from Mumbai, and the Mumbai municipality produces 9,000 tons per day of municipal solid waste. In that, 50% is food waste, 10 to 12% is plastic waste, and others is construction, debris, and whatnot. So we have to manage that. So MSW can be a source of energy and materials. Waste plastic recycling, whenever there is a problem, we blame plastic. But plastic saved so many lives. During pandemic, it was plastic which came to our rescue. So plastic ban is not the solution. Management is the solution. So, water resource management. When we talk about hydrogen, we require water. Where is that water? And now his SMR presentation, he also said we require a lot of water for these small modular reactors. And the so-called circular economy and recycle engineering. This is the buzzword these days. Biotechnology will come to our rescue. So I mentioned that SMR, which there was a talk, and ultimately it is systems engineering approach. Nothing is a waste, everything is a resource. So if there is a co-product, that is also resource. If it is a byproduct, that is also resource. So in other words, I'm saying that think negative. Most of the people on television say better think positive. I'm saying think negative. Of course, I'm joking. It means think of negative, that is carbon negative energy systems. Carbon should not be used as a source of energy. That's my important point. And we should have material neutrality. So this is where the net negative energy systems and sustainability come into picture. So the 5R is, first is refuse. If I refuse something, suppose I refuse a water bottle from PET bottle, then I'm reducing carbon dioxide. Repurpose. The same thing can be used for something else. Repurpose is the terminology which has come from pharmaceutical industry. Reduce, reuse, and recycle engineering. So according to me, in 2047, when we want to be Vikasit, there will be nothing virgin available to us. It will be all recycled material, and you have to use that recycled material. This is where government policy matters the most, okay? And it has to be incentivized. For example, if there is a barcode on the plastic bag, milk pouch, you can return that and get your money back. But now we don't have. The housewife will take the last drop of milk by putting copious quantities of water in that, but she will not use the plastic bag. She will throw it in the dustbin. So you have to have incentivization of this. So this is where government must have a practical incentive, not something. You say that 50 micron plastic, nobody is going to measure it, right? It has to be incentivized. So yes, so recycle engineering, physical, chemical, biological. So I call chemical engineering because I'm a chemical engineer. Is going to be renamed as recycle engineering, where we will do everything. We will recycle everything, which are rate processes, increase the rate, minimum reactor volume, continuous processes and whatnot. So at the same time, we have to say that nothing is waste. We are unfortunately not giving any value to waste. We have to say that is valuable. Now this is where hydrogen comes into picture. So by 2050, there are 3 different international agencies based out of Europe that they said this demand will rise from 287 to 813 million metric tons. Why not 850 or something? But these are in numbers. This is for reference, yes. And this is where you will have both green hydrogen and blue hydrogen. So I will tell you what is the meaning of that. So hydrogen production can be done from biomass, natural gas, coal, oil. And since I'm supposed to talk about coal like to chemicals and whatnot, I will give a little more time on that. So coal, yes. So whether it is a thermochemical process or something else, we'll look at this. So you know what? We did in our lab work by using solar energy, molten salt, and a copper chlorine cycle to make hydrogen. So this is the thermochemical cycle. So where we use carbon dioxide as a feedstock, make methane, ethane, LPG, and higher hydrocarbons, including SAF, okay? That is another idea. So you can make, for example, methanol, dimethyl ether, formic acid, ethanol, higher alcohols, all those things, then we are done. We have got few patents on that. So now let us look at India's strategic vulnerability, and the topic I'm going to talk about is 87% of the crude oil is imported, right? LNG, methanol, ammonia, all those things are imported. So can domestic coal become a strategic carbon resource? And this is the thing which I'm going to talk about. So look at the comparison of the coal. So in India, we have a very high ash containing coal, okay? I'm a consultant to chemical and allied industry, and I find that they are mostly importing this coal from Indonesia because it has got least amount of ash. So here, India, Australia, USA, South Africa. So this is very, very important that high ash content in Indian coal poses very, very challenging questions. If you want to make use of this coal for syngas production, and then syngas is taken to other chemicals or whatever, that is going to face a very big problem. So it requires indigenous technology solutions, and we don't have them. Okay, so I will tell you something what is going to happen in this. So there are 2 types of coal, the thermal coal called non-coking coal and coking coal. So these 2 are very, the so-called non-coking coal is abundant, widely available, and this is the backbone of energy security. And wherever the coking coal, which is used in steel production, steel industry is one of the most polluting industries. And this morning he was telling that we produce about 160 million metric tons. 1 ton of steel produces 2.38 tons of carbon dioxide. And China is about 1100 million metric tons. So this industry is going to grow. So, and he was telling about 300 million metric tons. So that means this industry has to be decarbonized first. Can we use green hydrogen there, for example? Okay. So look that about 390 billion tons of coal is available in India. And so people are talking about why not use coal? We do not have much of crude oil, so can we use coal for chemicals, materials? We are the 2nd largest producer, and we top 5 coal reservoirs. And see Odisha, Jharkhand, Chhattisgarh, West Bengal, Madhya Pradesh. And so coal is a strategic carbon reserve, not just as a fuel, and it should not be burned as a fuel. That is one question. So burning coal, the old model, you have a combustion, you heat and you generate carbon dioxide. And the other one is you produce syngas, and you make chemicals, fuels, and materials. So you have higher value addition. It will be an import substitution, low carbon intensity, and even if in future there is some crisis like Hormuz, we will not be affected. So this is where the coal ministry and other ministries, including steel ministry, must start. So the future lies in carbon conversion, not carbon combustion. So look at this. Oil reserves are only 0.6 billion tons. Natural gas reserves, they are limited. And coal reserves are very high. So coal contains 250 to 270 billion tons of carbon. So why not use this as a source for making chemicals, fuels, and materials? This is where, so India, we should think that coal is not just a fuel, but it is required for the sustainable development of this country. So there are many coal gasification technology. That is the main. So once you have coal and you gasify, make it syngas, you can produce variety of things. First example is methanol. We did not, establish many methanol plants. We still are importing methanol. Then hydrogen, because syngas contains hydrogen, we can separate it. Then of course you can have ammonia. Then so-called Fischer-Tropsch synthesis to make variety of fuels, and of course SNG. So we can convert this low-value coal to something. This cost of coal is around 10 rupees a kilo, okay? That is what it is today. So you can see what sort of things can be done. There are many projects, coal gasification projects. This is about mid-2026. The Talcher in Odisha, okay? So BCGCL in so-called Jharsuguda, and then Coal India's then BHEL, GAIL, and all these companies are involved in all these projects. Some of them are in planning, some of them are at the advanced stage, and some of them will be operational by 2027, okay? So look at this. So for high ash Indian coals, what is the best technology? So the BHEL has the fluidized bed gasifier, and of course the pressurized fluidized bed gasifier, then the moving bed Lurgi technology, and the so-called entrained for, small, this is for the cements, and also, last but not the least, the underground coal gasification. ONGC was planning for it several years ago. But yes, these are the areas where Indian coal will be a great value to our country. And so this Talcher coal gasification, and so they are talking about ammonia and urea project. So you see this is a joint venture between GAIL, CIL, Coal India Limited, RCF and FCIL. Then you can see that these are the great many details are available in the literature, in public domain. The technology licensors. So can we develop some better technology than what is available in the market, okay? So this is a very important thing which has been talked about a lot. So China is a leader in this, okay? China is a leader. So in this case, once you have a syngas, you require catalyst to convert that. Of course, you require gas cleaning, methanol synthesis, FTA synthesis, methyl to olefins, methanol to olefins, hydrogenation and whatnot. So this is where a lot of research is being done in nanocatalysis, bifunctional catalysts. Then you have to worry about the catalyst poisoning processes, and you do process intensification. We have been working in this area, therefore I put them in this order. So now let me come back to the hydrogen part of it. There are 7 different colors of hydrogen depending on the source, the technology. For example, brown hydrogen is the gasification of coal. Okay, it produces 19 tons of carbon dioxide per ton of hydrogen. Gray hydrogen is steam methane reforming natural gas. It is 11 tons of carbon dioxide per ton of hydrogen. Blue hydrogen means 90% of the carbon dioxide is captured, sequestered, stored, and then that becomes 1.11 tons of carbon dioxide. So that is a blue hydrogen. Turquoise hydrogen is pyrolysis of natural gas, where actually you get carbon and hydrogen, so zero CO2. Green hydrogen is electrolysis or thermochemical, and so there you can have, again it is zero. And pink hydrogen, where nuclear energy is used for electrolysis. And very recently, Atomic Energy Commission, were in the news for this particular. They are using the 4-step copper chlorine cycle. We have been using 6-step copper chlorine cycle. So these are the ones. And there is another one called the white hydrogen, which is naturally occurring hydrogen. That was reported by CNN on 30th of October 2023. And so a lot of, and that was near Mali. Now they say this could be anywhere between 6 million tons to something like 350 million metric tons. But Texans call it as gold hydrogen. Okay, so in future by 2050, we'll have only blue hydrogen and green hydrogen. Now look at methanol. If you make methanol from syngas, whether the source is coal or any other source, including carbon dioxide, which we have talked about. So you can make formaldehyde, formic acid, acetic acid, dimethyl ether, olefins, fuels. So hydrogen, here, the methanol is an energy carrier, okay? So methanol could become the petroleum of 21st century, because we will not have any crude by 2050. That is for sure. Crude will be exhausted by then. Either because something else, so-called biorefineries will be there, and something else will emerge out. So in the methanol economy, so methanol is valuable for the energy sector, chemical sector, transportation. Methanol, for example, methanol is used in the racing cars. Okay, methanol can be used as a fuel, then marine fuel and petrochemicals. So this will be India's opportunity for import substitution of billions of dollars, okay? So methanol economy is the one molecule, multiple sectors, massive impact. So methanol is a versatile fuel, and we wrote a couple of articles on that, and one of them is also dimethyl ether. Either you dehydrate methanol, or you can produce methanol directly from carbon dioxide. In our case, we have produced methanol from carbon dioxide and also dimethyl ether from carbon dioxide. So both of these are very valuable precursors for chemical industry. So this is another thing. Then this is our success story. So we converted carbon dioxide into methane, LPG, and higher hydrocarbons. These are catalytic processes. We have developed this catalyst. And this work has been supported by ONGC Energy Center. So, of course, we have expression of interest from 3 companies. There were 26 when we asked for it. But anyway, we are going into this. So we can convert carbon dioxide upon any stage. For example, the power plants produce about 15% of carbon dioxide in their flue gas. And also it has got other muck. So it can be clean, and that carbon dioxide can be taken as a feedstock for making methane, LPG, and hydrocarbons. The other thing is that we converted carbon dioxide into dimethyl ether, DMA. This is in the news. So our source, we developed this process, catalytic process. Our catalyst doesn't die even for 3,000 hours. So that's a good process. It is better than whatever has been reported in this. And we have Godavari biorefineries as our partner. So yes, so this is patented. So they produce something like 450 tons per day of carbon dioxide from their fermentation plant because they make ethanol. So that produces a lot of carbon dioxide. And that carbon dioxide can be converted. They will get carbon credit, and that can be converted. So we have a pilot plant now built on this, and we want to sell this technology across the world. So this pilot plant was inaugurated on November 10 last year, and experiments are going on, and we'll be ready in few months to transfer this technology to industry. Then another is carbon dioxide into methanol directly. Okay, so we have got international patents, and this can be commercialized. So we are now planning for a 5 tons per day of this methanol plant from carbon dioxide. So carbon dioxide can be any source. It could be biomass, it can be the power plants, or it can be from coal. Okay, so we can use this carbon dioxide to make so-called green ethanol. Okay, that is one more thing. Why methanol? Because I said earlier that methanol will be a very important feedstock for chemical and allied industry. So all these processes we talked about, see formaldehyde, acetic acid, MTBE, gasoline, petrol, methanol to olefins, all those things can be done. And they will go in a variety of sectors like construction, automotive, appliances, paint, coating, everything. So once you have syngas, you go to methanol, you can do it, or you can directly go to dimethyl ether, as I mentioned earlier. So we can have this green hydrogen integration. So coal-derived syngas, this lacks sufficient hydrogen, and you can use, for example, lower carbon dioxide emissions. You can use wind, solar, or hydro energy, either have electrolysis and make coal gasification. So you can low carbon coal to chemicals. That is another theme where we can integrate green hydrogen with coal conversion. And so low carbon technology roadmap will be coal to ammonia, so it goes to fertilizer, then coal to coke, that is steel industry, coal to methanol, olefins, that is the conventional coal-based chemical industry, and modern coal chemical industry will be coal to natural gas fuels, coal to oil fuels, coal to olefins, plastics, and coal to ethylene glycol, polyester, etc. So all these things are possible by using coal as a feedstock. In fact, the direct CO2 hydrogenation to methanol is one of the interesting processes. And so you can use either water electrolysis to generate hydrogen, or like what we did in our case using the thermochemical process. So low carbon coal industry, electrolysis, coal gasification, then you have CCUS, government of India is promoting CCUS, so that will reduce the CO2 emissions, and here we can of course recycle the carbon. So that will be our future sustainable chemical production. So clean energy plus hydrogen, green hydrogen, coal gasification plus CO2, we will get sustainable chemical production. Of course, coal to coal tar to chemicals is another area. Again, catalytic processes, you do pyrolysis of coal, you get coal tar, then you can make fuels and chemicals, or you can make carbon materials, okay? So thermal polycondensation, carbonization, etc., or catalytic cracking, and we can generate diesel, gasoline, and low aromatics. So in other words, energy transition and circular smart carbon refinery for India, this is the concept. So you have coal, which is abundant. We have biomass. So normally what happens is the farmers are burning their agri-waste because they think that way it will increase the fertility of the soil. At the same time, it will kill the bugs and whatnot. Actually, it's a bad idea. During December and January, you cannot go to Delhi because flights are delayed. The air quality index is about 300. You cannot land, and all sorts of problems are there. So these farmers, my suggestion to the government is the following. Farmers should collect their agri-waste. They should densify it, make pellets, and these pellets can be a feedstock for making chemicals and materials. Okay? Once you do that, that will give additional. So this is typically 5 to 6 rupees a kilo. You give additional incentive, maybe 10 rupees a kilo. Everybody will collect that. They will not burn it. And so you have a distributed collection centers. They go to somewhere else, and this is where they process this biomass to make variety of chemicals that will be biorefinery. That is what the government should do. Rather than, this is one of the suggestions I'm giving. Then you have any source of carbon dioxide, you take plastic waste. For example, plastic can be depolymerized. You can do aminolysis, glycolysis, hydrolysis, whatever. You can depolymerize them. So you get the polymer, you can get the ingredients, same ingredients or something else. So this is plastic upcycling, downcycling, recycling. So we did this with PET. So from PET we could get terephthalic acid and ethylene glycol within a catalytic process, which we, of course, we have a patent on that. We did also with nylon, same thing. Okay, so what I'm trying to tell you is that plastic ban is not a good idea. People should be given incentive to collect that plastic and return, so that will be a circular carbon economy. Okay, that is what is required, not ban. Ban will never solve a problem. And you know, I can tell you on a lighter note, wherever there is a ban on liquor, in those 2 states, maximum liquor is sold. And who is benefiting? The authorities, the police force, and the municipal authorities. They make money, illicit money, because we are putting ban on everything. If one technology creates a problem, another technology should solve the problem. That is the solution. That is how history of civilization tells us. Otherwise, still we'll be riding bicycle. Right? Why did we go to the next level? So that is true in the case of this carbon as well. Carbon has to be treated, recycled, and used again and again. Okay, that is what is going to happen. So all forms and colors of carbon are gold. Okay, according to me. So in the circular economy, you will have smart carbon, sustainable carbon, that will be resource efficient, zero waste, net zero. And so we can make high value products, chemicals, for example. Fischer-Tropsch synthesis itself gives a lot of industry, and that is how we started. Chemical industry started with coal chemistry more than 125 years ago. Now we are going back to the same stage. We can make fuels, we can make materials, advanced materials. So the carbon should be treated as gold, should not be allowed to be wasted. There should be a collection for policy or incentivization of that policy, so that people do not throw anything as a waste. That is what. So the perspective on sustainability and carbon management, the challenge is rising carbon dioxide emissions, and I tell you that if we do not control it, every year this carbon dioxide emissions are rising. Typically they are 3 ppm. And if that way we go, it is believed by 2027 we would have already emitted so much of carbon that the so-called 1.5 degrees Celsius temperature rise, earmarked for the entire century, will be over. And another thing you should know as a general public is that in any place, wherever the temperature rises more than 3 degrees, 80% of the biological species will die. That will be ecological disaster. So we have to plan immediately that how do we stop these CO2 emissions and take CO2, carbon dioxide, as a resource. So this is where I always talk about net negative systems, net carbon negative systems, okay? And that way we will not be dependent also on the so-called fossil fuel. We do not have much of that. So carbon capture, then convert that into advanced, processes, chemicals and materials. You have a closed loop. So this CO2 utilization, clean energy and fuels, all these things are possible, and India can lead in this technology advancement. It is all possible provided we have right sort of policies and incentives for this, okay? So finally, I thank quite a few of my students who are working with me over the years. And so if there are any questions, I'll be more than happy. And I'm within my limit. No questions? Yeah, please. No, 15% CO2, 15%. No, you have to first of all purify that carbon dioxide, otherwise the catalyst will foul. There is a particulate matter, there is nitrogen, there is oxygen, there is nitrogen and there is oxygen. Yes. Yeah, you can see, once you capture that carbon dioxide, there are n number of possibilities. Like for example, when we started carbon dioxide capture, we said, let us make methane out of it using green hydrogen, okay? Yeah, then methane, ethane, etc., etc. We also did methanol. We also did ethanol, okay?
A solid product.
Yeah, we can do, yeah, once you have chain building, ultimately it will become a solid product.
I just have one question, Professor Jani.
Yeah, please.
This is very interesting because you have covered the entire gamut of chemical production from carbon dioxide. The question is, how does the cost compete? Let's say you make ethanol from this, and you make ethanol from
fermentation,
corn or grain.
Yeah,
or
very good question. Yeah, because that is a traditional process where you make ethanol, that the percentage will not be more than 12-13%, because the bugs themselves get drunk. Beyond 12-13%, the bugs don't work. So the maximum, it's a dilute ethanol. And so then you have cost of separation, downstream processing. So what happened, the ministry said, because these are the plants run across, all PSCs are also doing that. But then they said, can we not have enzyme technologies? But believe me, 1 lakh liters of ethanol, the cost product, that is estimated right now to be 1,400 crores. Whereas this fermentation, that is on the basis of enzyme, because we are talking about 2G ethanol and all. In the case of this fermentation process is about 800 to 900 crores. So these new technologies which are being talked about, they are not economically viable. Okay. Secondly, all ethanol processes generate carbon dioxide. The remaining goes as carbon dioxide. So I gave you an example of Godavari biorefineries. They have a sugar factory. So they're producing 450 tons per day of carbon dioxide. So Samir is my friend. So I said, Samir, why don't you join hands with us? We have developed this carbon dioxide to dimethyl ether and all. You will benefit because you will get carbon credit. During that COVID time, the carbon credit was very high, about $60 to $80 a ton. It went down afterwards, right? So, but there is an incentive to capture that carbon. So that's how I convinced him. I said, your carbon dioxide, which you are producing this way, we can take it to the next level. So entire biomass you take and do calculations, it is much better than just producing ethanol. Now, yes, ethanol can be produced from, ethylene, okay? And that was earlier done. Then it was overtaken by these fermentation processes. Now we are talking about something where you can also make ethanol using catalytic processes. We have published articles, we have done work on that. But that is not as economical as ethanol by fermentation. But that is a waste stream. So we are trying to make something out of the waste. So waste to value is the concept which we use there. Quite honestly, the so-called economic viability, I may call anything green. Nobody is going to invest in that unless they make money. They have to make money. Engineering is making money by definition. Right? Otherwise, it will be just scientific curiosity. They have to make money. If they don't make money, they will not do the engineering. So yes, this is a challenge, but it is work in progress. They are looking at me.
Request for the paucity of time, I may request, sir.
I go down?
No, sir, not at all. My request if we can continue our question answer with the learned personality like him during the lunch hour. I'm extremely sorry we are so out of time that it's my apology not to give time to such an towering personality who is there with us.
No, thank you. No, actually, you know what happens? I'm a professor. So when you go into the classroom, you don't look at watch. You try to satisfy the audience. The students there, these are not students, these are delegates, highly distinguished delegates. Their curiosity, I must answer that. Yeah, thank you. Yeah, we'll discuss. No, you know, he's a colonel, I remember that. He has ordered that we have to stop. Thank you. Yeah. Okay. No problem. No problem.
Thank you very much, Professor Yadav, for that illuminating and highly enriching plenary talk. May we request Professor S.R. Samantre, Dean IIT Bhubaneswar and Secretary INAE Bhubaneswar Chapter, to please come on the stage and felicitate Professor Yadav. I would request Professor Damodaracharya sir to please come on the stage and felicitate Professor Yadav. Thank you, sir. Ladies and gentlemen, we now move to a very special session of the conclave. We move to a very special session of the conclave, startups by recipients of the INAE Young Innovator and Entrepreneur Award. This is one of the flagship initiative, the INAE Young Innovator and Entrepreneur Award of Indian National Academy of Engineering, instituted to recognize and encourage outstanding young innovators and entrepreneurs. And the award celebrates individuals who have successfully translated innovative ideas into impactful technologies, products, and enterprise. Through this initiative, INAE seeks to foster a vibrant culture of innovation, technology-led entrepreneurship, and startup development, while inspiring the next generation of engineers to create solutions that address the national priorities and global challenge. It is now my privilege to invite Mr. Jayant S. Karve, Director and Chief Executive Officer, R-Cube Life Sciences Private Limited, Bangalore, an esteemed recipient of INAE Young Innovator and Entrepreneur Award, to share his journey and the story behind building a successful technology-driven enterprise. Ladies and gentlemen, please join me in extending a very warm welcome to Mr. Jayant S. Karve with a hearty round of applause.
Good afternoon. My name is Jayant Karve and I represent R-Cube Life Sciences Private Limited. It is really a privilege and honor to be here presenting our journey. At R-Cube Life Sciences, we are focused on innovative medical technologies, and our focus area is emergency medicine and critical care. In fact, prior to starting this company, I had an educational background wherein I did my master's from Indian Institute of Science, Bangalore, and subsequently I worked with GE Healthcare. At GE Healthcare, I have been involved in development of various medical equipments, primarily into nuclear medicine and X-ray. And that attracted me, so I haven't really listened to my professors who were wanting me to continue with my PhD. Having said that, it's really a field journey so far, and we have been working on various technologies, but one of the technology example I will present in front of you, how we basically translate insights, unmet clinical needs into practical products, and how do we implement them. So our focus is basically trying to understand unmet clinical need and translating it into the patient outcome and trying to create the impact. And we have been working with various institutions, including All India Institute of Medical Sciences, and we have been doing a lot of clinical work with ICMR. As we are moving forward, we are interacting a lot with hospitals as well as armed forces. So we follow I3 process, which is an innovation process, which is identify, invent, and implement. And we have crossed all this, though it looks very linear. Basically, what we do is we go outside into the hospital setting, try and understand what are the clinical needs, what are the unmet clinical needs. Subsequently, we move ahead with the inside-out approach, wherein we try to develop the solutions. Initially, there are initial prototypes, and subsequently, we translate it into the actual clinical use. So it's a very, very complex process, appears very linear, but there are multiple iterations involved, and it needs a lot of regulatory compliances as well. So this is our flagship product, Ozindi. It's a life-saving device in all medical emergencies. And what this device does is basically gains access to the circulation in all medical emergencies. So consider any medical emergency. Typically, it happens in resource-poor conditions, and what one needs to do is basically provide access to the circulation, and typically we do it through these vents. But in clinical conditions, basically because of the low blood pressures and low blood volumes, these veins get collapsed, and even the best of the best clinicians are not been able to gain access. And providing this access in emergent scenario is very, very important. If we are not been able to provide the access, typically we see a lot loss of life. In fact, in India, as we speak, around 3 million patients, which is around 30 lakh people, die every year just because of non-availability of any solution so far. So the clinical scenarios are basically a cardiac arrest, accident cases, out of where there is a profuse blood loss conditions, then the burn cases wherein the skin is completely burned, pediatric emergencies because of the very, very small sizes in the pediatric population. In fact, people say that the bread and butter for the pediatrician is actually to gain the IV access. And of course, the military medical emergencies. These medical emergencies typically happen in the resource-poor conditions. Typically, when I say resource-poor condition, either the person who attends the medical emergency, whether it happens inside the hospital, outside the hospital, or on the field, typically it has been attended by less skilled paramedic or the nursing staff. At the same time, the resources available are very, very poor. So access to circulation in golden period of a treatment is very, very important. So this is our solution. It's an intraosseous access device. This is a device which is basically a pre-sterile, ready to use at the point of care. And one can very easily gain the access to the circulation in less than 10 seconds. There are 3 landmarks to this. And it's a completely manual, so you can use it inside hospital, outside hospital, or wherever feasible. And it's very, very easy to do. So our value proposition is basically we provide access in less than 10 seconds. It's a very minimal training requirement. In fact, we have built a complete solution for that. And it's a quick, safe, and easy. Basically what it is doing is this particular procedure, trying to avoid the very skilled physician and even the paramedic or the nursing staff can do this particular procedure. So this is a video of the basically it's an animated video. So our value proposition is access to circulation in less than 10 seconds. Sorry, there is no sound. I don't know what is the issue. But the clinical conditions like patient with a cardiac arrest, accident cases, trauma cases, profuse blood loss conditions, pediatric emergencies, geriatric emergencies, obstetric emergencies, patient with the burns, and of course the military medical emergencies. So these are the various conditions wherein we need to provide access to the circulation, and if we don't provide that, there is a lot of mortality and morbidity. The access is very, very simple. The landmark is tibial tuberosity, proximal tibia, distal tibia, and humeral head. These are the landmarks which are very, very easy to identify. Even the paramedic nursing staff can do it. If you touch your knee, you will find one protrusion, and that's the landmark. So with respect to that landmark, basically this is a device which is pre-packed, pre-sterile. You just open the device, position the device at a particular insertion point and press it couple of times. Though it looks very simple, gaining access into the bone is very, very complex. So there is a lot of engineering which has gone into it. Typically a standard tubing is connected. One needs to aspire so that he knows that he is into the right location, and then start infusing. You can give the single syringe which is called bolus infusion, or one can give a continuous infusion. This is a location which is basically a non-collapsible veins, and it drains completely into the circulation. And we have various variants of this device. Like we have a 25 mm, 45 mm. So this is one of the fluoroscopy video. Basically, what we are trying to do is basically trying to take out the topmost layer of the bone, which is the hardest, with our device, and the rest of insertion happens very easily. So there are a lot of advantages why we are doing this procedure in this particular case. Because if you have a power devices, there are issues that the needle goes across the bone, and there are extravasation related issues, and so many things. So this is one of the, again, a fluoroscopy image. This is been done at humeral head. If you do the access here, it directly drains into the heart. So less than a minute, we are able to. So essentially, if you gain access here, it directly drains into the heart, and less than a minute, basically, one can infuse fluids, medications, everything, which is very, very crucial, including cardiac arrests. So this is a patented device. Our patents are granted not only in India but also in global locations, including US, Europe, Israel. We have been implementing this device in a very clean room environment. This is a CE certified device, Indian certified device. So we are complying with all, not only Indian regulations but also global regulations. And as we speak, our device is already been approved in UK NHS system. We also have done a good clinical work at All India Institute of Medical Sciences, published a couple of clinical papers in American Journal as well as Indian Journal, and we are also doing a lot of clinical work with the ICMR funding. So this is a complete solution, because it's not only the device but also the training is equally important. So we have developed the modules, training simulator as well as training kit, and this we are using it for the demonstrations. So yes, you have a technology, but typically the question what we get is, oh, this looks fantastic, but we haven't used it, so how do you adopt it? So we have built a systematic complete training module, and we are trying to basically give the trainings to the care providers, including All India Institute of Medical Sciences. This is at AIMS Guwahati in the pediatric session. This is at various private hospitals, government hospitals, what we are trying to train the care providers. This is in the orthopedics, wherein they are seeing polytrauma patients. So these are the various locations wherein we are trying to train. In fact, this device also has a huge applications in armed forces emergency medicines, and we had an opportunity to train few of them. In fact, much of work is also done at Armed Forces Medical College. In fact, we got a surprise. This is there is a program Yodha Rakshaka, and wherein we figured out that our device has been demonstrated, is been used for the training purposes. This is something which we had an opportunity to be in the Arunachal Pradesh, in India-China border, wherein we visited border ports, border field hospitals, trying to demonstrate the technology. This is with the topmost leadership with the armed forces. So we have been working very incessantly on this technology. We got various accolades, including British Medical Journal. But the most important thing is what we have been able to demonstrate is create a very credible evidence for our device to get adopted. It is CA certified, it is Indian regulatory compliant, and at the same time, we got UK NHS registration completed now. So we are really excited. This is a Make in India, a design in India for the globe. So that's the kind of a device what we have. Thank you for your attention. If there are any questions, we'll be happy to take. Yeah. Thank you.
Thank you very much, sir, for that inspiring and insightful presentation. May I request Professor Dr. Renu Sharma, Additional Dean, Student Affairs, ITER-SOA University, to kindly felicitate Mr. Jayant. Please, sir. May we have a huge round of applause, please? Ladies and gentlemen, with this we come to the conclusion of the morning technical sessions. May I request all the distinct delegates, speakers and the participants to kindly proceed for the lunch to the lunch venue, which is at Conventional Hall, ground floor. The technical session will resume at the scheduled time. We are ahead of the scheduled time, so we request you to please be back by 2:55. Thank you, and we wish you an enjoyable lunch. We look forward to welcome you back.
Ladies and gentlemen, you have a short walk to the lunch venue. Time available to you for this during this break is only about 20-25 minutes. May I request for a hurried lunch at the cost of sounding rude? I will request you to kindly be back by 2:55 p.m. and will be grateful to you for being here. Thank you.
लेट्स गो सर। वो कह रहे थे आप डेलीगेट्स के लिए वहाँ पे हैं, कन्वेंशन हॉल के नीचे डेलीगेट्स के, रेनू मैडम ने मुझे इन्फॉर्म किया। चलो भी कराओ पहले साथ में।
Let's start because he's waiting. We can just announce. Mimansa is waiting also. सबको स्क्रीन पे लाने के लिए what you have to do? Good afternoon, ladies and gentlemen. We are about to commence the next session. Professor U.B. Desai, Founder Director IIT Hyderabad, and currently Chancellor Anurag University will be with us online shortly. He is on standby. We are just patching him on for his talk, which is just due now. Thank you. Desai sir standby है, he is here. बस अपने को start करानी है game. That's all. है ना? Screen पे बस आया नहीं अभी तक वो. Screen पे तो यहाँ पे अभी transfer करते हैं, इसमें है वो. We'll have to see. उनकी presentation भी है. He would like to share his presentation. इसको वो दूँगा. What magic is to be done now? उनको actually screen पे लाना है. Professor Desai को he is online. Huh? We have to get him online. इसलिए नहीं आ रहा कि आपको इसमें डुप्लीकेट करना है. डुप्लीकेट वाला जो बटन होता है हमेशा करो आप तब तक मैं सबको आप उधर से उनको वेलकम करोगे. मैं भी आपको नोट देता हूँ. जस्ट गिव मी अ नोट. वी आर रेडी. से बंद करिए. प्रोफेसर देसाई देख रहे हैं? सर को बोल देते हैं.
Yes, yes, sir.
Right
You
now
have
I
the
can't
share
share.
permission.
I'll wait for a while. No? You let me know once I am there in front of the audience in a way. I'll start sharing it. Huh?
Sir is in front of the audience.
Sir, you are now in front of the audience only, sir.
So can I share?
Sir,
Sure, sir, sure.
I'll just introduce you first and then you can share.
No, one second. Let me just, the sharing may take a little time.
Right, sir.
Window sharing. Okay. Is my thing visible?
Sir, a blank screen is visible.
Oh. What happened? I did some. Oh, blank. Here it said I've shared it. So always stop sharing. I'll start again.
Sir, we can see. We could see you. You can just share it again.
Just share it.
Yeah, I'm trying to do that. Okay, let me see.
Sir, we can see the presentation. Please do it full screen, sir.
Okay, okay. You can see the presentation now?
Yes, yes, sir.
Okay. Let me go to the first slide so that will make it easier. You're able to see the title slide, right? Is it okay, the full screen now?
Yes, sir. Perfect.
Yes,
Hello?
sir. Perfect, sir. Yes, sir. Yes, sir. It's
Okay,
perfect.
okay.
Right, right.
Perfect, yeah. You can keep the introduction short. You don't have to say everything. You know, just
Yes, yes, sir.
Two,
A
three
short
lines is good
introduction.
enough. You know, 2-3 lines is
Right,
good
sir,
enough.
right.
Yeah.
We now resume the technical proceedings of INAE Technology Conclave 2026 with the first plenary lecture of the afternoon. Ladies and gentlemen, it is my privilege and honor to invite Professor U.B. Desai, FNAE Chancellor, Anurag University and Founding Director, IIT Hyderabad, to deliver the next virtual plenary talk on the theme Next Generation Communications. May I now request Professor Yubir Desai to kindly deliver his plenary talk.
Thank you very much, and I appreciate the brief introduction, a short introduction. That's really nice. So good afternoon, everyone. I hope people are able to hear me in the audience.
Yes, sir. Yes, sir.
Okay, good. Okay. So is everybody online, or there are some people who are physically present in Bhubaneswar?
Sir, people are present physically.
Okay, good.
And online
because, because I can't see anybody, I can only see my presentation, which is fine. Okay.
Right, sir.
Okay. So let me mention, see, my talk is a very general talk, you know. First of all, I'd like to acknowledge my colleagues who helped me prepare this particular talk. In fact, a lot of work that I'm going to present is technically not my work, but I was sort of partially involved in maybe mentioning it, suggesting it, and some degree of a little bit of mentoring out there. So the credit goes to Professor Kiran Kuchi, who is a professor at IIT Hyderabad and also founder of a company called WISEC Networks. Dr. Naresh Vatikutti, he works there. He's the head of product division at WISEC. And Sai Dhiraj, who was at WISEC at one time and now I think is adjunct faculty at IIT Hyderabad. I think they are the ones who, a lot of work has been done by Kiran Kuchi and his team by and large. Let me first start off, generally giving a broad perspective. See, there are a large number of technologies by which we are governed today and are going to be affecting us. I will not go through enumerating all of them. You can see a whole bunch of them out here, 6G, quantum, blockchain, natural language processing, space technology, okay, gene editing, the whole bunch of them I've stated out here. Artificial intelligence, of course, that's the flavor of the season. Everybody is talking about it. I'll also talk a little bit about that. Okay. And my focus in this talk is going to be more on 5G, 6G kind of technologies to some extent, but more on NTN, the non-terrestrial network part of it and where things are going. And I'll build up to it. It's not that on very first slide I'm going to start on NTN. And that's why I said satellite communication in time to come is going to play a very major role in how all of us are going to be connected ubiquitously in a pervasive manner, and covering practically every nook and corner of the global space. Let me also get my laser pointer going. Okay. So, these are some of the emerging technologies and to some extent emerging. Okay, 5G plus is there. Many of us, and in India, we don't truly have access to it, though our service providers claim they do. 6G is still emerging. IoT is there to some extent, but still it has not made the impact. AI in communication, currently, it's not quite that active, though sometimes people claim they may have some upgrades for your existing cell phones. But obviously AI is there everywhere and people are using it. Metaverse, that is augmented reality, virtual reality, that is coming in. And we are hoping that in time to come, it will come on our cell phones also. It has not yet happened. Software-defined radio, again, it has not taken off the way it was anticipated, say 20 years ago, more than 20 years ago, I would say, when a lot of research was being done. Even now, a lot of research is being done in software-defined radio. There are applications, maybe defense has a little more active application of software-defined radio rather than civilian applications. Quantum communication and computing, now it is very big. Okay, quantum communication is making a bit of an inroad. The QKD systems are coming into picture. Computing is still in its infancy, but yes, the hope is there and the future looks good. India also has a massive quantum mission taking care of both communication, computing, materials, technology. Free space optical communication, I just have one line at the end of my presentation on that part of it. Okay. My focus in this presentation primarily will be on what they call HTS. Very briefly, I'll talk about it, high throughput satellites. Then 5G, 6G and SATCOM. Satellite communication, not from the traditional way satellite communication using microwaves that was there. This is like the backhaul that we used to use, but a little more complex than that. Okay. Then NB-IoT and the work that WISEC has done in NB-IoT. I'll talk about massive MIMO, multi-input, multi-output systems, again used in SATCOM. There is a concept that we started at IIT Hyderabad called cell-free MIMO. Professor Kiran Kuchi has done quite a work on it. It is not quite part of the standard. Anyway, I'll briefly mention what it is, and that particular battle still goes on to get it into the 3GPP standards. A little bit on AI/ML and a fair amount of talk on cellularizing space. It's like space, the final frontier, right? You know, the line from Star Trek movie that is actually happening now in communication. Okay. What is HTS? HTS is, the reason I'm just giving is to give you a flavor of what HTS is. It is nothing very, very profound at all. It is frequency reuse, which is done in terrestrial network constantly, by which I can increase my bit rate because I'm using the same frequencies multiple times and I'm not asking for any extra bandwidth. Okay, I can also reduce my cost of communication. Now, the same concept also is applicable and applied to some extent, to a large extent, even in space communication. Okay, so the diagram at the bottom shows how frequencies are being used. You have 3 frequencies available to you and you make sure that there are 2 frequencies which are 1 hop away. So if there is 1 here, there's 1 out here. So there is no interference between the 1 on the top and 1 at the bottom. And the same thing with 1, 2 and 3. That's the basic concept, and in space it will be a little more different because everything is going to happen in a space environment rather than a terrestrial environment. Now, this is like one picture giving you a perspective on how telecommunication is going to evolve, and we are almost getting there to some extent. We are not too far away from it. For example, the terrestrial part is at the bottom. All of us are using it, ground mobile communication. We are all part of it. Of course, fundamentally, we are using 5G. And some cases, some countries do have a little bit of that 5G plus. Okay, India claims, but in my opinion, we are still, in fact, I would say it is 5G minus. I've had access in 5G, which goes from, 1 megabit or even less than 1 megabit per second to 300 or 200 megabits per second. That kind of variations is not a very healthy sign. Okay, what is coming in is what you see on the top, low Earth orbit satellite access network. Okay, this is going to be very, very big, and this is where you can see we are really going to create a cellularization of space. The way we have cellularized the ground area, there are cells all over the place and cell towers are there. Essentially, cell towers will get replaced by smaller satellites. I'll talk about it at the end of my presentation, CubeSats or PicoSats. Okay, and that's how it is going to be. Okay, and now the challenge is how do we have low latency, very seamless communications between satellite and the ground-based mobile communication system, which is already existing. All of this is based on a standard. In case of satellite communication, there is one big player which does not observe the standards, is SpaceX or Starlink. Starlink does everything on its own, and it is not part of 3GPP. Otherwise, all telecommunication that you see, mobile communication on the ground and other places, all wireless communication, subscribes to the standards which are there in 3GPP so that there is very seamless interoperability wherever you are in the world. It does not really matter, which service provider, which cell phone, the mobile instrument that you're using, where you are in the globe, immaterial. And that is because of whatever work that 3GPP has done. And as you can see in the standard, we are currently at this particular point. Okay, roughly around release 20, end of release 20. 21 is still to come. Maybe it will get delayed a little bit. And 2030 is when we expect 6G. Now, usually there is always a delay. So we expect 6G in 2030. But it may be that 6G minus will be there in 2030, like it happened with 5G. And the true 6G may be 2031. That's why one has put 2030 plus. Okay, so we still have a fair amount of time. And one of the reasons I'm saying is that mentioning this slide is India is participating very actively in 3GPP standard. The activity started a long time ago by setting up TSDSI, Telecom Standards the Development Society of India. Okay, and they are very active. Professor Kiran Kuchi is one of the persons who goes to many of these 3GPP meetings, and it is not that easy to get your technology into 3GPP. Even if you have something very profound, very all tested, it's more of a techno-commercial discussions out there. And there are heavyweights like the Ericsson, the Qualcomms, the Nokias, the Huawei's, and it's not so easy. But I think we have made quite a few inroads over the years, because of a lot of activity that started. I think TSDSI was formed. I don't have the exact dates with me, but I think it was around 2019, 2018 timeframe, maybe a little earlier. Don't take the exact number from me, but fair amount of time, at least roughly about 8 to 10 years ago. And we have come a long way. In 6G, there are quite a few things that we have been able to push through in 3GPP. And I must compliment Professor Kiran Kuchi and of course the TSDSI team for getting some of the standards into it. Okay. The way forward from 5G to 6G and the role of satellite communication. One of the reasons one is pushing for satellite communication is to create universal coverage. Even if you look at India today, if you are in a metro or in a tier 2 city, tier 3 city, you will have some coverage. Moment you get to the hills, I've not done it recently, but if you go, say, from Chandigarh to IIT Mandi, earlier I used to travel that, you go through the whole hilly area of Himachal. And by the way, Himachal is much better connected than many other hilly areas. Like if you go to Uttarakhand, it is much worse. Okay. Even there, you will find that you will not have proper connectivity once you are in certain segments of the hills. Okay. If you're going on some of these yatras which are there, Mansarovar and others, certainly you will not have proper connectivity using your normal mobile phone. Okay. Not just because of security. There are no connectivity is there. There are hardly any cell towers out there. There is no fiber. Even if you have microwave backhaul, it's still not that well developed. So your connectivity is extremely poor. Now, how do we create this universal coverage? One approach is used to use sat phones. Sat phones will give you that coverage, but you don't get the data rate that you want. B, you want to integrate the sat phone with your smartphones. And I'll talk about Vodafone, what Vodafone has done in actually launching it, though not commercially, but they have demonstrated that it can be done. Okay, so A, you want very high data rate on SATCOM, the kind of data rate we're used to based on fiber, okay, and the mobile connectivity that we have today in metros. And also, it is connected through satellite communication. Okay. The common user equipment. So the constraints are that I don't want to have a separate sat phone. Many of you might have seen it. In movies, we see it. In real life, I keep joking, there are only two groups of people who have sat phones today. One is, of course, our defense. Okay. They have sat phones. The strategic groups have sat phones. And, of course, the terrorists. Okay. Otherwise, normal civilians, it's almost impossible to get a sat phone. Okay. So, how can I enable sat phone capability on the smartphone that you have today in your pocket? Some of the work that has been done as a beginning in terms of getting, not quite satellite, but I think that is the beginning that is taking place, is what we call fixed wireless access. It is there. It is not, this is not, WISIG is not the first to do this particular part. Others have also done this particular thing abroad, and I think even Airtel and in certain pockets, Airtel and Jio are offering this kind of a service. And so what happens in remote areas, you still need a tower. So suppose you have a tower which is 20 kilometers away, 15 kilometers away, okay, and that's what you happen, Then, so this is the tower as an example in this village called Chimnapur, which is close to IIT Hyderabad. The tower is on top of IIT Hyderabad. Chimnapur, maybe as the crow travels, maybe about 2 kilometers away. By road, it may be 5-7 kilometers away, maybe a little longer. Okay, so this village has proper access. The other place where the implementation has been done is in NIMS hospital. Okay, and whatever measurement WISIG have done, roughly 1 terabytes of data is being used. More data, of course, in NIMS hospital. NIMS is equivalent of, in the sense, AIMS, but it's a local Nizam Institute of Medical Science. Okay, while this is a small classroom that you see, and it is accessible on the TV monitor on top out here. This is a village level school. Anybody who has been to some of the small villages, you would see most schools like that. They don't look like the schools that we see in metros. Okay, okay. So they have access because of the tower that we have installed at Chimnapur, at IIT Hyderabad. Okay. And we use the IIT Hyderabad backhaul. Here the backhaul is from T-Fiber, Telangana Fiber. They are providing it. They are trying to set it up in several other places, Nizamabad, okay, which is a tribal area out there in Manala, and of course in Ramakrishna. Sorry? Sorry? Any questions, please? Okay.
None, sir. My mistake.
Okay. Okay. Yeah. So, and Khammam, that's where they're setting it up. So fixed wireless access is like beginning that is happening. It gives some extent, some internet connectivity in areas where there is no proper telecommunication. But still, this is not working extremely well in hilly areas because you still need it at least maybe 10-kilometer distance or 15-kilometer distance or 7-kilometer distance. Okay, in hilly areas that is still very difficult. Okay, so SATCOMs will come into picture. What are the key areas that are coming in telecom? In my opinion, this is again my perspective. Somebody else gives a presentation, they may have a slightly different perspective, but broadly, I think all of us are on the same page, maybe slight variation in terms of what we want to emphasize. These are the 6 broad areas that I would sort of see. The first one I'll talk about is extreme massive MIMO. This way, we can actually really increase the data rate and increase the coverage also. It can adapt, people are working on multi-antenna systems which can adapt to any geometry. I'll talk a little bit about that, one slide on it. Spectrum reuse is much more extensive than what you see, what I described earlier in my first slide, or the third slide, I think. Okay. And I think so in that sense, massive MIMO is very important. Massive MIMO means, today MIMO is there, by the way. Your cell phone also has multiple antennas, but sometimes it varies from 2 to 5 or 6 or something like that. But here we are talking about minimum of 32 going eventually up to 10, 24 antennas. It's a large system out here. Okay. Distributed massive MIMO. Okay. No concept of cell. This is something that we have proposed. Okay. So it is not currently operational in any technology. Neither has 3GPP accepted it. Okay. But it requires a fundamental change, But we have done the testing of this in IIT Hyderabad and it is working, it works. So that proof of concept is there, but beyond proof of concept, one has not gone beyond it. I'll talk a little bit about it. So as I mentioned out here, it is being debated. At one time, Kiran Kuchi was trying to push into 3GPP, but then I think right now also he's still trying, but there are other things that we want to push a little more urgently, so the emphasis has changed. Okay, so this is the setup that we had at IIT Hyderabad. What you see on the right-hand side is a big lab out here. So in a sense, the same equipment is used for base stations as user equipment, equivalent of cell phone. What you see out here, okay, and what you see up here, these are the massive MIMO antennas out here. So there are a whole bunch of antennas. I don't forget the exact numbers out here. Yeah, 24 to 48 users per sector. That is what we have. So with massive MIMO, you can have much larger number of users per sector out here, as opposed to 8 to 16 that we normally have in current technology. And you can have a spectral efficiency of close to 30 bits per second per hertz, which is extremely high. Today, probably we have something like 2 to 3 bits per second per hertz, or maybe 5 bits per second per hertz at most. So you can get a massive jump in spectral efficiency. So thereby you can pack many more bits for the same spectrum. Keep in mind, spectrum is the most precious resource. Okay, and if I can send more and more data on the same bandwidth, I can provide connectivity at internet access for a much lower price, and you can send much more data, and cost will be much less and much more efficient. Now, so what we are proposing will require new MIMO scheme, new interface removal algorithm, new antenna pattern, new cell-based specification, a lot of new things, but MIMO is there. I think this is something which has already been pushed into 3GPP. The plan is to introduce these techniques. Now, what happens is this is the way we have done it. Now, what goes eventually into standards may be partly what we have done, partly what others are doing across the globe. Some of the names that I mentioned earlier, the big telecom companies like Qualcomm's, Huawei's, Ericsson's, Nokia's, Vodafone's, etc. Okay. This is a big area. This is not quite commercially implemented, but it is there. So-called reconfigurable intelligent surface antennas. A lot of work in India is being done. I think MIT has supported many projects in this particular domain. Samir is one of the big organizations which is actively working on it and developing. The whole idea here is that I may not have to put up independent base stations with big antennas out here. As the picture shows, I may have just a massive MIMO. This whole array is out here, and the antenna pattern will take the shape of the building. So in some sense, if you design the building aesthetically, you won't even know that there is an antenna pattern out there, and there are antennas out there which are communicating. It becomes part and parcel. Even if you have a curved surface, this antenna can take that particular curved shape. Even if you have things going in and out, you can kind of manage that particular part. So this is really a very interesting concept. A lot of work is going on, and I think maybe in the 6G standard, eventually when 6G gets implemented, so-called reconfigurable intelligent surface antennas will also get implemented at a particular point in time. The next thing is next generation so-called mobile MMTC satellite communication. This is basically massive machine type of communications. Essentially, right now, most communication involves human in the loop. Here it will be machine-to-machine communication. When we talk about Industry 5.0, etc., key thing out there will be machine-to-machine communication, and it can be done through satellites, so that the access is 24/7. You are not really dependent on towers which function properly. If the power goes out, sometimes towers have difficulty. Nowadays, you'll see in the Maharashtra area, particularly Bombay, Pune, with heavy floods, many of the towers were dysfunctional. Of course, slowly and slowly you bring them up. Okay, so this is a big thing, and if you want Industry 5.0, then machine-to-machine communication is going to be very, very important. And what we would like to do to make it very reliable and ubiquitous is to have MMTC via satellite communication. And this will be also useful for IoT. And I'll talk about NB IoT, which is actually developed in collaboration IIT Hyderabad and to some extent WISEC. Okay, distributed massive MIMO. Okay, that is something which I mentioned earlier. So one is trying to push it, but it's not easy to push some profoundly new technology into 3GPP. They by and large go with incremental technologies, and if this were to come from some giant company, then the situation could be different. The story could be different. Okay. So what one is looking at, there is no concept of a cell. We are talking normally as a cloud. Okay, there's a huge cloud, and what you see are these are all the user equipment. This is the wireless front hall. So essentially, you are communicating to a central base station. Okay, there is no handoff concept. As you are moving, this base station then communicates to a central processor. Everything is fiber connected, extremely high bandwidth, high speed connectivity. Okay, and all the processing takes place out here. So in some sense, a lot of intelligence and a lot of processing is now transferred, not through, you don't have towers at all. You have one big tower in some sense, if you wish, and it goes to, as we call it, as a central processing unit. And here also we could use the concepts of high throughput satellites that I talked about, very similar to that. So basically, joint processing of signals in the user equipment and within the supercell or the cloud, okay, and at the CPU. I think that CPU, so some processing will be here. So your equipment or the mobile phone that you have with you in your pocket will also do more processing, but bulk of the processing will be at the CPU right now. Right now, cell towers do very little processing. They are more like a forwarding mechanism. That's essentially what the cell towers will do. This is a concept established, it works, but getting into commercial or getting into the practical part is a different battle altogether. Okay. Next generation integrated access and backhaul. I did talk a little bit about it earlier. Basically, it is universal communication. Essentially, convergence between terrestrial network and satellite network. Okay, and that convergence is complicated. It is not as simple as the convergence that we used to talk about earlier, and that's why it's taking a little longer for this thing to be launched. Okay, this is a broad setup of how it works. Let me skip this for paucity of time. I'll show you. This is what Vodafone has already established: direct to smartphone satellite service. This is a demonstration. Commercially, they are, I think, working on it. I think I read that maybe in 27 or maybe late 26, it may actually be available commercially in the UK. So you have your ordinary smartphone, as you can see out here, communicates to these, let's call them miniature satellites. They are like picosats or CubeSats out here. From there, it will come to a ground base station out here. And then once it has come to a ground base station, your call will then go to the terrestrial network and come to a sat phone, which may be connected to one of the towers out here. And the same thing will go back. And they have shown multimedia communication. So they went and put this particular cell phone in a mountainous area in UK, where there was no other connectivity whatsoever. Only sat phones would work out here. And they have integrated the satellite communication module into the smartphone that you see in the picture out here. Okay. So this is the kind of scenario, so-called convergence between terrestrial network and satellite network is what we are looking at out here. I presume, I've not done the research and I've not checked it out. Other companies also have something in it. Very rarely it will be that only one company has something on this particular part, because everybody is looking at it. The problem, everybody is aware, everybody has a solution, but you want to come up with a solution which is interoperable and accepted by 3GPP standards body. In this context, a lot of work has been done at IIT Hyderabad on so-called NB-IoT, narrowband IoT. This is 5G standard compliant IoT. It has been quite some time. I think almost it took nearly 6 years to come up with this chip. And this is an SoC, system on a chip. In my opinion, system on a chip is far more difficult and complex than developing a processor. India has several processors. I think there is this Ajit processor, then Tejas processor or something, and I forget. Then there is a processor from IIT Madras. They have a certain name. A colleague of mine, Madhav Desai from IIT Bombay, has developed a processor. So we have several processors. SoCs, I think there are very few SoCs that have come from India. Off the cuff, I can name two. One is this NB-IoT, which Kiran has done, and NAVIC. Many of you would have heard ISRO came up with the NAVIC chip. NAVIC is also an SoC. Point is, in SoC, it is not simply a processor. It's integration of the analog module, there's a low noise amplifier, there is a front end out there, there are DSPs into it. So essentially, you take IPs from different organizations, different vendors, and integrate it together. Okay? And that's what makes it very complex, because everything has to come together and work together. And each one comes from a different vendor. Processor, everything is yourself. So it's a lot easier to kind of handle that particular part out here. This is fully functional. What is in fact important to notice is that here, WISEC and IIT Hyderabad have had collaborations with several companies. One is Sharp in Japan and Viasat. Viasat is a big telecom company, a satellite company. Okay, and Viasat has validated this particular chipset. And we are hoping now they will start using it in their systems. And some orders will come, and India will get some kind of visibility internationally. That NB-IoT chip used internationally. Similarly with Sharp also. Sharp also plans to use it. So currently it's like initial trial phases are there. Once they're fully convinced, hopefully we should get certain action and the chip should be there in the international market. AI-enabled networks. This is very big. It's not currently there. Whenever they say, you may buy a phone which says AI, ML and all, actually it is not true AI, ML, a little bit here and there. It is like something equivalent. Years ago we used to buy washing machines and they said they had fuzzy logic. It was a nice marketing gimmick. Okay, so a little bit of that is there. The real thing will come in 6G because a fair amount of work. So this is not like Chat GPT or LLMs out here, but we want to use these deep learning neural networks, kind of the picture I've shown out here on the right hand side, for things like more efficient interference reduction, better handover, faster handover, low latency out there, minimize call drops, enhance signal quality, enhance efficiency of power and power efficiencies out here. So you can do better. Enable dynamic network deployments out here. So things can go, when you turn your phone on, it takes much longer to connect sometimes. So those sort of things will be much faster. Enhance MIMO performance. Okay. So the whole idea is that this will be a very different kind of an application for AI ML. It has to be embedded, the application, into your smartphone. Towers can do it. They have a lot more processing power. It's a lot easier to do it out there. But we want some of these things onto your cell phone itself. Okay. And we have to work on it. So this is going on, and my hope is that this will definitely come, not hope, I'm almost certain, in the 6G version of telecommunication. Okay, some of the pre-6G work is already going on at IIT Hyderabad and WISEC, and this is just a picture to say that yes, they have a 32 transmit receive MIMO system fully operational, which is being used for drone detection. These are all demonstrations, by the way. They are one level above proof of concept. Okay, so this is not proof of concept. If you say proof of concept is TRL3, TRL4, this is like TRL5, TRL6. We are trying to approach TRL8 and 9, not quite there. Point is that this is indigenously developed. We need a big push from the country itself to make sure that some of these technologies get accepted by 3GPP and we have presence in the global market. Now let me talk about this CubeSats out here. How does this satellite communication that I've been talking about, or what Vodafone is doing, kind of works out here. There is this big emphasis on developing satellites, which they call CubeSats. As you can see the dimensions, 10 centimeter by 10 centimeter by 10 centimeter. It's 1,000 cubic centimeter. That's the size of that small satellite which is being tossed off. So these are that, you can call them mini satellites or micro satellites. Okay. And initially it was envisioned that this way we will have pervasive education, but today it is being used for regular telecommunication. And it has already had a big impact out here. There's a nice survey paper which I have referenced here. You can just Google it and you'll find it. It talks a lot about CubeSats and how they can be used in telecommunication. It's a 2019 paper, 7 years ago. So this concept is not new. In fact, this concept, like a small critique, I will say, many people, including myself and the team that I had, we talked about it. but investments are too heavy. We never got funding to implement this particular part. Okay, it's very difficult to get because satellite is part of a strategic initiative in the country. So how do you get access to it? And how can you have large number of satellites, CubeSats? One or two satellites will not do the job out here. As you can see, you have towers on ground. Similarly, these are, you can think of them as base stations or towers in space, and those are nothing but CubeSats. And these are all multi-band. Okay, this is how a typical CubeSat looks like. I think this is a picture that I've taken from the paper of one of the IEEE magazines. I don't recall off the cuff. I should have put the URL out here. Okay, the main problem is new protocols are required. The physical layer development will be somewhat profoundly different out here because you want this to interoperate with terrestrial network. Okay. MIMO will be incorporated. You cannot really do this without MIMO out here, and EIML schemes also will come into the picture in this case. What is rather interesting and also something of concern, Starlink is a leader in this. Okay, they already have a constellation, as all of us are aware. SpaceX went public, and I think the whole IPO was more than $1 trillion, if I'm not mistaken. Okay, now how much more I don't recall right now, but certainly much more than $1 trillion. Okay, it is providing coverage at the moment in 60 countries in the world. Starlink, by the way, though not that expensive. It is expensive, though not that extensive, I would say. India in principle has given approval to Starlink, but they don't have permit to start deployment. There are some discussions going on with DOT, and I think soon, hopefully, Starlink will have presence. Unfortunately, Starlink is not interoperable in the sense it does not interoperate with GSM, the 5G technology that we have. They have their own thing. So it will be good internet access technology, but you'll have to see how we can integrate with your cell phone. There'll be a Wi-Fi, and through Wi-Fi you can integrate, but there is no seamless integration that you have. See, right now what I mean by seamless is that you can migrate from Jio to Vodafone to Airtel network without any worry because they are all standard compliant. It doesn't really matter. Okay. So the concern that I have, and that is bullet number 3, okay, as of mid-2026, there are over 10,400 active Starlink satellites. And this is more than 50% of low Earth orbiting satellites that are owned by a single company, namely SpaceX/Starlink. So for others to make an entry is not that easy. Already Starlink has created a major entry barrier by being a massive fund runner. See, they invested very heavily, knowing that this is what the future is going to be. Okay. They are large flat panel communication spacecraft rather than standardized CubeSats. So what I mean by large flat panel, if you can see this, they're somewhat like what I showed in the photo. You see out here the small one? So satellites look like this, flat panel satellites. So they are akin to CubeSats, but not technically CubeSats, what you see out here. Okay. Then SpaceX subsidiary Swarm Technology operates constellation of approximately 120 to 150 space DE satellites. These are tiny pico satellites measuring 11 centimeters by 11 centimeters by 2.8 centimeters. So this is roughly about 300 cubic centimeter is what we have as far as this particular technology is concerned. And these are used for global internet connectivity. In fact, the NB-IoT can be used in this particular domain out here. Okay. So this is actually coming up in a very big way. Okay. It is there operational in US. Of course, Starlink is present. Anybody who has, it's not cheap. It's still expensive compared to the usual internet access that you have on your mobile phone. Okay. But if you have a house which is way up in the mountains, your whatever summer home or your vacation home, okay, then you can go there and use Starlink connectivity out here. Okay. Starlink connectivity out there. Just give me 2 seconds, a small interruption. So what I'm saying is that SpaceX is way ahead of other people. Viasat is trying it. There are many others in India who are trying to have collaboration with Viasat. I don't recall the names of operators, but there are service providers, telecom service providers, who are trying to have collaboration with Viasat. But the lead that Starlink has is too far ahead. Okay. The other part, last slide out here, last but one, is optical free space communication. Many of you would have heard of it. I won't say much about it. This is very, it is there. It gives you a tremendous bandwidth, but ultra sensitive and requires a lot of power. It's not easy to have a laser going somewhere from satellite to space. Okay. Alignment is a big problem out here. Slight disturbance somewhere and you can. So in principle, it's a great concept, but I have my doubts whether this will really see any civilian application. Perhaps in high-end defense application, it may find some room. Even there, sustaining it will be a big expense, and there I don't know exactly how it's going to work. But I thought it is worth mentioning because this is something where a lot of researchers are spending their time looking at, optical free space communication, particularly from satellite to Earth. The last thing I'll mention, this is an interesting thing. I don't think anybody in India working on it, but this is where countries like US why they have a leadership role. This started way back, when the Mars rover was launched and it landed on the surface of Mars. Vinton Cerf, many of you have heard of him. He is the father of internet. Okay, he's one of the very famous persons who was made pioneering contribution to what we call internet today and what all we are using. The TCP/IP he was one of the co-authors of TCP/IP. Okay, so he was giving this. He narrated this story that as soon as it landed, he flew from Palo Alto, a Mountain View area where Google is located. He flew immediately to Jet Propulsion Lab in Pasadena and started talking to people that how are you communicating with the Mars rover? Of course, they were doing traditional microwave communication. At that time, he said, why can't we create something equivalent of an internet for interplanetary communication? See, problems are very large. A lot of you might have read, that Voyager now today, okay, is about one light day away from the Earth. So if Voyager sends a signal just now, you will receive that signal 24 hours from now. Okay, that is the kind of latency, or that is the kind of delay, I should say, no longer latency, it is more of a delay. So a lot of work, and this is something they started almost more than 20 years ago, interplanetary communication out here, end-to-end information flow across the solar system. Now that's a very jump in thinking. We are still struggling with terrestrial networks. To some extent, we have low Earth orbiting satellite, but here we are jumping to the whole solar system. IP-like protocols suit able to operate over long round-trip light times. You're talking of light days. That's why the word light times out here. So this is a very important and very difficult thing. And when he gave a presentation, I asked also that how can a country like India participate in this? We don't have access. He says you can still work on certain protocol, and there are some open source domains where they will do the testing for you. I have not experimented with it, but I think I would certainly encourage a lot of young researchers who are looking at some very, very innovative topic, where more of a curiosity-driven research rather than a translational research which will see light of day maybe a year from now or 2 years from now. This may not see light of day for maybe another few years. I don't know how long it's going to take. Okay, but I think, as a young researcher, if you want to do some curiosity-driven research in telecommunication, this may be a very interesting topic for you to look at. So I'll end my presentation saying that there are many technologies in the offing. The whole domain is very rich. It is very dynamic. Things are changing at extremely fast pace. Lots of interesting things, very exciting area. Researchers to spend time and look at and work in this particular domain out here. So these are AI, ML for SATCOM, high frequency, frequency reuse technologies for SATCOM, quantum communication, that is very big coming in, optical laser communication that I mentioned. In labs and in certain specific campuses, you can try it out and it will work. But even implementing that in a small campus, the free space communication is not a trivial exercise. Obviously, there's a full open problem, universal communication, cellularization space, MIMO is still there, etc., etc. So you have, even people who develop satellites. India, ISRO said at one time that they are looking at satellites, and I don't know whether ISRO has developed it or launched it. Okay, one has to find out. But I don't think they have looked into CubeSats or PicoSats. maybe India should actually focus, if you want to get into the satellite telecommunication space, on CubeSats and picosats. So thank you very much for giving me this opportunity, and thank you very much for listening to me. I will stop my presentation at this point. If there is some time, I'll be more than happy to answer some questions. Hello.
Allow me to introduce to your colleague, sir.
Sorry, there is a echo. I can't hear. I mean, it's not very clear. You know, your voice is not at all clear. See, I can hear my echo also. Some issue is there by having more than one system which is on. I hope this was not the problem when I was making a presentation. Colonel Rai, I hope my presentation was audible.
He is just out of the eco zone.
Okay.
I am with Professor Manna, sir. I think I will request him to do the honors. So thank you formally, sir.
No, that's not required. I'm saying if the audience has some questions, I would be more than happy to take some questions. Maybe it will be also a learning experience for me, because they will ask something which will trigger my thinking. Are there any questions, either audience online or offline? You have that provision or you don't have that provision?
We don't have a provision.
Okay, then forget it. Okay, then forget it. Okay, no problem. Thank you. Thank you.
The problem is this is a 1500 capacity hall.
Oh wow. Okay. So
and the audience is all scattered.
Forget it. Okay, then I understand. It is very difficult to have Q&A.
I just inquired with Cornell. This entire lecture is actually in real time beamed through YouTube.
Oh, wonderful. Okay. Yeah.
And I don't know whether you're going to get it. So the recording will be played again and will be curated and presented.
Sure.
But certainly it was a very, very illuminating talk.
Thank you.
And I'm sure the younger generation will have benefited a lot from your presentation.
Yeah.
But I have some questions, but which I'm going to share with you in private, not now.
Sure. Anytime we can discuss that. Yeah. No
right.
problem.
Thank you so much, Uday.
Okay. Thanks very much. Okay. So I'll log out now. I'll stop sharing.
Yes, sir.
Okay. Thank you. Okay.
Ladies and gentlemen, we now come to one of the most engaging segments of the conclave, a panel discussion on the theme Transportation and Logistics. It is my privilege to invite Professor Manoj Kumar Tiwari, FNAE Director, IIM Mumbai, to organize and moderate this distinguished panel discussion. Joining him on the panel are Professor Geeta Krishnan, Department of Civil Engineering, IIT Madras, Professor Debjit Roy, Center for Transportation and Logistics, IIM Ahmedabad, Shri Pushkar Singh, Founder and Chief Executive Officer, Let's Transport Bengaluru, and Mr. Rajiv Agarwal, former Chief Executive Officer, SR Ports. We are privileged to have such an eminent panel representing academia, industry, and logistics leadership, and we look forward to a stimulating and insightful discussion. May I request Professor Manoj Kumar Tiwari and all the esteemed panelists to kindly come forward and take their seats on the stage. Ladies and gentlemen, please join me in welcoming our moderator and distinguished panelists with a warm round of applause.
चार हो तो अच्छा है, तीन चलेगा।
Respected INAE President Patil Sahab, Vice President Professor Indrin Mannaji, and other office bearers of the INAE, along with my revered Professor Damodar Acharya ji, who is here. And today we have been assigned a task to have a panel discussion on one of the very important and useful topic that is pertaining to the logistics sector of the country, that is the integrated logistics and digital transformation for multimodal logistic parks, enhancing connectivity and efficiency. And along with me, the other panelists who are here, they are basically some of the renowned persons in different domains, because I have divided this presentation altogether into the 4 different domains. One is that how the port, rail, road connectivity is there. And for that, one of the experts whom I know since last so many years, Mr. Rajiv Agarwal, former CEO and MD of ISAR Ports. Agarwal साहब, थोड़ा सा खड़े हो जाइए सर एक मिनट, ठीक है? Yes. बैठिए सर. He is leading expert in the infrastructure, shipping logistics, and port development and management. He is currently running his own business and consulting by name InfraSeek Solutions and Amarwell Solutions. With 38 plus years of unparalleled experience in industries like ports, shipping, telecom, retail, and business processing outsourcing, he is guiding organizations to achieve excellence and experienced leader in the maritime industry with a passion for creating transformative business solutions. My another co-panelist is Mr. Devjit Rai, Professor Devjit Rai. He is a PhD from University of Wisconsin-Madison and currently a full professor at IIM Ahmedabad. He is one among the persons who has been very early stage by breaking most of the record, has been declared as a professor for his outstanding contribution in the domain of logistics and supply chain management. He has having parallel assignments at Rotterdam and business schools in the University of IMMT, USA. And Professor Devjit holds PhD in the industrial engineering with major in decision sciences, operations research, and minor in the computer science, and MS in the manufacturing systems engineering from the University of Wisconsin-Madison, besides an MSc engineering from Indian Institute of Science, Bangalore. His research focuses on improving system performance using quantitative methods such as stochastic modeling and optimization. His specific research interests are in the estimate of performance of logistical services and systems such as container terminals, automated distribution centers, vehicle rental, healthcare, and restaurant systems. He has received several research awards including II Transactions, Best Conference Paper Award, Facility Logistics Award, and honorable mention of Jack Meredith Best Paper Award in the Journal of Operations Management. And these are the journals which are one of the most tough to publish, and because of his very innovative ideas, he has been awarded from the Rotterdam School of Management, Erasmus University. So this is the Devjit Raji, and we have here to discuss some of the recent trends in the automation of warehouses. We have another very leading expert from the IT Madras, Professor Geeta Krishnan Ramadurai. He is a professor of Department of Data Science and AI in the Badhwani School of Data Science and AI at Institute of Technology, Madras. He is also faculty in charge of mobility and intelligent transportation, collaborative and industry governance academia, a collaborative effort in working towards building a digital public infrastructure for mobility. He is co-lead in the FedEx Smart Center at the IIT Madras. He is basically a bachelor from IIT Roorkee and then did his PhD from RPI and then joined IIT Madras actually. So one of the prolific researcher, and we chosen him because of his large scale contribution in the logistics. And we have another very interesting figure here, who is well known in young age to have one of the fantastic startup, Let's Transport, in the Bangalore. And currently his annual revenue generation is around 1,000 crore rupees. And he is basically a dual degree graduate from IIT Kharagpur. And my luck is that he worked with me for one of the projects, and that led to one publication also. So on my request, he is here to attend this panel discussions on the important area, particularly last mile delivery. So with this particular introduction to all the panelists, now I just want to focus on that what are the topics that are of much importance in the domain of particularly multimodal logistic park, and what are the related problems into that actually. Next slide, please. As you can see, we have a tough problems to see that how the logistic cost has changed in last 10 years. We used to call that 12 to 14% of the GDP, but recent study by the DPIIT as well IIT Madras also, they found it that it is 7.9%, and that is almost 26.62 lakh crore rupees. And ideally, it should be somewhere around 6% of the GDP. Perhaps target is that only. And idea is that to see that how the both logistic cost as well as the data LPI, that is the logistic performance index, this should improve. As per 2023 study, it is 38 and improved 6 positions as per the NCAER study report actually. Next slide. So as you can see that Indian freight is overwhelmingly road dependent. Mostly you can see that 65% of the total traffic by road, rail around 25%, coastal shipping 5%, pipelines 3%, and inland water is around 2%. And you can see the cost of items that you want to move per metric ton, per million tons, as you can see, that around 2.28 rupees for the cost of around 2.28 rupees per ton kilometer is the road. And rail is 1.4 rupees per metric ton kilometer, and inland waterway is 1.2. So cheapest is coastal shipping. A road is so high, but you can see 65% of our traffic is moving on the road. So region you can understand that why it is so costly. Then you can see that how this overall cost of logistics you can divide into different modes of transportation. So the moment you call, so there are 7-8 parameters which decide the cost. One way you can say fuel and energy, labor and crew members, maintenance, infrastructure charges, asset cost, insurance and taxes, along with the administrative overheads. And altogether you can see that for road, rail, coastal shipping and inland water, they varies significantly. And highest you can see that fuel and energy charges is 43%, and that needs one of the big problem actually. Then in multimodal system, as you can see that there are different modes and we want to integrate them. So how the rail is connected with the port, how port is connected with the road, and what are the difficulty. So recently we are solving a problem with the Comptroller and Auditor General of India for multimodal transportation. There we found that the GST charges which they seek from the road and rail is found that slightly better for those operators who are using road and slightly costly for those who are using rail, because rail's last mile connectivity is not good. So because of that, rail is not one of the best options. And many times it is also observed that terminals of the rail is not available very near to the port also. That also creates many times problems. And because of that, in order to improve all these things, the concept of multimodal park came into picture. Means multimodal park means a space around 35 in nature that has been conceived by the government. And these 35 current multimodal park locations, they have decided in different parts of the country, where all the 4 modes of transportation, they meet each other, and from there only all integration aspects like digital transformation will take place, so that cost can come down like anything. Another effort is there with the help of several softwares that has been developed by the different agencies. Like I will show you that how the ULEAP, FOIS, etc. they are working together, but they are working in different silos actually. So you can say challenge of the multimodal logistics, if you see, the first week, last mile connectivity. Second, rake availability by the rail, limited siding terminal infrastructure, means where there is no railway line in and around that place. Low mechanization at the interchangeable points, asymmetric costing subsidies, and fragmented documentation and liabilities. So these are some of the challenges, and other also like port congestion and dwell time, high detention demurrage cost, capacity mismatch at the hinterland ports. So they are actually adding to the cost, and then inadequate rail connectivity, lack of real-time cargo handling, and multiple regulatory custom touch points, they add to things to make it more tough actually. So keeping that in mind, 35, the multimodal parks, logistics parks have been conceived. They are planned across India's key freight corridors. And idea is that 10 to 12% total logistic cost will come down, and 20-25% improvement in the cargo turnaround time, and 15-20% reduction in the inventory holding requirements actually. So with this particular purpose in mind, this multimodal concept has been brought into the picture. And major research issues that has been noticed in the multimodal logistics are mode selection and route optimization. Because of this issue, you can see many times a truck is moving from Bhubaneswar to Delhi with a full load, but while coming, it may not have even half of the load, or it may come empty. So that is adding cost to the logistics system actually. So if you have a proper coordination among different entities, and there are many the IT service providers where the single window concept, you can log in and tell about your load. So that way, that problem can also be come down up to some extent. Then intermodal coordination, like delays due to congestion, custom clearances, loading, unloading, they are very common in the logistics circle. Then dynamic uncertainty, as you have seen recently, the tamasa of the Trump and all those geopolitical situations, fuel prices, they all are going to aid this dynamic uncertainty. And of course, there are different choices like how to balance between the cost, delivery time, vehicle utilization, etc. So they are adding further the problems of research. And then data fragmentation, like how the integrated structure of data and big challenges between shipping, truckers, railway, ports, customs, and there are softwares like ERP, and how the system for transport management systems, warehouse management, GPS, IoT sensors, they are different kind of entities. They are not having any common points actually. So they also need to be synchronized with respect to the proper protocol. And sustainability is another issue, because most of the European goods, they want certain level of carbon emission to be reduced, and then only they will procure the things from your side. So many of the sustainability issues with respect to the ESG, they are posing key challenges to us. And then real-time visibility of the cargo, both whether it's shipping, railway, road, they need to be figured out by proper IoT devices and other methods. And also the current way of GPS GIS systems. Then you can see multi-stakeholder coordination is one of the well-defined things for multimodal systems actually. And automation and robotic enhancing multimodality, this is the way how unloading and loading operation need to be performed in a large scale. Because our system is not so efficient, that is why they are being recommended with the AGVs, particularly Singapore port you can see where this kind of things are very common and their productivity has increased because of the both AGV and robotic operations actually. And after this, the automation and robotics operations, they enhance the many multimodality concept, that is how the RFID and OCR based gate automation, then many of the e-seals that actually manual checks going by the sensors, telematics, and similarly there are robotics process automation. Documentation is required where the bills and bills custom clearances, they need to be simplified actually. And coming to same point that many of the recent AI applications, which I think Geeta will talk in detail, where we have the LLM application, large language models, particularly for multimodal logistics, with business challenges like vessel delays, route selection, temperature compliances, and also the port congestions, automotive supply chain, e-commerce, last mile delivery. They are very common, and I think recently we have seen that how Let's Transport with Pushkar is here, they are using LLM actually to find out the better route planning in the different component of the vehicles, different types of vehicles for their operations in the Mumbai city to reduce the cost of delivery of the parcels and small items. So because of that also you can see considerable improvement. So idea is this market momentum behind the AI is a very interesting area where a lot of investments are going to come up. And they are, you can say, expected things that with agentic AI itself, we are going to ensure at least 8.67 billion, logistic market additionally to be added, and project market size going to be by 16.84 billion, and 40% enterprise apps to be embedded. So these are some of the estimates suggested by some of the experts in this domain. So hoping that with the help of all these new tools, proper coordination, multimodal park, with the 4 modes of transportation in talking in same mode, and then government's own effort of bringing the ULIP and road transport, like say they have different software, you can see Vahan, Sarthi, FASTag, e-way bill, and freight operation information systems, port community systems, air cargo community systems, cargo management system. They are all softwares used by each one differently. So now point is that they all need to be linked with the, or to be added with the APIs into the ULEAP, and they have a proper connection with that. So keeping that in mind, hopefully that we will be able to bring down the logistic cost considerably by having many multimodal parks. With this note, now I think I stop here and request my next panelist, Professor Devjit Rai, to take care from here and then discuss that how the next portion of this, like warehouses and its impact, automation in the warehouses, how they can reduce the cost of logistics by this process. Thank you very much for patiently listening to me.
All right, thank you everyone. Thank you all the INAE members, and thank you Professor Tiwari for inviting me to this wonderful panel discussion. Excited to be for the first INAE conclave. It is pretty much the first time. So I learned a lot about the INAE organization this morning as well, and was very, very impressed with the kind of system that you have created to promote technology kind of dispersion here. So I'm Devjit Roy. I'm a faculty in the Operations Decision Sciences. We also founded the Center for Transportation Logistics. And particularly the topic that was given to me for this afternoon was warehouse automation, and specifically its kind of relationship with multimodal logistics. And the two key words that was mostly talked about is risk and resilience. So I will start off by, I think Professor Tiwari already set the stage very well for me. In fact, if we talk about, I want to start off by talking a little bit about MMLPs, what is the multimodal logistic parks all about, what are the customer needs today, and that is very important because we are setting these multimodal logistic parks for the future and for 10 years, 20 years down the line. And once we set it up, how do we really use them? The next is the type of hub automation that will be really helpful in terms of managing the risk and resilience. And how do you manage disruptions? And I will try to have some concluding remarks with that. So in general, as also Professor Tiwari mentioned this, in India specifically, if you look at all the modal transport and the segments, the road is really a huge one. But we also know that the cost of the road transport is pretty high, and we have to really focus on how do you cut down the cost. And towards that, the government has put a lot of effort putting down the plan for the MMLPs. In fact, we recently worked with the NICDC looking at all the e-way bill data for the last couple of years, and we also validated which of them are really good locations, which are not so good locations. But what we found is that, as again mentioned, the logistic cost is super high. If we talk about the components of logistics cost, transport is only a part of it, right? A significant component is actually the storage piece of it. So storage is important because storage is connected with the inventory holding cost. So we have to also think about how do you reduce the inventory holding cost. And if you ask, traditional knowledge tells that if you can have a faster turnaround of the products, the inventory cost will definitely be able to come down. So today's topic, I'm going to focus a lot more on the storage piece of it and not the transport piece of it. So I think this is also kind of addressed earlier, which is all about the need for the MMLPs, which goes back with fragmented logistics, looking at our freight transportation involve multiple modes, but they're very poorly integrated. And today morning, we were having a conversation that where Professor Tiwari was saying at some points you have a hub and then the railway station is like 12 kilometers away. That really tells us how poorly these modes are connected. So we really need to have good integration among all of them. I think what is really important is figuring it out, where do you get the right kind of hubs based on either the source or the sink or transshipment hubs. So going forward, if we talk about it, these are the 35 that Professor Tiwari was talking about in terms of what are the MMLPs that are identified by the government. In fact, when we did that project as well, we found about 83 of them. And out of 83, these 35 were part of the common set. So we are assessing some of the locations as we talk today. So this was the classical, how does MMLP look like? And you will see here there are multiple components. While there is a good connectivity with the railways, good connectivity with the roadways, you can see also where you are having the stack blocks, where you're stocking some of the containers. But you also have a huge, what is called the hub, which is actually the warehouse, right? The warehouse in this particular case could be value addition, it could be storage, it could be a variety of different services that you offered within it. So what are the expectations from MMLP? Some of the expectations that we see going forward is that, look at from the demand side. If you talk from the demand side, this is, of course, from the other countries, but we have a very similar. If you talk about UK, US, they have the Black Fridays, they have the Thanksgiving, which is the peak volume. In India, we have the Diwali, Holi, all the festival seasons, even New Year, Christmas, we have a huge spike. So one of the challenges is that how do we handle the volatility of demand? And that's a huge one. The next piece is from the demand side is, if we talk about the recent survey done, and the customers were the Gen Zs and the millennials. In fact, I checked my age, I belong to neither of them. But what we found is that what are they asking for? Well, they want definitely flexibility, but what they also want is that they want speed. But the contrary is that they want flexibility, they want speed, but they don't want to pay for it, which means cost is also important for us, right? So broadly, if we talk about the key metrics, what we are looking here, customer requirements, is in terms of speed, cost, flexibility, quality, safety. If you want to kind of have an inclusive work culture where you include some of the older population as well, and you have to be responsible. But if you have to say one thing that will be not compromisable in the future, will be all about speed. So the SLA on speed will be must given forward. So we know what are the expectations from the demand side. Flexibility, the 3 Fs, fast, free, and flexibility. But now if you see from the supply side, and even supply side, when we do surveys, I think what they're getting from the views of the managers is very consistent. There's some of the recent views, they say that the current systems are too rigid to respond, right? And they say that the hidden risk of traditional automation is that 77% says at least half of the systems are too rigid. Not just that, some of the systems that are built is called build to scale or build to stall. And what they say is that more than half of the leaders say that fifth automation is not ready for change. So it clearly says that we are still working in automation, but broadly that is rigid or called fixed automation. And if you talk about risk and resilience, fixed automation is not going to make the cut, right? We have to move away from fixed to more flexible automation. So, and we know recent times there have been a lot of disruptions, and not recent times, in fact, the last 6 years, if you see, you started off with the war, which was in the Russia. Before that, you had the COVID. Then you had the Ukraine war. Then you had the Strait of Hormuz. You also had earlier the Suez Canal episode. The last 6-7 years, disruption is the usual norm, right? Which means, and the biggest one was, of course, the pandemic, the COVID, which ran for a long, long time. So clearly, all of these disruptions are affecting the hubs as well as the modes of transport. So when you talk about logistics, broadly, we're talking 2 parts, the modes and the nodes. And the nodes are the hubs in our case. The modes are the one that connects these hubs. So if you go further from here, and yeah, these are some other recent stories where you see a landslide in July disrupted one of the India's busiest freight corridors during truck hours between Mumbai and Pune. So disruptions are the norm today. So how do you really manage disruptions? So what we are studying today is that from the supply side, we need to have resilient hubs, and we also need to have alternative modes for transport. So if you talk about, we can easily model that. If you talk about optimization, we can have a nice graph network connecting all the modes, nodes, and we can talk about what happens once a hub fails, how do you think about using another hub, so we can model all the resiliency in an optimization model. Or you can think about, not just that, I can look at a mode failure. What happens instead of a nodes, one of the arcs fail, right? And do we have other kind of modes to kind of take away the load from one other mode? So we can look at both of the angle. So in some sense, if a hub fails, we need backup hubs. If a mode fails, we need alternative modes. Today's session, I'm going to talk more about the hubs, which is all about the warehouses. So I think if I go forward from here, flexible automation of hubs is the answer. We cannot go with rigid, and I showed that if you go with rigid, it is not very flexible, and as a result, we are stuck with something for 20 years, and we are not able to cope up with it. So if you talk about flexible automation and go forward from here, if you talk about any storage hub operations, what you see is typically you have the receiving from where you store the pallets. From the pallets are replenishing your order picking area, which is the case picking or the broken case picking, or in terms of from there it goes to accumulation sortation, or it goes to from there to the shipping, right? So broadly, a hub can be divided into 3 components. It could be a highway storage, it could be an order picking, it could be a sortation. In fact, automation is picking up in all the 3 areas, whether it is high bay, whether it is say order picking, or it is sortation. In the next few slides, I'll tell about how is the transition happening from fixed to flexible in all of these areas. The first one is all about high bay storage. If you talk about high bay storage, I'm sure you're familiar with the traditional fixed ASR screens, which are called automated storage and retrieval cranes. They're more like the cranes what you see in automated soda dispenser machines in the airports, right? You see, you put a coin, and the crane kind of goes, picks up your soda bottle, and brings it. That's pretty much a fixed automation, right? So this is what is called the fixed automation. But today, if you see the crane-based system, because of the fixed speed, your throughput capacity has a limit, and it is a rigid system. Very similar story, you can think about now the shuttle-based system. Today, all the cranes are being replaced by autonomous shuttles, and the shuttles can move to any location as you think. If there is a peak demand, you can introduce more shuttles. So these are quite flexible, and they can be, throughput can be increased as the demand increases. So now let's move on to the order pick. In the order pick as well, we have the traditional, what we have the fixed automation. But today what you see more and more what is coming on in order picking is something called the collaborative picking system, which I'm sure you talk about the human-robot collaborations. So what you see here in one side, you have automated systems, but you have too many robots, very expensive system. On the other side, you have this manual systems, which are cheaper, which are more flexible, but then it is not very fast. You need the best of both the worlds. So while one throughput is high, but requires too many robots, on the other side, you have low throughput, more flexibility, but then you do not have the high throughput performance. So this world is today moving towards what is called human-robot collaboration, where you can get higher flexibility and more resilience in the system. How does the system work? I'll just show you a short video to demonstrate it. Can you play it? You can see here in this particular system, you have the humans and the robots working parallel. So research questions here could be, well, how many robots do we need? Do you want the picker to lead the robot or the robot to lead the picker? How should they collaborate? What is the ratio? What is the speed? So a lot of fantastic research questions. In fact, we have one paper where we just focus on the matching policies, and the other focus, we are focusing more on how do you enhance the throughput using dynamic programs. Not just that, now let's move on from order picking to sortation. In sortation as well, what you have is very traditional, what you call is the fixed automation, which is all about conveyor belts. And if we talk about these conveyor belts, again, do you see a challenge? It's all horizontal, takes a lot of space, and more important, it is rigid, which means if your demand fluctuates, these systems will break up, right? You'll not be able to manage your fluctuations in demand. So today what you're seeing, again, the world has moved away from fixed to more flexible automation that kind of takes care of risk and the resilience that we're talking about. So you can see another example of fixed automation. This is again takes up a lot of space, and also it is very, very rigid. So today if you go to Bangalore, if you see the Flipkart's ITPL sortation center, you get an understanding of what flexibility means. And let me show you a small kind of video about that as well. What you have there is again robots which are picking up, and you have this bottom tier where they're collecting all the packages. Can you show me?
ಸರ್ ನಮಗೆ ಅಂದರೆ ಈಗ ನಾವು ಪ್ರತಿಯೊಂದು ನಾವು ಮ್ಯಾನ್ಯಲ್ ಫಸ್ಟು ಪ್ಯಾನೆಲಲ್ಲಿ ತೊಗೊಂಡು ಸ್ಕ್ಯಾನ್ ಮಾಡಬೇಕಾಗಿತ್ತು, ಸ್ಕ್ಯಾನ್ ಮಾಡಿ ನಾವು ಬಿನ್ನಿಗೆ ಸಬ್ರಿಗೇಷನ್ ಮಾಡಬೇಕಾಗಿತ್ತು. ಈಗೇನಂದರೆ ನಾವು ಬಾಟ್ಸ್ ಮೇಲೆ ಇದು ಇಟ್ಟರೆ ಸ್ಕ್ಯಾನ್ ಆಗುತ್ತೆ, ಜಿಯೋ ಒಂದು ಕೋಡಿಂದ ಸ್ಕ್ಯಾನ್ ಆಗಿ ಬಿನ್ನಿಗೆ ಹೋಗಿ ಅದು ಡಂಪ್ ಮಾಡುತ್ತೆ ಸರ್. ಡಂಪ್ ಮಾಡಿದಾಗ ನಮಗೆ ಅದು ತುಂಬ ಈಸಿ ಅನಿಸುತ್ತೆ ಸರ್. ಮತ್ತು ನಾವು ತುಂಬ ಕಲಿಯೋದು ತುಂಬ ಇದೆ ನಮಗೆ, ಇದರಿಂದ ನಮಗೆ ಕೆರಿಯರ್ ಗ್ರೋತು ತುಂಬ ಇಂಪ್ರೂವ್ ಆಗುತ್ತೆ ಸರ್.
All right, I hope you see how the flexibility can play a role, especially if you want to think about fluctuation in volume. You can introduce more robots and do more work with the same kind of warehouse. So I think all my talk was about as the requirements changed, as the customers became more conscious about fast, free flexibility, as the customers want more of resilience and risk aversion, your warehouses also moved both on the highway from manual to fixed to flexible. Your order picking went from manual to fixed to flexible. Your sortation also went from manual to fixed to flexible. And that is what we are talking about, multimodal hubs, but we need more of flexibility to really manage the resilience and the risk part of it. So all we are saying is that as customer expectations evolved, supply chain technologies have also evolved to manage those expectations. And this was kind of interesting, is that we are talking about risk minimization. Think about the COVID times. There were a lot of articles saying that if you had robots in your warehouses, robots don't catch flu. They can work 24/7. You can reduce the dependence on people. So definitely robotic systems add flexibility and also mitigate risk. That is really the need for the hour for now. I think to sum it up, all we are saying is that the need of the hour is to have dynamic and more highly adaptive hubs. That's the requirement. What we need is a dynamic warehouse, which are adaptive operations, empowered workforce, cost resiliency, and all about growth of business. To sum it up, the core ideas, long term, we need to understand the effect of disruption. We need to plan in the event of disruption. We need to design and develop flexible hubs with better modal connectivity. In a short term, we need visibility. We need to leverage real-time data. And more importantly, we need to digitize processes. Hopefully, with all of these, we will be able to act swiftly. We cannot wait for 1 year after disruption. We need to work in seconds. So what we need is that we have to move away from more of a static to more dynamic decision-making, from reactive to more proactive decision-making, and offline to more online decision-making. And that's what is the need of the hour. Thank you so much. Yeah. Thank you so much.
Thank you, Devjit. Please
thank you.
Now, Professor Geeta.
A very good afternoon to all of you. I thank INAE for inviting us and SOA for hosting us the last couple of days. I thank Professor Tiwari for having me in the panel. I've been working with him on, I'd worked with him on a report a year back, and it's great to meet him in person and interact with him. It's an honor, sir. I'll talk about safe and sustainable transportation logistics, right? And I happen to be now part of the Vadvani School of AI at IIT Madras, and so that's my association. Though originally I'm a transportation engineer, I was at the Department of Civil Engineering. I also lead the Mobility and Intelligent Transport Collaborative at IIT Madras. So a lot of what I'll share today is the work we've been doing. It's not just research, it's about translating things into practice. Work that has resulted in a startup, work that we're doing at the MINT Collaborative, bringing together industry, government, academia to achieve things. And I'll talk about some of the ideas that we are working on. So a lot of it is about experience, like Professor Manna said, it's about taking, engineering is about solving problems for the people, right? So that's essentially what I'll mainly focus on. So, of course, Pushkar will talk more about this. He's been solving this for some time. What drives last mile delivery growth? It's urbanization, right? If you look at urbanization across the world, the Western world is highly urbanized, whereas India and Asian countries are fast catching up. And over the next 2 decades, I think we'll also be in the green, just like these other countries. And that is going to mean a lot more movement of goods within the cities. The issue with last mile delivery is the cost can vary anywhere between 25 to 75% of the cost of transporting a product from the manufacturing location to the final end use location, right? So it's a lot of variability, but that's also very high because you're talking about last mile, right? So that's hardly 2-3% of the distance the product is traveling, but the costs are 10 times, 20 times higher. There is also significant time pressure. We're talking about the congestion in Bangalore, how even it takes sometimes 10-15 minutes to cover 1 kilometer. So all of these delivery people have to actually work in that kind of a time pressure, deliver on time, right? Deliver more goods. The workforce is shrinking. About anytime 25-30% of our trucks are idling because their drivers are not available, right? And there is also a lot of automation that's coming in, right? So all of these make it a significant challenge. So there are broadly, I would say, 3 important problems to solve in this last mile delivery, right? First is about location and capacity of depots. I think Devjit spoke about it more from a regional level, but at the city level as well, this is an important problem that one has to look at. Then the size of the fleet and the staff, right? These are not only determined by logistics optimization, but also field constraints, right? Several of the streets in Chennai, you cannot access even with a light commercial vehicle. I have to take a 3-wheeler or a 2-wheeler to reach them, right? So all of these also have a role to play. And of course, finally, the routing and scheduling, right? So these are broadly 3 areas. So a lot of work that we've done over the last 15 years in my research group has focused on sustainable city logistics. We've looked at vehicle-related strategies, infrastructure strategies, logistics strategies, right? We have a lot of work on vehicle routing, right? Of course, Devjit is aware, one of my students did work on this. He was one of the reviewers. Prasad Tiwari has mentioned some of this work. But we've also done work on the comparing the life cycle analysis of different modes of transportation, right? There's always been a debate about should we go electric? Is electric really better than conventional fuel vehicles? And that's something that we've done, and we have shown unequivocally that electric vehicles in terms of life cycle analysis are definitely better compared to conventional fuel vehicles. I also happen to found a startup called Good Move. I'll briefly talk about that as well, right? So when we talk about electric vehicles, they have their own constraints, they have their own characteristics that need to be accounted for when we talk about routing those vehicles. So that's something that we have studied quite extensively. I'm happy to share more details of this if any of you are interested. But it makes the problem more complex, right? And therefore you need more compute, you need better heuristics to be able to solve these kind of problems. So that's something that we've done. This is the other work that I mentioned about life cycle analysis. And in general, we found that battery electric vehicles have 50% lesser greenhouse gas emissions over their life cycle compared to conventional fuel vehicles, right? So I think this part of the puzzle is settled. The other part is, of course, financing. I think that's where still a lot more work needs to be done to get electric vehicles to become mainstream. Already 3-wheeler vehicles, we find that electric 3-wheelers, goods vehicles are, more of them are getting registered than conventional fuel. I think it's just a matter of time. In a few years, we'll find the same with light commercial and heavy vehicles as well, right? So that's something that we've done. So this is my startup on city logistics. So we have 2 verticals here. One is what we refer to as on-demand, and other is basically the AIC-SOA for direct-to-consumer kind of deliveries. So this is similar to like Uber, but then more like a Uber share, right? We look at optimizing by consolidating deliveries in a single truck, right? And because we have our own proprietary algorithms for optimizing this in real time, we are able to achieve this with a fairly high degree of accuracy and efficiency. Yeah, so this is broadly how this thing works. We have our core AI engines, which look at various aspects of city logistics. For example, I need to kind of predict where my next demand is going to come from, so that I can place my trucks in the appropriate location so that I can go pick it up at the right time without having to spend a lot of travel distance empty, right? So empty miles we have to reduce. Which truck is allocated for which pickup, and then which are the goods that we can consolidate. All of these are decisions as well that need to be made in real time. And if you're using electric vehicle, you have to constantly monitor the charge levels. You have to route those trucks accordingly. And with AI, there is a lot of advancements that happens with having AI agents do a lot of the work that the delivery person is right now doing, right? The attrition rate in delivery services as high as 70%, right? So if you want that to be reduced, you need to take away some of the pressure from the delivery agent, right? For example, the delivery agent making calls, finding out, are you at home? Can I come and deliver? I am at this location. I see this building. Where is your house, right? All of these are unnecessary inefficiencies are there in the system, right? So how can we minimize some of those, right? That's something that we are looking at. So this is just some news article that came up based on our startup. Good to have some coverage on that. So we've also been doing AI SaaS work within our startup, right? Where we look at optimizing the entire network, right? So this is some work we did for a semicon company, and they opened a new hub in Malaysia. And how do we optimize the truck movements into the hub and also optimize the stacking within the hub, right? So that's something that we did. We built a simulation optimization model through which they're able to do what-if analysis and figure out what is the kind of resources that they need to deploy, right? So this is a first step towards building much larger digital twins of the entire transport warehouse ecosystem, right? So that's something that we've done as well. So I'll quickly change to what we do at MINT, the Mobility and Intelligent Transport Collaborative. So this, of course, takes mobility from a larger perspective, not just logistics. We look at passenger and logistics. And the case we make is for CASE. It broadly stands for Connected Autonomous Shared Electric Mobility, right? This is going to be the future, right? We all know what these mean. Of course, we are at different stages of development across all of these, but eventually this is what will be the future of mobility. And in MINT, we say we need to create the digital public infrastructure for this mobility ecosystem. And this is something that cannot be developed in silos, right? We can't have industry develop its own systems, government coming up with its own policies, academia doing its own research. We need to have all of them come together to work together, right? So that's what MINT enables, right? So we are more an enabler for doing this. And the main focus of MINT is to build what we are referring to as the Bharat multimodal mobility stack. Professor Tiwari was mentioning about how there are different software systems, right, which are not talking to each other. So we need to have standards, right, which all of these systems can follow, right, so that we can have interoperability. So what you see at the middle there, the mobility protocol is a set of standards that we are defining so that people can adopt those standards and they can start communicating with each other, right? So you'll have data repositories, you'll have rules, AI agents that look at the data, make it usable. Then you'll have models, right, which can actually use this data, come up with some meaningful insights, subsequently have measurable impacts, right? And you have to do this in such a way, everybody derives value, right? Otherwise they're not going to contribute, they're not going to be part of it, right? So that's what we're building broadly. Those models could then eventually develop into what we refer as mobility digital twins. So right now we're developing the initial digital twins for the city of Thoothukudi, which is a port city in Tamil Nadu. We're also just entered into a MOU with Chennai Unified Metropolitan Transport Authority, which is the overarching transport body in Chennai, to develop the digital twin for Chennai city, the mobility digital twin, right? So it's a very, very complex problem. There is, of course, a lot of work that has happened through the smart cities. Devjit and I were discussing about it, but there are still a lot of gaps that are there, right? And one of the primary gaps is people come up with their own proprietary systems, they install it, and after 3 to 4 years, the project is over. You have all of these legacy systems lying around, nobody knows how to use it, how to take it forward, right? So we need to have standards that all of them can follow, which is essentially what we are trying to do with our work on this mobility digital twin. The other aspect, I've talked a lot about sustainability, the other aspect is safety. As a country, we perform very, very poorly when it comes to safety, road safety, right? We have about 1.7 lakh people dying on our roads every single year, right? I mean, in about 5 years, you're talking about a tier 2 city completely disappearing from India, right? That's the number of deaths which are there. And majority of the victims are typically young people who have their entire life ahead of them, right? They are the ones who are casualties in this. And they are also vulnerable road users. Many times they are not at fault at all. They're just walking by the side of the road and then a truck comes and hits them, right? So we need to address, this aspect quite a bit, right? A lot of work to be done here. So again, a lot of research publications have been happening in this country for last 20 years, but we don't have enough solutions to actually translate it to some impact on the field. So work we've been doing using AI cameras in Bangalore is to actually implement enforcement of rules, enforcement of certain policies on a couple of major corridors. You may be familiar with the OMR, right, and the airport road, two of the deadliest corridors in Bangalore, right, high speed. So we did a lot of study with data, identified what are the vulnerable locations, then came up with technologies, right, mainly edge AI based surveillance cameras, something that we have developed and implemented. There's another startup that's come out of that work as well at IIT Madras, right, and then several infrastructure interventions. But for the first time, these interventions we are collecting before after data, right? It's not just about having the intervention. We are able to quantify what is the benefit of each intervention, right? So this is something that's completely lacking, right? Consultants are just giving recommendations without quantifying what will be the benefit, but this is something that we will get as a result of the study, right? So this is one particular example in Bangalore, just after the airport, a place called Kandamangalapalya. So basically you can see a level crossing there. Vehicles come from there. Whenever the gate is lifted, they just come straight, and there is this slope on which the flyover on which vehicles are coming. That particular point, there's a lot of conflict, right? So we are actually setting up a vehicle actuated signal there, so that if there is conflict, we make it red, so that we prevent accidents, right? And then allow vehicles to pass smoothly, right? So this is something that we've implemented, and we already have seen significant improvements in terms of metrics, surrogate safety measures. We have already measured, and we are reporting improvements from this, right? So of course, accidents are probabilistic events. We need to reduce the probability of an accident occurring. That's how we can reduce accidents overall. And in the last decade, we have not reduced accidents at all, right? It's only been increasing. And that is some work as well that we've been doing, which is extremely important. And I'll end there, and if there are questions later, I'll be happy to take more questions. Thank you.
So, thank you very much for inviting me to this great event. I'm probably the only non-engineer who is here and non-professor. So I am a chartered accountant, but having worked in various industries can share my experience. So what I would like to talk about is more at a macro level in the ports and logistics field, which covers all the various interconnectivity of transportation. But I will, first talk about what is the big thing about logistics. Many years back, I think no one was talking about logistics. It was, ठीक है ये सब ट्रक में भरो और भेज दो or something, put on the train. So it wasn't considered to be that important. But over the years, as businesses have become complex, as scale has become large, it has become very, very important, as we saw in some of the presentations, how minutely people are planning their logistics piece. From an India point of view, if you look at, I would talk about, at a international level, because when we talk about ports, we are talking about foreign trade. 90% of the foreign trade takes place through marine route. And you will be surprised to know that Indian Ocean accounts for 80% of the world trade. So what we are talking about is that we have a very big strategic importance in our country, that we have our presence in the Indian Ocean, and through which 80% of the world trade passes, which is not just because of us, but because of China, but we control many of the strategic locations. And if you look at the geopolitical situations or the pandemic or other things that have happened in the last 5-6 years, and the frequency of these events, or even the Houthi disturbances, etc. So we find that it is important that for a country of our size, 150 million, 140 crore people, it is very important that we treat this thing very, very seriously, because it determines the very existence of our country. If we are able to import and export our goods, critical requirements like energy, etc. And also today, from a defense point of view, it is no longer that you can be a country of peace. Peace can only be there if you are strong. So for a country of our size and number of people, it is very, very important that we, from a defense point of view, are fully taken care of. So when we're talking about ports, we are not just talking about business, but also talking about defense. If you look at some of the events in the recent past, in the last few weeks, our Prime Minister has traveled to Indonesia, he's traveled to Seychelles, he's traveled to, Japan has come here, and we've been talking to Myanmar and, Mauritius. These are all, and, the biggest controversy which is today is the Andaman port, which we are developing, which is basically going to control the Malacca Strait. Like you've heard about the Hormuz Strait, but you may not have heard about our own strait, which is the Malacca Strait, through which most of the cargo passes. And basically Vietnam, Philippines, Indonesia, then, our own Andaman, then Lakshadweep, then Seychelles, Mauritius, Maldives. These are vantage positions which are not only critical from the point of view of trade and commerce, but also from the point of view of defense. No one will talk about it, but these are all multi-purpose ports which India today controls. And never to forget Iran, which is the Chabahar port, or the Haifa port in Israel, or ports in Greece, and in so many other locations. Oman, of course, you cannot forget. So these are all, today an effort which is of a very proactive government, which is trying to safeguard the interest of India by creating not only safer routes for for goods and services to pass, but also to create relationships, to create bases, etc. Today, normally what happens, like, you saw in the earlier presentations, that very fixed systems are designed to cater to requirements of, logistics. Same happens when we are talking about, say, import of LNG or LPG or crude oil, etc. There are trade routes which are predetermined, sources are predetermined, where your things will come and which port it will land, how it will happen. But suddenly there is a war and Qatar, which supplies all the gas to you, gets bombed. What do? Suddenly you have to see that, there is, hue and cry in the country, and a lot of hangama. And what do? Then you go and import from other sources, which is all of a sudden, and who gives it to you? 50% of the LNG and LPG which has come to India in the last few months is from America, US. We are importing Russian oil, we are increase the import from West Africa, from America, etc. So basically, you have to make different new arrangements, and that's not easy because you cannot create a new port which will export the material to you. So these have to be something where it has to be an alternate arrangements which are already being planned, that in case of a problem we will handle it. Storage, you talk to some of the exporters of oil and create a large storage, or talk about creating a large storage in India, because it is in their interest, it is in our interest. So see that we have storage for at least 6 months. It's not easy to create storage of 6 months of oil, because it will cost you something like $50-60 billion. Plus, who will take the fluctuations? Who will take the currency risk, etc. Of course, all these can be hedged, but it is at a cost. And who is going to take the inventory cost? So all these are expensive things which earlier we could never think of. We have created some of these storages, we have created some of these things, but they are not enough. So somehow we are managing, because I have worked in refineries, we have worked in steel plants. We keep minimal inventory. 15-day inventory is what we keep. So when we talk about 3 months, storage of oil, crude oil, I don't know, because we don't have that kind of storage, but maybe it is there. 3 months may be possible, but not 6 months definitely. So these are the questions that we have, and that makes, and then the cost of logistics has to be such that it makes the country competitive. So what are the reasons why we talk about logistics cost? Because that's how manufacturing can happen in this country. There was no export of crude oil, oil products which are happening till the Reliance and SR refineries came by. Because all other refineries, most of them except a few, were actually in hinterland. They were not even at the port. And they were importing in small parcels. Then came SR and Reliance, and they started importing in 330,000 tons VLCCs, which reduced the cost of import, and started exporting in Aframax-sized ships. So all this has to be planned, has to be seen that, how do we create competitiveness? How do we create the logistics and the supply chain, which is robust? Because the biggest issue today in the world is about supply chain. Disruption of supply chain is what the nations are trying to disrupt, even in peace, for strategic advantages. China would try to disrupt this thing without having a war, or someone else will try to do something to disrupt your supply somewhere. So these are things that we have to be cognizant of, we have to be taking care of. So that is where the planning of logistics comes, and that is where, where the nation is moving today, with all kind of risks. Or even for defense, for example, if you have to have preparedness in remote areas of the country, you have to create logistics, you have to see that you can move fast. So we're talking about, fast movement from one place to the other. Maybe somewhere you land by plane, but then from there you have to have road transportation, etc., and etc. So this is one part. The other is that, if you look at, in my thing, I realize that sometimes when we are working in India, we don't understand fully what is good in our country. We make a lot of jokes about us and we laugh at us that this happens or that doesn't happen in India. But when you travel to certain countries which are not that fortunate, and when you go to, say, Africa, and you see that a country which is full of gas and full of minerals, coal, etc., but can't do anything because they don't have transportation. From the mine to the sea, it is 1,000 kilometers, and they don't have any rail or road, and they don't have even from the pit head to move the coal from there to the nearest rail head. So these are things which you have to plan. So India has done wonderfully well by seeing that, wherever we have coal, we have power plants on the pit head. We, of course, have the advantage of consumption. So they don't have the advantage of consumption also. Even if they put up a power plant, first of all, they don't have money, and even if they put up, they do not have the means of transporting it by having the distribution system or the network. So these are things which are very, very important. So we say that a mine or a resource is no good. It is worth, like mitti ki tarah hai wo. Unless you have the transportation, unless you have the logistics to exploit and take it to the markets. So from Africa, if it cannot travel to the markets, which is India and China, it is of no value because in their country they cannot use it. So it is very important to pay attention to the logistics, to see that you are competitive, you are least cost, because it's a global world. Now you cannot say that I will have a pricing which is going to be different from something which is there in the world, because people can import it. So every commodity is today dollar denominated, every commodity is internationally priced. So whether it is oil or it is coal or it is steel or it is anything, everything, or even small commodities, they're all at international prices. So you have to, maybe you can at best take the advantage of having some duty which the country is putting, that you can add and then compete within that. But otherwise you have to be competitive. So cost of logistics is very, very important. Now what is the government doing? Government has stated, and we all know, we have talked about Atmanirbhar Bharat. So basically what that means is that more and more we will go for manufacturing. Now in so many years manufacturing was there, but it wasn't taken very seriously. Now especially some high-tech areas like semiconductors, etc., we are taking it seriously. We have started making a lot of electronic products, and we are going to backward integrate it with semiconductors, etc. So in maybe next 5 to 10 years, we will really be able to, from a component level, create this. But that all needs supply chain. So one is that we have to be Atmanirbhar. So based on that, we have planned, and the Ministry of Transportation, Ports and Shipping has made a plan which is part of the overall plan of the country of Viksit Bharat, which is Viksit Bharat 2047. And it talks about, first is augmentation of the port capacity. Today, India's port capacity is about 2,500 tons, million metric tons. If you compare it with China, it is about 20,000 million metric tons. So we have taken a plan to take it to 10,000 million metric tons by 2047. I think this target something which we can achieve much earlier, because the plan, the port capacity can be increased very easily if you increase the draft. So say from an average size of ship which comes to our port being 25 to 40,000 tons to 200,000 tons or 300,000 tons, your port capacity can really go up if you dredge it well, if you have the requisite evacuation methodology of having mechanization, having storage, having conveyor belts, etc. So that is what is being planned, where these ports that we have are getting modernized, and we expect that the port capacity will go up to 10,000 million metric tons. The second is that ships. Now, when a disruption takes place, we have seen in the case of Russia, no one was allowing them, giving them ships. They were not even able to get insurance. There was a time when they used to say that in 5 voyages, I will give you a deal that in 5 voyages your ship will be free. They were so desperate. So India has decided that they will increase their tonnage from about 13 million DWT to about 100 million DWT. So that is another plan. The third plan is, of course, that we want to increase our capacity for shipbuilding. Over the years, we have neglected shipbuilding. Shipbuilding is not something which we cannot do because it is largely, a lot of, it's not so high-tech that we cannot do it, in fact. Nowadays, at least for naval crafts, etc., we have started doing, but for commercial ships, still, we haven't really done it. But there are some shipyards which are now coming up, and we expect that we will increase, we will have at least 5-6 large shipyards or maybe more, and by 2047 we will be among the 4-5 top shipbuilding nations. The top B today is China, and then Korea, and rest of them, Japan, etc. They price themselves out because they are not cost effective. I feel that India can do very well because our manpower is reasonably priced, and we have all the basic resources. And I have seen that we kind of treat ourselves a little harshly because every time we have set up a project abroad, we find that the cost of setting up a project is 4 to 5 times. The services are also very expensive. So that way I would say that if we want to do something, India can definitely achieve it. Next goal is, of course, to decarbonize and to create ports as hubs for green energy. So we are talking about green hydrogen. We're talking about seeing that the port, all the power that gets used at the ports is all green power. So ports are setting up solar and wind energy, and they are buying maybe, and plus, of course, railway has electrified fully. So that connectivity of railway, that is also is green if the railway is running on green energy. So that is one of the things where we are moving towards using the ports for generating green hydrogen and ammonia and storing and transporting from there and exporting green ammonia. So that is another thing. Apart from that, of course, we're talking about digitization. We're talking about creating, a multimodal transportation system, because at the end of the day, it's the last mile which is most important. You can bring the ship and you can reduce the cost, but at the end of the day, the last mile is extremely important, which my predecessors have all talked about it, so we understand. So basically, it is like saying that you reach an airport and then you don't have road or you don't have rail connectivity and you have to go somewhere. So in Western countries, you'll find that there'll be a metro station which will be right there. There'll be good bus services and everything which will be there. So you can take, apart from the taxi, which is always there, you can take other modes of transportation. So it's an interconnectivity of transportation which is required, which unfortunately in India we have not developed. So which I think in times to come, we are moving towards it. So that is very, very important. So these are some of the important points which I would like to highlight. In the interest of time, I would end here and we'll take questions.
Thank you, sir.
Hello everyone, respected sirs, thank you so much for having me over. I'm a Kharagpur graduate from 2013. Professor Acharya was the first director when I entered the college, and Professor Tiwari is my guide and mentor, and now today more than everything today. Thank you so much for having me over. Quick introduction. As mentioned, I'm a mechanical engineer from IIT Kharagpur, graduated in 2013, went on to work for ITC Limited, which is one of our FMCG majors in India. What started out as a management trainee project for ITC culminated into the company that I run today called Let's Transport. So it's been 10 years that we've been working in this industry. These are some of my findings that I've worked over the last few years that I'm trying to crystallize and communicate to all of you. Yes. We work in the last mile and middle mile transportation. Most of my esteemed guests have already spoken about it. It's a business which is 10-year-old today. It's a smartphone application which connects medium to large size enterprises. Think of them as all the way from an Amazon, goes down all the way to a medium sized enterprise in India. We work with form factors of truck carrying payload of 500 kgs all the way up to 20 tons in size. That fungibility of form factor allows us to deliver a better cost per kilometer at the back. Today we have about 2.5 lakh trucks which transact with us, and yes, we cover about 50 million plus kilometers every year. We are a business of 900 people. We would have done 7 million trips till date. We capture about 5 million data points every month. We work with 2% of India's trucking supply today, and there are 1,000 physical touch points that we intersect every day as we speak. Right. Now, the management trainee project, while a lot of us have spoken about the theory behind it, I would like to walk you through what was my experience while at ITC. A lot of time, the reason why logistics becomes exciting to discuss is the problem statement that was given to me was we would often lose out on sales because our stocks would not reach on time. So the demand curve which Professor Devjit spoke about, you walk into a retailer outlet, ask for a bag of Ashirvad atta. The retailer says, sir, Ashirvad aaya nahi, can you buy Pillsbury instead? That phenomena happens 25% of times in India, which technically means every company which posted $10 billion of revenue could have done $12.5 billion of revenue. Now, a more interesting concept is most companies in India believe that they have invested in inventory, they have invested in branding, marketing. So any incremental sales throughput would have resulted in a PAT movement for them. And that's the sensitivity to the topic that we are discussing. This was the problem statement at ITC. I analyzed balance sheets of top 10 companies of India. I realized we put together do about $46 billion in sales. 10% sales increase would lead to a 25% enhancement of PAT for most companies in India. Now, with that sensitivity, I started diving deep into the problem. Most balance sheet in India would talk about an inventory days of north of 90 days. So when you open up a balance sheet of Pidilite, Daburs of the world, you would realize a lot of inventory has already been produced. So clearly production was not a challenge. You then move to distribution. In distribution, you realize, given that so much of inventory has been manufactured, most factories do not carry that space to occupy that kind of inventory. So it would have moved to regional warehouses. For instance, a lot of products would be stored in Bhiwandi, but wouldn't have gone to Bombay, wouldn't have gone to Nashik, Shirdi, so on and so forth. And that's essentially the problem statement that I've started solving for. Most of your long distance trucking in India happens with large leading companies such as TCI and likes of them. But last mile and middle mile, the act of delivering a product from Bhiwandi to a retail outlet, to a retailer or to a metro cash and carry still happens through an individual truck owner in India. And because it's fragmented, that's also a reason why it's not reliable and it's expensive in India to do it. So my first port of call was to actually nudge a TCI. Would they be willing to solve this problem for me at ITC? Most of them denied doing this for us. I'll spend a minute as to why it is important. I'm skipping a few slides just to ensure benefits of time. But yes, now a lot of us spoke about ports, ships, so on and so forth. The value that we are trying to create is, if I just go back a slide, That's how supply chain works in India. So you manufacture products in an SEZ or a different parts of your country where you have tax benefits, raw material proximity, so on and so forth. And then you send a large truck between cities in India. That's the area where most companies play with. Think TCI, think VRL, so on and so forth. But as soon as you enter a city like Mumbai or Maharashtra, from there on, you use smaller trucks, which are a form factor of 2 tons to 5 tons to distribute products inside. Now, the reason why traditional companies are excited between the first leg of the movement is every transaction gives you a revenue of ₹1 lakh. And for every lakh of rupee, you would generate profits of 15,000 rupees. In the latter part, your form factor is now reduced from a 20 or a 25 ton truck to a 2 ton truck. And instead of traveling 2,000 kilometers, you're now just moving 500 or 400 or 300 kilometers. So every trip, you're just getting 10,000 rupees of revenue and subsequently probably 1,500 rupees of profit. The most difficult aspect of managing a transportation business in India is managing a truck driver. And hence, historically, most businesses in India think it's easier to manage one driver, get 15,000 rupees of gross profit versus managing 10 drivers to get the same amount of money in. Which is why historically the latter has been fragmented in India. Now, the way you solve any industry of this nature is by bringing technology in. For donkey odd years, the oldest industry to get organized was shipping industry. That is because every container that you send gives you $100,000 of profit. And you can hire a graduate from IIT Kharagpur, make him an operations manager, and still that business will be profitable to you. When you go below from a $100,000 price point to a $1,000 price point, you no longer can attract talent from an IIT Kharagpur, but you would then go to different, probably 10th graduate, 12th graduates, and operate that business. The challenge is, when you go to a price point of a $10 rupee a day, even labor in India is more expensive beyond that. Which is where you need technology to build a business which can run 1 million transactions a day. Which is why over the last 5-10 years, you would see fintech companies coming up. You would see food delivery companies coming up, and subsequently you would see smaller companies using technology to play in an industry which has a very low average revenue per trip or a revenue per transaction business. It's extremely easy for a Citibank to give a $100 million loan to a Reliance. But if you ask a Citibank to give a $5,000 loan, वो बोलेगा sir HDFC Bank के पास चले जाओ. Because the cost structures are very different for both transactions. The challenge is when you go to an HDFC Bank and ask for a 500 rupee or a 1,000 rupee loan, वो बोलेगा sir document लाने जाने में 5 रुपए लगते हैं मेरे. Which is what opens up for digital disruption. तो अब क्या हो गया? You download a smartphone application, submit an application, and 1,000 rupees comes to your account. That is essentially the tenet at which we operate today. Now, again, I'll just skip slides. Logistics, we have spoken multiple times. While we grow 12 to 15%, the more exciting aspect being on the ground is the rate at which we are organizing our logistics is more exciting. So today, when I speak to a CEO of Amazon or CEO of, let's say, Coke in India, the first ask by them is, Pushkar, मैं logistics तो करता ही हूँ, but I do it with 1,000 vendors at the back. Can you come in and consolidate it for me? Now that CAGR is 36% in India. So today we have more demand than what we can fulfill, largely because companies are moving towards more organized partners in India. And that's true for every sector in logistics and outside of logistics, by the way. People have spoken about this, but that's the snapshot of logistics. And that's our field of play, which is essentially into trucking, intracity and middle mile. India spends a little over $80 billion every year to do that part of our end. Now, why we are more relevant as time moves forward. In the year 2000, none of us expected a delivery to happen in 5-10 days, right? Which meant a very different hub and spoke nature existed in India today. Come 2010, that delivery expectation went down from 10 days to probably 3-4 days. Now it's 10 minutes, which means you're reorganizing every aspect of your hub, spokes, so on and so forth, which is why it is more important to have digital freight in India rather than doing it the traditional way. An example which resonates with me the most, India Post has been in India for very long. You did not need a delivery or a new age logistics company to move e-commerce parcels in India. Now, when you peel the onion, you realize, and the first image that comes to your mind of an India Post is a postman जो एक साइकिल चला रहा है और अपने झोले में envelope deliver करता है. They have the best reach in India. The only difference is e-commerce demands you to deliver a 5 kg packet instead of an envelope. The moment you change that part of that equation, jhola is no longer relevant, cycle is no longer relevant, and subsequently your dark stores are no longer relevant. So the only change that a customer expected was moving from an envelope to a 5 kg parcel. Just because of that change, you had an entire supply chain to be reorganized. India Post even today reaches every pin code, but they can't serve an e-commerce company because of this reason. So as and when you change form factors and expected timelines or transit times in the minds of a consumer, you're looking at reorganizing the supply chain at the back. Companies today have to sell through general trade distributors, which was prevalent 20 years back, modern trade, e-commerce, 3PL, and now quick commerce, right? It is tough for them to manage all of this today. That's where we come in. This is a chart which professors have shown you before, but it is a demand curve of a real FMCG company. What's happening is the local maximas are your weekend sales push, and your global maximas are actually quarter end or a festival sales push. Now, most supply chains find it difficult to optimize this, which is where an aggregator comes in. So, for a consumer goods, Saturday and Sunday is when they require more trucks because it's a push-based sales. Aap jate ho, you buy a biscuit out. But for an Amazon, you buy on a Sunday and your deliveries are done on a Monday and Tuesday. And hence, when you merge these charts, you get some efficiencies from the truck which is running at the back. And hence, that's the value that we offer to our clients. I'll just quickly run through. Some of our clients would experience 10x demand variation. These are real charts. We deliver a 99.5% reliability. You would be surprised today, the ask use cases that clients demand from us is, a DMart would say, you know what, Pushkar, can you help me build a Zepto? Or can you help me build a Blinkit? And that's what we do for them. They have better customer experience and they have more fungible form factors of trucks. Truckers, why would a trucker come and work with us? In India, everyone realizes there is a warehouse of, let's say, a DMart. But in order to get business from a DMart, you need to do a song and dance of procurement managers, finance managers, sales managers, so on and so forth. And truck owners in India are illiterate. Wo banda finds it difficult to spend 5 or 10 days of his entire month sitting in offices, dancing around all the song and dance which an enterprise would want. So the pitch is very simple. You download an application. We would digitize the entire process. And we would democratize all of that enterprise demand to an illiterate person who is a truck driver in India today. An interesting fact, why are we called Let's Transport? Most businesses or truck owners in India, in their phone books, would have different numbers stored as ABC Transport, Priya Transport, SV Transport, so on and so forth. And that's why we are called Let's Transport. What we have learned over the last 10 years is, when you book a cab, you're just actually asking him to come from a point A and take me to point B. In logistics, as they've rightly mentioned, you're asking a person to come at a point A, do certain tasks, pick up, unload, delivery, challan, so on and so forth, and then deliver it. In order to standardize experience, you digitize the entire workflow, and that's exactly what we've been doing for the last 10 years. So imagine building a product company for people who do not understand English, who are probably seeing a smartphone for the first time in their life instead of a Nokia 1100. So this is some of the USPs that we have delivered over time. I'll just quickly go through, skipping up a few. Yeah. We have built a fairly sophisticated technology stacks. It starts off a client. We understand a bunch of their data sets. We're the first to know whether a client is performing sales बढ़ रही है, sales घट रही है. We have a lot of truck data. कब truck का documents expire हो रहा है, truck कितने kilometers चल चुकी है, so on and so forth. And obviously, any kind of government data sets, we integrate APIs with them. These are some of our screenshots of our technology that we've created. But an interesting thing that I would like to take you through just for the benefit of time. Today we track about 18 lakh trucks on a daily basis, which means we understand on a lane level which fleet owner is performing which. what percentile does he sit on particular lanes that he operates, how can he be more efficient. We have cluster level analysis of what's happening in a particular node in India. We can also recommend truck owners, should he take a truck from Bangalore to Ahmedabad or wait for 2 days because return trips are not available. And we actually have densities around what's the waiting time on different parts of India today right now. So all of this is done through obviously AI agents. You have a bunch of agents sitting up, looking at data, looking at making various calls, as I rightly said, ki sir delivery kahan karni hai, so on and so forth. Most of it happens through technology, and it results in very actionable data sets at the back. Yeah, so this is what our business is. Simple. The more bookings that we do, we get more interest from truckers on our platform, delivers more value to our clients. In the process, what we also do is we cross-sell different services to them, such as truck insurances, fuel, so on and so forth, allowing them to lower their cost of operations for us. That's in a nutshell what we've done so far. I'll take a pause here, and sir, I think, thank you so much for your time. It was lovely coming over, sir.
So thank you, Bhuskar. So just for brevity of time, I just want to put 1 or 2 questions from the audience. Otherwise, I have 1 questions each to the panelists. Anyone from the Acharya Sahab, any question? Okay. So just I go one by one. So Geeta ji, you tell me, digital twin that you are talking, how it is going to reduce the logistic cost of the country actually?
So I think if you look at data, perhaps one of the most data-rich countries is India. We don't even realize this, right? Every GST transaction, fast-track transaction, e-way bill transaction, right? The quality, needs improvement, but in terms of the sheer quantity of data, what we generate is incomparable. I mean, for example, even in the US, they don't allow such minute tracking of shipments, right? So with all of this data, we can, within a very short period of time, I'm talking about few weeks, set up digital twins for freight movement in the country, right? And once we have clarity about what is happening, like, he showed the truck radar, right? So we have the pulse on where movements are, where demand is, where there are gaps. It's demand supply matching. Right, so that can happen very quickly. Right now, that information is sitting in silos. Government ministries are not sharing data with each other, right? Forget them sharing with others outside. But if we can start, sharing this data, I think within few months we'll start seeing results in terms of reducing costs.
So thank you, Geeta-ji, and Devjit. One small question to you, that you are always talking robotics applications and automation in the warehouses. At present, I think if you see traditional warehouse, more than 50 to 60 people are working. So if you bring all the robots, the number will go down. Where these people will go, and how are you thinking that human-centric robotics will be much more better for Indian warehouses than purely automated warehouses? What is your take on that?
My take is that I think going forward we'll see more and more human plus robots. It will be not only just robots. And the idea is that it'll address multiple problems, particularly in terms of ergonomics, in terms of throughput, in terms of flexibility, but also in terms of reducing the cost. In fact, many of our work we actually show when does a pure manual works and when does the robot plus manual be better off than completely manual operation. So this will be primarily cost driven, but also other factors that we talk about, speed, flexibility, resilience, disruptions, all of that will come in picture.
Very good. So, Bhuskar.
Yes, sir.
So in addition to streamlining all the truck owners and linking them with your platform,
yes, sir.
How do you think that this can also be linked with the other transportation link, how the rail, road, and
absolutely, sir.
Someone can link with the railway to get the item and then send it to the different locations. Can there be similar kind of platform to link the rail, road, and other modes?
Absolutely, sir. So we work with clients to actually build solutions for that. One thing which we often find difficult to bridge is cost of transferring materials between the modes. So what happens is, let's say if a truck comes in, you have to unload, load it again back to a train or a port or where. In India, that cost is something which eats up the efficiency away. And what we're trying to now do is look at different multimodal parks where we can set up our facilities to solve for these problems. But I have been fortunate to travel to different parts of the world to see more automated warehouses. And I've seen warehouses where robots move at terminal velocity. So if you're able to build palletization, smaller concepts of standardized logistics, multimodal will definitely get a fill up in India today.
So in order to just quickly finish the things and give the kernel right platform for next speaker, Raju, only one question. Do you think India should go for manufacturing large size ship, or they should hire the ship from other country and go ahead with the business?
No, I think, see, if you look at today, China is the only source of buying ships. No, they are outpriced completely. So mainly, most of the Korean companies are manufacturing in China, whether it is Hyundai or it is Samsung or anyone. So they are manufacturing in, we used to get ships manufactured in China, which were basically with their stamp. So India has no alternative but to manufacture. Yeah. And their capacities are all fully booked.
With this, thank you, INAE, for giving us this opportunity to organize, though there is very feeble attendance, but somehow we thought to fulfill our job, because it's a Professor Acharya whose request and INAE, so we have to come and see that. But topic is very important. I think those who are here, they should see that we can save a lot, and many more social work can be taken up by the money saved through logistics to support the other government functionalities. Thank you very much to all of you, sir.
Thank you, Professor Tiwari, and our esteemed panelists for a highly engaging and insightful discussion. May we request Professor Manas Kumar Malik, Director, SOA University, to please kindly come on the stage and felicitate the esteemed moderator and esteemed panelists. Thank you, sir. Thank you. Ladies and gentlemen, as we draw towards the close of an enriching day of deliberations, we now have the privilege of listening to our pre-dinner distinguished speaker. It is a matter of great honor to welcome Professor Abhay Karandikar, Member Niti Aayog, Government of India, who is joining us virtually for this special address. May I now request Professor Abhay Karandikar to kindly deliver his distinguished address. Ladies and gentlemen, please join me in welcoming Professor Karandikar with a warm round of applause.
kindly commence your talk, sir. We'll be very happy to hear from you. Your introduction has been read out to the audience, and we are ready to go, sir, live.
Okay, so can we start?
Sir, please, sir, please. Yes, sir, please.
Yeah, good evening, everyone. Let me just share the screen. Is it like my screen is visible?
Yes, sir, we just got it briefly. Now we've got it full screen, sir.
Okay. Good evening, and first of all, let me apologize that I could not be present in person there due to some unavoidable circumstances. Otherwise, I was planning to attend. So in today's talk, I will give a glimpse of India's science and technology ecosystem. So I will, this is my brief outline of the presentation. I will just talk about the current science and technology landscapes. And in the last few years, what structural initiatives have been taken by the government, both at the institutional level and also, launching some mission mode programs in key sectors of national priorities. Now, as all of you know that in the last 10 years, there has been a significant rise in our S&T outcomes. For example, in the Global Innovation Index, India has risen from 81st rank in 2015 to 30th rank. And in terms of publications in science and engineering, and these are all indexed publication, we are now number 3 in the world, after China and US. And also in terms of PhDs and science and engineering, also, we are now number 3 in the world. There has been a significant improvement in terms of patents being filed by resident Indians also. Now, as far as our innovation ecosystem is concerned, in today's world, we are having a very vibrant innovation ecosystem, which has been driving entrepreneurships and technology leaderships. We now have close to 223,000 registered startups, and just a few years ago, that number was less than 1,000. And in that, I think it is not just the number of startups, but there are about 120 plus startups, which are unicorns. That means having a valuation of more than $1 billion US. And there are about close to 5,000 startups which are working in real, deep tech areas. And there may be about 20,000 or 30,000 startups which are in technology areas out of these 223,000 startups. Now, if you look at, some of the, critical technologies and how we have done in terms of research publications only. So this graph is not showing about the products or the technology that we have, but it is just showing the global share of the high impact publications of the last 5 years. And this is based on Australian Strategy Policy Institute August 24 reports. So China, of course, leads in 57 of the 64 critical technologies, and while US leads in rest of the 7. Actually, we rank within top 5 in 45 of the 64 critical technologies. And some of them are shown here, like for example, in biofuels, we are number 2, advanced composite materials, we are number 2, quantum cryptography, we are number 3, and so on. So that basically shows that in terms of high impact factor publication, our research labs and top academic institutions and universities are doing actually extremely well. But obviously we don't have the technologies or products in these areas. So there is clearly a gap in terms of translating this research outcomes into commercializable technologies or the products. Even more so, one more interesting outcome is that India has about 1,200 universities and institutions, and even though we are number 3 in terms of scientific publications and also in terms of number of PhDs and also in terms of our share of global share of the high impact publications, the research is concentrated only in few institutions. In fact, as per the NIRF India ranking reports, only 18 of these institutions can be classified as most productive and maybe 47 as some kind of a medium productive. So you can see here that even with a fraction of our institutions and universities performing extremely well, we are actually have reached number 3 in the world, and we therefore have a huge potential. So there is one gap area that we have a huge potential in terms of research publications, research outputs also. And another gap area is that whatever research that is happening, is not getting translated into the commercializable research technologies and products. So these are, the two gaps. Of course, one aspect of that is our gross expenditure in R&D as a percentage of GDP still remains 0.7%, although this is based on the 2020 data. And I believe the Department of Science and Technology will soon release, the latest survey that was going on for the last almost 1.5 years. And this number may improve up to sort of 0.9. I am hoping that up to 1%. But the fact remains that many of the advanced countries are still spending, 3 to 4% of the GDP. And in that, the most concerning thing is that R&D expenditure by private sector in our country is only about 35%. So even if this gross expenditure becomes 0.1 to 1%, most of the expenditure is done by the public sector R&D and by the government. The expenditure by the private sector remains sort of low, and that is, in my opinion, also one of the reasons for a weak industry academic linkages or translation of research, because we need a robust industry R&D ecosystem to collaborate with the academia and take the research and translate it into the products and technologies. So there are these are some of the challenges. Only a few Indian universities, I told about 18 of them, are classified as most productive based on publications by NIRF, dominate high quality research, and these are mostly IITs, IISc, TIFR, JNCSR, AIMS, etc. There is a limited faculty incentives for industry engagement, and one more area which I mentioned, that full-time R&D personnel per million population also remains low. So obviously there are limited researcher opportunities also. Private sector R&D spending remains limited compared to the global benchmark. Industry academia collaboration, while it has evolved in the recent years, translation of research into innovation and products has not happened, to that extent. And finally, although, we can say that we are number 3 in the world in terms of scientific publication outputs, given that we are having 1,200 academic institutions and universities and close to 1,800 scientific R&D labs like CSIR labs, DST labs, DBT labs, ICMR labs, we are still having low share of the global research publications and patents compared to our population and the talent base and the number of institutions that we have. Now, these challenges were recognized by the government, and the government has done certain structural reforms and certain sectoral initiatives. And before I talk of that, I will talk about that in order to do these institutional initiatives and structural reforms. At the government, we thought that it is important to focus on technologies which are critical towards the national goal of becoming a developed economy based on the foundations of science and technology. That is the goal of Viksit Bharat by 2047. Now, if you look at that, then I can define the challenges which are affecting our society and nations into three buckets. One is the problem of sustainability and fragility. So whether it is climate change, greenhouse gas, or reliance on fossil fuels, or geopolitical shift which will result in cyber attacks, bioweapons, etc. The second challenge, in order to achieve the goal of Viksit Bharat is resource constraints. As we grow and the population increases, there is a strain of resources. We will result in food and water scarcity, including groundwater problems, rare and critical mineral scarcity, limited resources. So this is another challenge in terms of the resource constraint. And third, in terms of longevity and viability of life. So today we have a demographic dividend in terms of our young populations, but by 2047, we will be having an aging society, and therefore advances in healthcare focusing on even prevention are extremely important. And finally, for transforming lifestyles, transportation, housing, environment, pollution, digital connectivity, role of artificial intelligence also, becomes extremely important. So these are some of the challenges which are facing the country, and we need technology, we need solutions and products which can address these. And some of them I have shown here, which are only representative. But the fact remains that we need to focus on technologies which will address the problems of our society. We need to have a resilience, innovation, socio-economic welfare, and competitive advantage we have to take in order to develop our technology and engineering solutions. Now, with this goal, the government, working as a whole of government engine, took certain initiatives. Two of them were most important. One was the institutional initiatives, establishment of the Anusandhan National Research Foundation, and the establishment of the Research Development Innovation. Now, both these initiatives are based upon the previous challenges that I found, that I mentioned, that research is concentrated only in few institutions. The translational research is not happening. Private sector spending on R&D is limited, and both these initiatives are basically, trying to address that structural gap, and I will just mention about that. So ANRF actually came out of, as a recommendation of the National Education Policy, and the National Education Policy has emphasized that in order to bring our tier 2, tier 3 universities and institutions into the R&D ecosystem, it is important to create a national research foundations, and that is why the ANRF Act was notified. The government of India has contributed 14,000 crore, and the governing board of the ANRF is chaired by the Honorable Prime Minister. Now, it has four broad objectives. One is boost R&D in state universities and colleges. And I must tell that ANRF had launched a program called PAIR, and under the PAIR currently 7 hubs are operating. which is catering to about 50 state public universities, and 800 crores of budget has been allocated under that prayer program. Second objective was to unify the India's fragmented research ecosystem. Third objective was to drive some mission-focused research with national priorities. And national priorities I already outlined, in terms of the challenges, the three buckets of the challenges that we are facing. And fourth objective was to bridge the academia industry gaps. The next structural initiative was the establishment of the Research Development and Innovation Fund. Now, as I already mentioned that the private sector spend on R&D is extremely limited in our country, and that is also one of the reasons for the weak industry academic linkages. Now, what has happened is that our industry typically has shied away from investing in cutting edge R&D, barring few exceptions. There are of course many exceptions in this area. Many corporates and industries are investing, but barring few exceptions, by and large, a large section of the industry has not focused on the cutting edge R&D. And one of the reasons for that is that the cutting edge R&D requires patient capital, because most of this R&D is risky, has a longer gestation period, and obviously therefore industries which are for-profit businesses do not want to take that risk over a longer period. And that is the reason the government thought that in order to mitigate these initial risks, the government can take that risks, and therefore a 1 lakh crore corpus fund was set up. Now, this fund is not just for investing in the startups. This fund can also be given to the corporates, established corporates, listed companies. For them, of course, it will be a long-term, low interest rate loan, like very low interest, like 3% interest, 10 to 15 year of tenor, and without any security. The only thing is that this fund will be 50% of the total project cost. The 50% of course has to be given by the industry from own sources or raised through the private investors. There is an equity support, and the equity can be taken up in the deep tech startups, and there is a hybrid instrument also, including convertible options. Now, these are the 6 priority sectors have been identified, and again, these sectors have linkages with the focus on critical technologies which are required for achieving the goals of the Viksit Bharat. So this is AI for Indian applications, deep technology like semiconductor, robotics, quantum space, biotechnology, energy security, transition, climate actions, digital economy, digital agriculture, etc. Now, this fund will be channelized through the second level fund manager, but we in the beginning itself onboarded Technology Development Board of DST as a second level fund manager, and they have already selected 22 companies, and a snapshot I'm giving here. So there is this company in the energy sector, which is the startups, TRNL Energy. In the semiconductor design, Big Indian Semiconductors. In the space area, Galaxy. In the biotech, Peptris. And there is a listed corporates, which is the Tata Group company, Tejas Networks, for developing the 6G technology. 250 crores have been approved, and this is the E-plane company in the area of electric mobility. So almost 2,000 crores have been already earmarked for these 22 companies which have been approved for funding under the RDI. And as I mentioned, that 50% of that project cost has to be raised from the other private sources. So we are hoping that investment by the 1 lakh crore, which will happen over a period of 6 to 7 years, will catalyze 6 to 7 times the private sector investment, either through the venture investors or through the industry, and that itself will enhance, the spending of the private sector on R&D, and thereby increasing, their share as a percentage of the GDP, our share. So, this is really the reforms which the government did in order to enhance the participation of the private sector in the R&D. Now, I will talk of some of the sectoral initiatives that the government took in some key priority sectors that we have designed across, ministries. So, one is like the cyber physical systems, green hydrogen. So cyber physical system was by DST, green hydrogen mission by MNRE, mission biopharma Shaktis by DBT, national quantum mission by DST, India AI mission by MIT, supercomputing mission by DST and MIT, semiconductor mission by MIT, mission Mausam by Ministry of Earth Sciences, and again deep ocean mission also by the Ministry of Earth Sciences. And in the next few slides, I will sort of briefly talk about each of them. So quantum mission is about 6,000 crores. It is steered by the Department of Science and Technology, but other ministries like DRDO, ISRO, and MIT, they are also participating. And this mission will focus on the 4 verticals: quantum computing, quantum communication, quantum sensing and metrology, and quantum materials and devices. So 4 thematic hubs have been set up at IIT Bombay, IISc, IIT Delhi, and IIT Madras. But about 43 institutions across the country are involved in 17 technical teams. The mission has also supported 22 startups actually. And given the fact that so many researchers are involved, this can be considered to be one of the world's largest coordinated quantum R&D ecosystem program. I would talk about 2 emerging quantum startups which are backed by the National Quantum Mission. One was the QNU lab, which has recently demonstrated a 1,000-kilometer QKD link, and another one was a QPI, which has demonstrated 25-qubit superconducting quantum computer, and their 64-qubit quantum computer will be launched soon in the market. So these are the 2, and substantial investments by the National Quantum Mission has been done, I mean, of the order of 20 to 25 crores. Now the AI mission is about 10,000 crores mission, and it is focusing on making available the compute infrastructure, the India AI Coach, which is making available the data set platforms, the future skills for the talent, and the foundational models. And one of the important foundational models which India AI mission is supporting, and which was seeded by the DST, is Bharat Gen model, which is building multimodal AI models supporting 22 official languages, and that has both the text model, the speech models, and also they will have the video model as well. They also have Bharat Data Sagar, which is India's largest open data set ecosystems. In electronics and semiconductor manufacturing, India Semiconductor Mission has done well. It has, 10 semiconductor fabs were approved in ISM. India Semiconductor Mission 2 will be soon launched. It is yet to be approved by the cabinet. The expected cost is going to be more than 1 lakh crore rupees, but once the mission is approved, then only we will know the exact cost. But its objective is to focus on the deep tech ecosystem integration, local IP, and also the equipment supply chains. While the ISM-1 had focused on creating the semiconductor fabrication facility. In space, India has emerged as a very successful nation, but the most important aspect in the recent years is that we have opened up for the private sector, and there are extremely good startup ecosystem has come up, which includes Agnicool, Skyroot, Pixel, Dhruva, some of the leading, startups. In terms of health tech revolution, as you know that we are the third largest pharmaceutical producer by volume and the world's largest vaccine producer. Recently, a MedTech Mitra initiatives, which was, Niti Aayog recommended an ICMR CDSO initiative, which is actually supporting the startups in the MedTech innovations. Now, biomanufacturing ecosystem is rapidly evolving. Our bioeconomy was just 1,000 crore in 2014, which is now almost has crossed 16,000 crores. And this is an important area to address the problem of resource constraint, particularly in terms of food scarcity. In fact, this example just shows that given our cattle count and the availability of the land and the growing populations, it will not be possible to fulfill the demand of the milk, for everyone. In fact, only currently we just have about 459 grams per day milk availability, while the requirement, the healthy requirement is about 500 grams per day. So rising demand and cattle shortage will need bio-based dairy alternatives, and of course biomanufacturing is also important for carbon capture and utilization, agri-food, clean energy and biochemicals. The clean energy initiatives have been focusing on solar mission, smart grid, the green hydrogen mission also has been launched by the MNRE. Deep Ocean Mission and Mission Mosams were launched by the Ministry of Earth Sciences. The Deep Ocean Mission will focus on the critical mineral recovery from the ocean floor. So, and also, on the ocean thermal energy, and these are really two important areas, from technology sovereignty perspective for the country. In digital communications, of course, we are one of the fastest 5G deployments in the world. We have about, our mobile data consumption is about 33 GB per month per user, which is the largest in the world. Even, in countries like China, the data consumption is close to about 25 GB per user. The indigenous 4G, 5G stack was developed by TCS, CDOT, Tejas Networks Consortium. And as I just showed earlier, that we have the RDI funding has been given to now Tejas Networks for developing the 6G technologies. So in conclusion, I have to say that while we have done very well in the last 10 years in terms of very high quality research publications and patent filings and the number of PhDs being done, there are still some challenges remain, and these challenges are in three parts. One is our translational research outcome is low, and public sector spending is high, while the private sector spending on R&D sort of remains low. Research is also concentrated only in a few universities and institutions, which needs to be expanded so that our overall productivity increases. Now, government has implemented both institutional and sectoral reforms across various fields in the last few years for building a world-class SNT ecosystem, advancing through the strategic investments, strong collaborations, and a globally competitive research framework. These initiatives are also towards empowering talent and innovations. The sectoral focus is meant for accelerating disruptive technologies, whether it is AI, quantum, semiconductors, green hydrogen, etc. And finally, as I mentioned that we need to leverage the innovations to address both the areas of sustainability and fragility, resource constraint, and the transforming lifestyle. So we have to leverage innovations to address climate change, resource efficiency, and many of the urban challenges while ensuring the inclusive growth. So our vision for Viksit Bharat is to emerge as a future-ready, self-reliant global leader, which is driven by science, technology, and innovation. And many of the efforts which the government, by working as a whole of government engine across ministries, has been working towards that. And we hope that in the coming years, some of the initiatives which the government has taken will start showing, results in the coming years. So thank you very much for listening to my talk. I don't know if there is a time for taking some questions, then I will be sort of happy to answer. If there is a.
Thank you, Professor Karandikar. Can you hear me?
Yes, I can hear you.
In fact, being from remote, we have not kept the provision for asking questions. While I must say, I truly appreciate you found time to join from Delhi, while we would be even more happier if you were here. But notwithstanding, maybe next time we can take that promise from you, and we'll have the memento delivered to you. What I found during the day, of course, the rest of it being fine, but an exceptionally well startup ecosystem has been collected within the campus, and many of them are truly doing something extremely good. So obviously your memento, will have it delivered to your office. Thank you so much.
Thank you.
I think suffices for me to say gratitude from INAE that you found time. Thank you so much.
No, my pleasure. Actually, I should have come there. I wanted to come, but
so your position allows that we accept it.
Thank you.
Thank you so much.
Thank you. I'll take it.
नहीं जुड़े हैं वहाँ पे
चेक करो।
हाँ मैं
Good evening, ladies and gentlemen. Another 5 minutes, we expect Dr. B.K. Das, DRDO, to join us online for his talk. Kindly be patient. Meanwhile, you can take a water break or a bio break. We have just about 5 more minutes. Thank you for being patient.
वैभव कहाँ है? वैभव कहाँ है? हेलो? कहाँ? किसको? हेलो?
हम आयुष शर्मा को कॉल किए उठा ही नहीं रहा।
सिब्बा इधर आ। ये तो वीआईपी को नहीं करोगे ऑर्डर ही दोगे है ना? मुझे स्टूडेंट से बड़ा हो गया तुम लोग। सर हम लोग ऑर्डर्स नहीं दे रहे, हम लोग सुबह से काम नहीं कर रहे। हर सुबह नहीं हम नहीं कर रहे।
कर रहे हैं बात आ गया सर।
हाँ ऑनलाइन आ गया उस साइड में भी तो लगा
ये देख रही है स्लाइड नहीं आया, डुप्लीकेट करो, स्लाइड नहीं आया, बता दिए सर, डुप्लीकेट करो, सेम प्रोसेस आ गया ना, डाउनलोड लास्ट कर दो उनके प्रॉब्लम आपके पास में आए।
Good evening, sir. It is now my privilege and honor to introduce to our next pre-dinner distinguished speaker. Ladies and gentlemen, it is my privilege and honor to invite our distinguished speaker, Dr. Vinay Kumar Das, Director General, Electronics and Communication System, DRDO, Ministry of Defense. We are delighted to have you, Dr. Das, with us during the evening and eagerly looking forward for your insightful address.
Can I go ahead?
Yes, sir.
Namaskar, Jai Jagannath, Bande Utkal Janani. I think it's my love and regards to everyone out there for this great program. At the outset, my apology that I could not reach in person. Probably this is first of the program in Odisha which I missed because of some pressing reasons. So maybe next few minutes, I'd like to go through the topic, the changing warfare and India's preparedness with opportunities for academia and industries. If you really look at the current system of international scenario, the geopolitical scenario, it is ever-changing. I think leaving India aside, it's war everywhere. Whether it is Russia, Ukraine, we talk about Iran versus Israel, the US and Azerbaijan and whatnot. So everywhere there is war happening, and I think this is the right time for India, who is a master and pioneer of peace, to understand from the war, learn from the war, and have its own preparedness to master the technologies and the systems which can prevent war. Because India is an icon of peace, but like we always say, strength commands strength. So we need to have those technologies, we need to have those weapons, we need to have those mindset that we are able to be a global leading nation who can really master the peace and with that at the expense of the technology. And probably when India masters peace, it can drive world peace. I mean, that's the reason I thought I'd make a topic that how this changing warfare is making India prepared. We have been in DRDO all along. You are all aware the kind of systems and technologies we are developing. I think you all know. I'm not going to talk more on that. But of late, if it is still in your memory of Operation Sindoor, has been one insignia of what a country's defense can do to protect its sovereignty. It has happened at the 11th hour, but the country was absolutely prepared. And it's one of such kinds where the weapons which were used in this warfare were designed by DRDO, developed by Indian industries, produced by our industries, and most importantly, trusted by our armed forces for protecting India's sovereignty. Whether it is Akash NG, whether it is BrahMos, whether you talk about anti-drone systems, all of them are designed, developed, and deployed for its protection. This shows that India is one country who is absolutely prepared and ready. And remember, friends, leave aside any other deployment. When a weapon is deployed for the war, it is the most critical because war is such where it's only the champion who wins and runners-up has nothing, it has to perish. With such kind of a fine criticality, when a country trusts its own designed weapon systems, that not only shows that we are up to our Honorable Prime Minister's mission of Atmanirbhar Bharat. More than that, we are marching towards Vikshit Bharat. The fine difference between the two, when it is Vikshit Bharat, our economy has to be strong. Our systems has to be trusted by other part of the world rather than our own country alone. And such thing happens. I have seen the live of it, that when Upsindor happened after that, multiple nations are after BrahMos. You might have seen with Philippines, with Indonesia, and what all are happening. So which means a country trusts the weapon systems, because when a country deploys its own weapon systems for its sovereignty, that means that is the best. So India has come to an inflection point, the changeover paradigm wherein our economy is commanding, our technology is dictating terms, and our war preparedness shows to the rest of the world that the peace first comes, world will be beautiful. With these words, I'll just give you a quick defense odyssey of just a capture of what happens. If you look at Russia and Ukraine war, the entire disruption of the Ukrainian Viasat satellite network, it has happened by Russians through only electronic means. Friends, First World War was all about tank. The Second World War is about the air power. The today's fireworks are entirely going to be electronic dependence. It is the spectrum congestion, it is the spectrum dominance which is going to define the future state of the world. How we are jamming each other's satellite, how we are spoiling each other's cyber network, and how we are controlling from remote from the war room that the entire data sets gets completely choked is going to be the new paradigm of the world. And the similar such things happened when we had the entire command and control regime and the GPS navigation was jammed. You might be knowing that today every missile's navigation works with GPS and INS, and when GPS gets jammed, the missile becomes haywire. So these are the concerns. So we are learning, we have a takeaway that how we work future to protect our systems with anti-jamming facilities, with anti-denial, anti-access, with the new GPS systems, which is spoofing. All those kind of applications are going to define for the future world. There are a few more things. Malware attack on the satellite modem has been another critical one, which has happened during the Russia-Ukraine war, and also the Russia's complete counterplay for the frequency jam. So essentially, electronic warfare is the new normal for any war which is happening in future. Counter to that, you would have all seen Ukraine, how they have come in a counterattack. I think prior to Russia-Ukraine war, we all thought drone is only illuminations in the sky for the Olympics inaugurations. None of us could think drone could be an attack system. It is this war which has demonstrated that a tiny drone can make a T-90 or T-72 defunct with a top attack. Kamikaze role of the drone has become paradigm significance in this particular war. And of course, after that, like mushrooming, multiple industries are coming up with lots and lots of this drone attack happening. Shaheen is another thing you might have seen in the Iran war, how it has become so popular, the Shaheen drones. So these are all, again, if I take another statistics of Iran versus US and Israel war, if you look at, there are also the essential typical issues was the multi-vector saturation strike. See, approximately 170 Shaheen have attacked. So this is called saturation attack. See, today we have been developing so much of the ballistic missile defense. I think ITR is next door to you. I have been a director there where we have conducted so much of the missions of ballistic missile defense, wherein a target missile comes and an interceptor can kill it forward. But actually, those days are gone, because in the current paradigm of the war, even if one missile neutralizes another missile, practically both the nations lose, because both of us lose two missiles. And it's a war of economy. It's a war of prolonged warfare. And it is a war which is going to define who is economically strong. So that's the reason this drone attack has come in as a low-cost solution. Directed energy weapon has come in as the next set of low-cost solutions. Just I wanted to explain you the perspective from various systems. Radar is just one example. That this spectrum control is becoming more and more important than the platform superiority. Electromagnetic spectrum is the sixth domain of warfare. We know land, sea, air was the first three domains. Space and cyber has become the fourth and the fifth dimension of the world. And today, electromagnetic spectrum has become the sixth dimension of the world. So that's the reason. Artificial intelligence-driven cognitive emission control and how we have an agile shift in the frequency so that the missile which comes with a specific frequency attack will lose the sight is what is going to define further for the future warfare. So like that, there is a series. The stealth has come up. All that F-35 we are talking about in the stealth aircraft. So we have to develop radars which has to track stealth targets, which means we have to go to such frequency band which radar does not exist today, whether it is VHF, whether it is UHF, whether it is integrated passive coherent location, whether infrared search and track systems. You might have seen in Iran war how that F-35 got destroyed silently without even them knowing about it, because they were not tracked by any radars. Because if the radar tracks, you know the signals, you can fire the missiles to kill it down. But it was tracked by absolute passive infrared search and track system. So this is the kind of technology migration which is happening throughout. So friends, when I was talking about the new paradigm warfare is going to be HPM, it is called the high powered microwave. These are the silent killers. They are not the missiles, they are not the gun, they are not the ammunitions. They are absolute high powered microwave, which we pump it across towards the stealth drone attacks, towards the swarm of drone attacks, that all of them get nullified within a fraction of a second. Now that's going to be the new warfare paradigm, and India is very, very strong going about it. On a public media, I can't talk more on this, but be sure that these are the niche technologies. We are one of the top 3 countries in the world who are mastering these technologies. Now looking at the battlefield, actually, the entire new battlefield is digital. The center of gravity is shifting towards software and electronics. As I said, electronic warfare, cyber operations. You have seen the Venezuela president story. That few seconds that power was up, generator was out. By the time the triple generator comes up, in between the cyber blind has happened and the president has lost his place. So the story has become so fast that the cyber can make everything blind and win the war. Autonomous systems is going to be the new normal. No more the piloted systems are going forward to decide the war. We are going to be unmanned aerial vehicle in the sky. We are going to be the fighters which are going to be unmanned. The tanks are going to be unmanned. The array of drones who are going to make an unmanned attack. So that's going to be the autonomous systems for the future warfare. And the most important part is the multi-domain operations. See, today it is a network-centric warfare. It is not a land-based, sea-based, or air-based. Land, sea, air, space, and cyber. This pentagon integrated together, and that entire conclusion of the weapon systems and the enemy attack is going to decide the future course of warfare. Friend, another very important point is the saturation attack. I was just mentioning a few minutes back that these days drone has become the current threat. Yes, one drone comes, you can always put it down through a missile or put it down through an ammunition. But let us say swarm of them, hundreds and thousands of them come attack. How many of them you can keep firing back down? So that's called the saturation of the world. But again, from 2019 to today in 2026, the technology has changed. No more that we trust only missiles alone to secure our affairs. Today, it is going to be the directed energy weapons. Friends, the lasers have become the powerful weapon. In childhood, we used to put that lens or niche rui laga ke surya kiran ko dal ke aag jalate the, and we feel happy about it. Today, that has transformed into a technology reality. It is just other way around. We are creating the laser sources. We are pumping the laser power through a fine beam, and we are adjusting that fine beam pointing towards the missiles, pointing towards the satellites, pointing towards the drone to create that fire and neutralization. This is called the absolute low-cost neutralization systems called directed energy weapon. India is one of the global leaders. We are doing quite a bit of work. You might have seen in the literature, the 2 kilowatt systems has already been deployed, which was used during Operation Sindhu. In the meantime, we have developed 10 kilowatt systems and 30 kilowatt systems as one of the global leaders. We are going ahead with much more kilowatts. I can't speak much here now, but definitely be assured that our country is committed, our scientists are dedicated to develop one of the global leaders in directed energy weapon. Electronic and cyber attack, I have already told you. Killer satellites are being designed. These satellites are being deployed in the space, and at the time of protection, they themselves become the attack module to the foreign satellites. This is the kind of a transformation in space warfare which is happening. Of course, we have got some ethical challenges, certain legal challenges. We cannot have a proximity of 2 satellites so nearby. There are certain international rules. We need to follow all of that. So the weaponization of the outer space has become the new normal. So today, I explained you about the lasers which are being fired from the ground to the space. But today the situation is different because the laser is being fired from satellite to satellite, so that the space is minimum and the attack is maximum. So that is the new future which has happened. So space-based electronic attenuations, robotic arms, which I explained you a few minutes back, co-orbital anti-satellites, which I told you, going on, and hypersonic missile defense and the cyber these are the attacks for the future. So friends, if I throw upon the challenges is for the space qualification, maintenance of the space affairs, and replenishing the consumable stores and resources. So that's very important one I want to tell you, which we often use it in our war field. It is called a famous OODA loop. If those service people who are listening to my talk, they will appreciate it much more. This is the decision-making edge. The OODA is the acronym for observe, orient, decide, and act. So these are the 4 phases of any warfare. Observation is through the ISR and surveillance, through the sensors, through the signal intelligence and battlefield awareness. Orientation goes in when we do the computation and decide that there is some attacks happening. And the decision is to decide that we are going to kill our enemies. And act happens when we practically launch the missiles, the lasers, the high-powered weapons to kill our enemies. So most important happens to be surveillance. We call it as the eye of the loop. India is absolute global leader today. You talk about the radar systems, right from submarine to the space. We have got the capabilities, we have developed, we have delivered, not only to our country, to the rest of the world, the next generation radar systems. Electronic support measures, wherein we get the electronic surveillance, happens to be the next set of surveillance systems. And of course, electro-optics and infrared systems happens to be the third set of surveillance. So this does the OODAs, the first O is the observation. Sorry. So if you look at, this is one of the absolutely foolproof, fantastic product which we have developed. You'll be very happy to know. In a record time of 24 months, right from the designer's desk, this product had reached to the battlefield. We are so proud of this product called anti-drone systems, which has been the soft kill and the hard kill and the layered synergy weapon systems. I'll explain you just 1 minute on this. Normally, when a drones come for your attack, you have to pump microwave to disconnect its link. That is called soft kill. So when it disconnects its link, it falls down. But many times the drones come with an autonomous attack. Even if you disconnect, they don't mind. They go for attack with kamikaze. That is where we use the hard kill option. The hard kill is nothing but kinetic interception using anti-radiation missiles, or it could be directed energy weapon through lasers. This has been an absolute success. Multiple such systems have been productionized and deployed, and multiple foreign agencies are after us for this technology. Of course, another domain I must touch upon is called AI and automation. Like I told you a few minutes back, artificial intelligence enabled recognition, autonomous systems, and predictive analytics are going to be the future course of warfare which we are defining. So like I explained you a few minutes back, space-based sensors and interceptors are the new normals. Persistent surveillance, seamless integration, emerging interceptors, these are the new doctrines for the warfare. This is very important. MSDF, multi-sensor data fusion. I told you a few minutes back that the number of sensors are spread around in hundreds across. Radars of various types, electro-optics of various types, infrared imageries of various types, they all come forward together to create a network of sensors. But imagine, when we are in a war room, can any human decide out of 100 sensors which is right? It is impossible. So is the fighter pilot. Fighter pilot has got active electronic scanner radars, it has got infrared search and track system, it has got missile approach warning systems, it has got electronic surveillance systems, whatnot. All of them in a split second it cannot decide. So to help the pilot or to help the war room, what we conclude is called the multi-sensor data fusion. It fuses the multiple data, extracts the best with the intelligence. It helps us to really define which is our target of interest. So friends, the future normal is going to be Internet of Military Things. IoT, you are all familiar with. Today we are working on Internet of Military Things. So there is a network of interconnected devices and systems that are used in military operations and the warfare. So this is based on the idea that the future military conflicts will be dominated by the cyber warfare and the machine intelligence. So networking of sensors with intelligence backend and concluding to the systems is what IMMT is going to define for. This is just a topic I want to touch upon. Time is limited. I can't explain into very details. Just to give you one example, I have made the country's first AIC radar, which is going for our fighter aircrafts. But believe me, friends, it has taken me 5 years to make the radar and another 5 years to prove it. The reason being, every time we need a fighter aircraft to integrate it, test it, fire it, conclude the data, again change the algorithms, time takes phenomenal. Today, neither we have time nor we have so much of assets. So that is why the whole model is going to digital twin. We create a virtual representation of our product or the systems that makes us to understand how it works under environment. It operates continuously under real-time data, and every component, product, the interface control document, they all exchange with each other, and it gives you sufficient confidence how it works in the space. Of course, finally we have to fly it on a fighter aircraft, but the number of flights becomes limited and delivery becomes faster. So like I said, future is going to be autonomous. The entire air defense and the space integration is going to be autonomous. Space-based defense, autonomous platforms, and a network ecosystems are going to define the futuristic warfare. So that concludes as a smart C5 ISR. You know, C5 is the new normal, again, command, control, communications, compact, and conclusive cyber, and then it is intelligence, surveillance, and reconnaissance. This is what we call C5 ISR. So this together is a summary to how it drives our situational awareness, data analytics, and it gives a data-driven information for the decision-making for the futures. Friends, a very important point, having talked so much about warfare, today, technology security is the national security. Let me tell you, we have developed a class of systems for the defense, we have cybersecurity intelligence, we have critical communications, all of them are with us. But the country who masters the technology is going to lead the warfare. Yes, we may be buying multiple systems, we may be importing so many systems from US, from UK, from Russia, from whatsoever, but nobody gives you technology. They just give you the product and to use the product. That's not how India can grow. If India has to grow, technology has to be designed and developed in India, and we have to have a technology security that our technology should not go out. So just to give you an idea of the 4 dimensions of the sovereignty, so the design sovereignty is critical unless we have designed a system. We cannot be a global power. Technology sovereignty, which I explained to you now, unless the technology command is with us, we can't be a global power. But the third one is very important, supply chain sovereignty. Because any system you develop, there will be number of suppliers who will develop multiple subsystems of that system. Now, when we need in numbers for the warfare, if one particular supplier cannot deliver that system, then our system cannot be complete. Similarly, out of a complete system, if one block you are importing, for example, an infrared camera, right from optics to electronics to everything we do in India, but the detector comes from abroad. For some reason, in the geopolitical scenario, the detector supply is choked, then our camera is nowhere. So what I mean, Atmanirbhar Bharat does not happen only with a majority percentage. Atmanirbhar Bharat happens when all critical systems are designed and developed in India. This is the third part. And the fourth part, most important, is the knowledge sovereignty. Knowledge is power. And when we have the knowledge, even if our technology is stolen somewhere, we can build the next generation technology to defy that. So this is how India should go forward. So this is the engineering India's next decade is the semiconductor ecosystems. You know very well, Odisha is coming up in a big way. I think Gujarat is having a lot of good things because semiconductor is the last mile which we want indigenization. Artificial intelligence systems is the next one. Advanced communication is going to define the future warfare. Aerospace and defense is most critical. Energy transition, this is very, very important. Smart grids, renewable energy is going to be the new normal. And of course, the healthcare technology. Quantum is the next strategic frontier. We are working so much on quantum. Quantum communications, quantum sensing, quantum-based radars, they are going to be the new normals, the gravimeters, the magnetometers, the atomic clocks. These are all being developed by our country. So quantum and photonics are going to dictate the next generation electronics in future. 6th generation communications, they're building the new intelligent network. Terahertz technology is going to be critical for the future because when the current band gets short, we have to go to 10 terahertz or beyond to really work towards an absolute jam-free environment. So these are an AI native network architecture. These are the technologies for the futures. So convergent machine, I've already explained you. Sensors, communications, control, and AI together, the 4 integrated components for our autonomous systems. Sustainable electronics, this is the engineering for the planet. Friends, whenever we're working on so much of the technology, I told you a few minutes back that energy is becoming critical. So energy efficient computing is most important. Data centers, who draw so much of the energy. We were thinking, can we have data center in other planets so that we will really take the solar power to run it forward? Green manufacturing is going to be another very, very critical thing to reduce the chemical, water, and energy footprints of the semiconductor fabrication. And circular electronics economy. These are critical 3 aspects for sustainable electronics. Now, let us think what are the opportunities before India. The trusted electronics, India is one of the global leaders. AI-enabled embedded systems, the brain is here. Affordable innovations, I think all innovation guys are here, and the next generation talent. India is a talent pool, 1.4 billion people. If they all get focused to build a new India with the mission that we will not leave this country, we will serve for our country to make it as a global superpower, India is going to be a great country in the future. So for the national capability development on the Indian context, I think the academia and industry collaboration is a must because we work in silos, we work in isolation. So today, academia does a lot of research, they publish a lot of papers, but then they don't have a product in their hand. Industries seek for products, but they don't have the research input to work forward with. DRDO works with so much of the research, but that matching with academia and industry has to happen. So friends, this collaboration is going to create a new normal for our country. We have to have lots and lots of semiconductor ecosystems coming up. I think India will go forward very strong. The future research problems for the academia, those who are listening to my talk, just to trigger to you, cognitive radar and EW co-design is going to be the very big problem, which the country looks forward to. Nowhere in the world it exists today. AI native RF signal processing, it's really a research question. There is so much of RF signal processing we need to do, and spectrum situational awareness is another very critical topic which academia should focus on. Distributed MIMO radars and photonics RF front end, this is another very important topic. Quite a bit of work we have done on photonics already in the front end. MIMO radars, we are working very strong. I welcome academia to work on this domain and work with us. High-powered microwave, I explained you a few minutes back how this direct energy weapon is becoming the new normal for warfare. So coupling and metamaterial apertures, wherein the same antenna being used for multiple frequency for multiple operation called shared aperture systems is another technology which we look forward to. AI-driven EM simulation and joint radar communication waveform design and EW resilient navigation. Actually, friends, each of them is a topic by itself. I can talk hours, but within the paucity of time, I just thought I'll just give a flavor of it to our academia. Whoever gets triggered, you should really work on it. Just giving a small mark to my last part of the talk, we are going to a strong defense decade of India. Look at our defense budget in 26-27, it is going to be 7.85 lakh crore. And our defense exports up to 38,424 crore. These are only statistics. I don't believe not much on this. But what is showing the trend is India is going up. It is an up power which is rising defense budgets and R&D investments. Our IDEX, our development come production partner model, the technology development fund wherein we are encouraging up to 50 crores and even certain cases up to 500 crores are sanctioned and 80 projects worth 334 crores are running today. Our DIA-SOAs, we call DRDO Industry Academia Center of Excellence. They're running absolutely good in 15 centers today. We are also thinking for Odisha, but today already all 15 centers are doing excellent jobs today. Yes, a lot of reforms are happening, whether we talk about DAP 2020, whether we talk about DPM 2025, DAP 2026. So India is on a reform, DRDO is on a reform for all these things. So these D&D opportunities, if we look at for Indian startups and industries, then as I said again, just to sum up, net-centric warfare is the new normal. A lot of industries are coming forward to work. Indigenous IP mandate, I think our policy has to be strong for our own IP. Multi-domain operations, I said already land, air, water, and cyber and space, we are going forward to, and autonomous systems. So if we look at the startup and industries, these are the opportunities for all of you: AI and autonomous systems, surveillance and ISR, electronic warfare, secure communications, space technologies, cyber and trusted electronics, and defense semiconductors. These are the opportunities for startups and industries. Of course, there is a great export strategy, and why India is moment for now, because there are countries who are looking up to India. Just to give you a summary, in the Asian region, it's Vietnam, Philippines, Indonesia, Malaysia, high entry points, software-defined radios, unmanned aerial vehicles, avionics, radar, LRUs. These are the real export products apart from missiles, BrahMos, anti-drone systems, so on and so forth. If you look at Middle East today, UAE, Saudi Arabia, Oman, there is also a very high entry point. Electronic warfare systems, surveillance, artificial intelligence mission systems. If you look at Africa, there are a lot of coastal surveillance and communications. They are not so advanced, so they are not going into such next generation technology. But I have got a lot of programs, bilateral programs with them, with Kenya, with all those Nigeria and all of them. So they are really looking forward to lots and lots of technology from us. South Asia, Sri Lanka and Bangladesh, Nepal, they are our next door maritime neighbors. So surveillance and mission systems they look forward to. And Latin America, Brazil, Chile, Argentina, all of them are emerging today with UO payloads, radar electronics, so on and so forth. Why I'm giving you this concluding slide with an export orientation is, friends, If we want to be a global superpower, if we really want to prevail peace alone, we have to be economically strong. And this strong economy will happen when it happens to export. Atmanirbharta is only one step. We have to have exports. And this is the export opportunities. And when export opportunity comes in, today foreign countries look for technology, look for such game-changing systems. So all these, my academia, my industry friends, all of them should put together, we should work together to go forward for building a great country. I always say, friends, if I say India, INDIA, you know what it stands for? India is built with 5 pillars. The I stands for industries. Today, India is built with industries. The N stands for the nascent forces. The nascent force is our startups. They are our strength. Young, tiny, 20 to 23-year kids, they come forward to me with such great ideas, even which we can't think of. So an Indian brain is thinking what youngsters with such kind of a firepower, it shows where India is going forward to. So that is my N. What does D stands for? Obviously, it is for DRDO. We are the people who are working on the next generation technology to build the next global defense power for this country. And what does the further I stands for? This next second I stands for the innovation centers, the innovation hub. The India lives with innovation today, innovation in incubation center, innovations through the schools, colleges, innovations to my students. And finally, A, the A stands for academia. All our knowledge comes from our academia. So these are the 5 pillars of a country, India, and India rests on this. Friends, if we have to build a new India, if you want to build the great India, if you want to build an India which is second to none, all of us have to be committed only on one thing. We 1.4 billion people have a dream to trust our energy within, to trust our power within, the hunger in our stomach to make something great which nobody in the world could do. India is set to take the world to the next level. And when India becomes powerful, the peace prevails, because India is a country of Gautam Buddha, who is the pioneer of the peace. So we all work, friends, to peace, global peace, love everyone, love humanity, and take the country forward for a global humanity. May God bless you. Thank you so much. I think I just took 30 minutes that was allotted to me, but any interest happens for the future, I'm always there and available. My namaskar to all of you. Thank you so much. God bless all.
Thank you, Dr. Das. Pleasure listening to you as always. That passion-filled Dr. Das I know. So it was absolutely pleasurable to hear you today. And although you took us, I know this talk you could make for almost 2 hours. Every element you know out of what you were talking. We certainly will continue to draw on your expertise, your specialization. Look forward to doing more and more things between DRDO and INAE. Thank you so much. We will have your memento sent to your Delhi office. Locally, that would be better. I know you'd be twice a week in Delhi. Thank you so much.
Thank you so much. My love and regards to everyone. All the best. God bless you all. Thank you.
Thank you all for your gracious presence and active participation throughout the day. We sincerely appreciate your valuable time and contributions. We look forward to welcoming you again tomorrow. The program will commence sharply at 9:30 a.m. and we request everyone to kindly be seated a few minutes in advance. Have a pleasant evening and thank you. We have a bus waiting outside, so those who want to attend the cultural program, it is followed by the dinner. So please, there's a bus waiting outside the venue, near the PNB Bank. Thank you. I request everyone to please come along for the cultural program and the dinner. Sorry? So the venue is Hotel Prachi Sarovar Premier. Prachi Sarovar Premier. So we'll be going by the bus. It's waiting outside. Yeah.
सर अनाउंस कर देले तो हमर गाड़ी लागि गेलानी बोली गाड़ी को जगह रहला एपट लगिस्ता हां कहि दैछन तो बैक साइड ना हां समस्त बस रे जे तो हां ठीक है